Hey, hey, hey! We're back again with another show, another chit chat show titled Any Globe Proofs. And let's see who we've got in the chat. Let me pop out the chat first. Where are we? Let's pop this out and bring this over. Let's see who we actually have in. So, currently we have Christian Kuman. I see you in Nick Bill G. Yes, we do have a panelist this evening. Dale Ohio, Mason B, Howard Moore, Mind of God, nice to see you in. Rob Keane and many more, I'm sure, will join at some point. Anyway, we are joined by the Rumpus. Rumpus, how's it going?
Not too bad. I was having some little health issues for a few weeks ago, which still recovering. I think I had COVID as well, which I've got over now. But but I'm not too bad now.
You had COVID? Really? Seriously?
I think so. I think I had a flu about March of something, and then I got better from that, and then I can't be sure, but I think I then had about 2 months worth of feeling quite unwell through this COVID thing, and I had the loss of taste and everything for a week. But I can't be sure. But it seemed to me I caught it off someone who seemed to have similar symptoms, So I had all the classic symptoms of my chest and things, and lots of coughing, etc. But it wasn't awful. But I did have about 6 weeks feeling quite miserable with it, but I think I had flu as well beforehand. So who knows? But I didn't get myself tested. But I've never lost a sense of taste before, or sense of smell, so I presume that's so. Anyway, so the chances I haven't had it tested. I will eventually, because I want to go and see my mother and things shortly. So I was thinking of having an antibody test to see if I've had it, but who knows? Perhaps I haven't. But it seems rather weird that I had this thing that was had all the symptoms of COVID. But so who knows? But yeah, I wasn't very. So that was all banished about 6 or 7 weeks ago. But then I managed to do something else. But anyway, I'm okay now.
Okay, well that's good to hear. I have my own health issues. I was supposed to do the show yesterday. Unfortunately, I needed to contact my doctor yesterday because I had an issue, and he suggested that I went to the hospital. He said that it was an emergency. I needed to go up there, and they wouldn't see me. Basically, they wouldn't see me.
Really?
Yeah. They had me in. I was in there no more than probably 20 minutes. They brought me into this little room and they put me in front of a TV monitor with somebody talking on the other side. And they said, well, basically, as you're waiting to see the surgeons about this issue, essentially, there's nothing we can do because it's an ongoing problem. And I'm sorry that you nearly choked to death, and that you can't swallow and you can't eat food and shit like this. I know that's kind of an issue for you. It's a bit inconvenient, and normally we'd look into this, but under the current conditions, we're not going to be able to do anything today. So see you later, bye bye. I was like, what?
Right.
The doctor sent me up.
That's amazing. I must admit though, you're presumably aware, about a year ago, I decided to run down my stairs at 12 o'clock at night, and I fell down them and broke my bloody shoulder and things and dislocated it. And I then got to A&E. I initially rang up and asked for an ambulance. I said I've, basically ripped my shoulder apart. And they said, "Are you bleeding all over the place?" No, I'm not actually bleeding, but my arm's dysfunctional. I got sort of hanging about, and I said, "Oh well, sorry, we can't see you. We can't send you an ambulance, and you'll just have to make your own way there." And I couldn't drive, of course, so eventually I had to go and not get one of my lodgers to take me. That I had to wake them up at 1 o'clock in the morning. So I was a bit shocked by that. The fact that had I not had someone I could go and take me, I would have been. And they said, "Well, we'll try again in 8 hours' time." And with a dislocated shoulder, your nerves and things can be trapped, and it's absolutely essential you get immediate treatment. And even then, they were saying, "No, we're not going to come and collect you. It was too bad, mate," which I found shocking. So yes, I was shocked by that, and I'm now a bit shocked that you're even under these conditions with COVID, that they wouldn't. This was so you were actually in the A&E. You were actually at A&E.
Yeah, well, yeah. The doctor told me to go to A&E. He recommended.
And that's where you were when they said bye bye Ranty.
Yes, basically. Oh. Yeah, they sent me home.
Was it because of COVID? Was it because they worried about COVID infections?
Well, when I turned up at the front desk, they had the windows closed at the front, and the woman said to me, "Have you got a mask?" I said, "No, I don't have a mask." She goes, "Oh right, you need a mask to be seen. Let me just see if I can get one." So she goes behind, and she's sort of like rummaging in these boxes behind, where she's sitting. And there's this other woman. I don't know where she was. It was in the next cubicle or something, but I couldn't see her from where I was. Oh my, she was kicking off. She was saying, "Does nobody watch the television? Does nobody watch the news? Don't they know that when you turn up at hospital, you have to be wearing a mask? We are sick of this. We're going to have to put signs on the door that if you do not have a mask, you cannot come in." And I'm like, and she's telling us, this woman, obviously, so that I can hear this. And I'm like, my doctor's told me to come up. I'm sorry, I don't have a mask, but it's a mask at the end of the day.
You
it's
hadn't
not gonna...
planned for. So you hadn't planned for this, had you?
No, exactly. Jesus. Well, basically, what it is, I've had this lump underneath my chest. It started about a year ago, and it's been getting bigger, and it got really painful about 2 weeks ago. And I have noticed that when I've been eating food, I've had to take a lot of liquids, and I've only been eating half my meals for the past year or so. And it's getting down to the point now where I'll be given a plate of food, I'll eat maybe a third of it, and the rest of it will just be liquids. And I have to drink a lot of water or juice or milk or whatever to get anything to go down. And quite often, things get stuck on its way down. So it'll go down, it'll get stuck, I'll take some.
Yes, it sounds like you need some treatment, Ranty.
Yeah, well, this happened.
So why have you waited a year to do this?
Well, I don't really bother with the hospitals very much. I'm one of these old school kind of people.
Yeah, same here. Unless I've had some back problem, which has made my life a bit miserable. I had to have that dealt with, and things like breaking your shoulder and dislocating it.
But yesterday I just had a pie for lunch. I just had a couple of small bites out of it. Nothing big, just a couple of small bites. Took the third bite, and it got stuck, and I felt it get stuck. So I took some milk, thinking that the milk would wash it down. And this has happened before, that I've drank the milk, and what's happened is it's just filled up my pipe, and it's gone up above my window. I've been drinking, and
that sounds really serious, Ranty. It sounds like you've got obviously something wrong with your esophagus that needs sorting out.
Well, yeah, and basically I was choking to death on the yesterday after.
Quite serious. Yeah, Ranty, I think you. I'm not surprised that the doctor said this is an emergency. Yes.
Yeah.
I think you should take that quite seriously. Yes, I think you should.
So is this
make another visit? What do you mean they said? So when they said they couldn't do anything, people are probably not interested in this chat actually. But yes, but just quickly. So why did they say they couldn't do anything for you? Because it sounds quite serious to me. Is it because they couldn't do anything because of the COVID thing, or because they didn't feel as though there's anything they could help you with anyway?
The day before, I'd contacted my doctors and I first informed them about this. So I told him what I told you basically, and I told him a few other things that I've had. The size of it's like 6 inches long. It's about 3 inches wide. It goes up around about 1.5 inches. It's quite pronounced. This lump underneath my chest sort of thing.
But what was their excuse for not giving you some sort of investigative treatment?
Well, here's the thing. I spoke to the doctor and I said, look, I think it might be a hiatal hernia or something.
Yeah, it sounds like a hernia of your esophagus, yeah.
And then when I phoned him back, he said, well, this was the day before, and he said, right, I'll recommend you to the surgeons at the hospital, because it sounds like you've got a hiatal hernia that needs some kind of treatment. So this was the day before. It's the first time I'd spoken to him, so I've still not been diagnosed properly with it yet.
Indeed. But what was their for not looking into it at the hospital? Why did they say, was it just because you didn't have a mask?
Because I'd been referred. No, because I'd been referred the day before to the hospital to see the surgeons. So because that was in the pipeline,
you didn't qualify for any because you were on the list for having done something done for it, right?
Yeah, even though it could probably take weeks to get seen by them.
Yes, quite. I don't understand.
And I'm there to be seen.
There was an emergency. It doesn't matter whether you're due in for some investigative stuff in 2 weeks' time. You were having an emergency then. I'm sorry, I don't understand that. I think you have a right to. I think you should complain about that, actually. I think that's if your doctor said it was an emergency, it's irrelevant whether you've got an appointment in a couple of days' time. You needed treatment there and then, or at least an investigation. That's ridiculous.
Well, he said to me, look, it could be one of two things. He said, it sounds to me like he got one of two things. And I spoke to you yesterday, he said it could be hiatal hernia, or it could be something more severe than that. It could be a blockage. There could be something there that's physically causing a blockage on the pipe. So, in which case you would need to have treatment for that immediately. So we'll need to get you in there. And basically you need to go up, because if you're choking to death trying to drink and eat, because the milk's filling back up your pipe.
Yeah, exactly. It sounds really quite serious when you're having danger of. You actually sound as though you're in danger of drowning.
Yes, it felt like I was drowning. It was horrible.
Indeed, you were. When you have that, that's exactly. This is you're subjecting yourself there to the torture that that was banned in America. They used to use on Iraqi suspects, Iraqi terrorists and things to get interrogation. What's it called? Waterboarding. That was it.
Yeah.
And Christopher Hitchens put him through, where they actually just pour water into your mouth until it starts filling up your larynx, which is effectively what you were doing there. So yeah, I think you have every right to go get really angry with something, including that woman. Who was moaning about you? As you say, you hadn't planned to go in A&E that day. It's not like you were all able to organise yourself. You were. Well, that's quite potentially fatal what you were describing there. So yeah. Anyway, I'm sure we're boring everybody with our health issues. So we don't want to bore them stupid about this. I'm sure we've got some more interesting things to talk about. I hate it when these things start to become some sort of chit. Well, I suppose if you're talking about chit. Okay, you're describing as a chit chat, but
well, it is a chit chat, isn't it?
But when these things, I don't mind them being social, but sometimes these things can get less content and more social, and people get. I'm sure most people get bored with just listening to other people's social chit chat, unless it's sort of jokes and what I did on my holiday, falling off and got bitten by a shark or something. That can be quite interesting. But but other than that, I think probably most of the stuff just. Well, for me, some sort of cultural experience on holiday I think would be interesting, but it wouldn't be for most people. So yeah, but unless you're being savaged by a shark or bitten by an octopus or being beaten up by 17 people or taking the rugby club or something, then I think. Anyway, so let's get on before you. Well, this could be your last hangout, so you better get on with.
I actually took an image of it. This lump. I don't know whether to show anybody
Okay, Ranty. Now I really do not think that we want to bore or upset.
Yeah, let's not show that. Let's not show it. It's gross.
You'll lose about 100 subscribers.
Yeah, we better not do that. Right. Okay. So let's move on. So. What have you got for us, Rumpus? What have you got?
Well, I say I've got to the panel, to the people who this is. I've only just been accosted about this and suddenly asked to produce some proofs within 2 seconds, and I quickly made a list of what I've got down here. What were they? Let me just quickly go through them. I haven't got any. I'll say nothing prepared whatsoever. But let me just remind myself what I just wrote, and I've just lost it. Well, it's just. I mean, there's just ridiculous the amount. I mean, we have sunsets, sunrises, impossible on a flat Earth. The whole Earth would go black. There'd be no light because it's gone below the horizon. We know. I mean, I know the mind of God. When I accosted him about this, I think it was God was on this thing. I think some time ago, and he was saying, "I don't want to." When I said, "Where does it go when it goes below the horizon?" and he said, "Well, don't word it like that. I don't want to answer that question the way you've worded it. Rather commits me to accepting it's gone below the horizon." Of course, mind of God is also the chap who didn't understand that if something got further away. About a year ago, I had to explain to him about perspective, and he said, "Well, the sun just sort of gets further away." And then on being faced with the fact that involves the sun getting smaller, which is actually one of the other proofs here. If the sun's it's going to get further away, it's got to get smaller, and he didn't understand that. I had to explain some simple geometry to him. But yeah, so but
okay. Well, I'll tell you what.
Okay, so just to finish on my initial points, I've made that second point, but the first point, let me finish. The reason I brought up the mind of God there was because I mentioned this going below the horizon, and he said, well, I asked him where he thought the sun went. And he said, "Well, I don't want to answer the question as you put it, or yes, no, because of that, you're forcing me down a particular line." But one of the things I should have said at the time was that we know that the sun has gone below the horizon, because if you then increase your altitude, as it can be done if either in an aeroplane or in a very tall hotel has been done, you can go up the lift to the tall part of to the top of the hotel, and oh look, there's the sun. It's gone below. You can see it's still there. Everything is still there in every regard. It's still the same size. But it's just gone below the horizon. Obviously, when you get back down to ground level, it's disappeared. And of course, that can only happen if you've got something in the way. And of course, that.
Okay.
And of course, on a flat Earth, there can't be anything in the way.
Have you seen the recent video by DITRH?
No, I haven't.
Okay, so he's put a video out, and he's put some things together, which is, in his opinion, how you would explain a sunset on a flat Earth. So, would you mind watching it with us?
No, that'd be interesting.
Okay, let me start sharing. Okay, let's get it on. Here we go.
Okay, here I am. This is my flat Earth counter. continues on into the far distance. I have my camera filming across the surface, slightly above it. This line here is the path of the sun, and I have this bottle here to show you that it's just over 3 fingers above it. As we go down, we have our tropical forest, we have our blue glass cutting board, and some more mountains, if you will. As the sun continues to the end, 3 fingers, we have a level line. I'm going to flip the camera around, stick it here. I'm going to dim the lights and travel to the sun. Let me move my bottles out of the way. Here we go, my sun. See? And here we go. We follow the sun's path, staying level over our flat stationary counterplane. We cruise over the lower mountains. Of course, this is not to scale. I could do this much higher if my kitchen was just twice as long. And we would get the same effect. I come to the end, to the firmament, and we stop. There's the camera, still at level, slightly above level, standing on the flat earth. So here we go. I'm going along the sun's path, keeping it level to the flat earth. Heading past the mountains. Now if this is truly the flat earth, I'd have much more distance to go, and I could even have this much higher to get the same effect. We're just finishing, hitting the firmament basically. Let's take a look. Turn the lights back on. I'm going to remove all of the bumps on the earth. To show that I am above the counter, flat earth, I'm going to just slide this along a perfectly smooth flat earth. And I'm guessing that it doesn't set. Because the earth has bumps. To show that I am above the counter, the flat earth, I'm going to just slide this along a perfectly smooth flat earth. And I'm guessing that it doesn't set. Because the earth has bumps.
Okay, so that was David Weiss and his DITRH channel. What did you think of that, Rumpus?
He is an utter moron. Jesus Christ. Has he not listened to any of the points being made by people over the last X years? What an absolute moron. For a start, he actually demonstrated and he invalidated that model by this video. He showed how that light became smaller as it went further away. Also, we're dealing with situations with sunsets on water, so we're not talking about mountains and going behind. So, I mean, this just invalidated the flat Earth completely. I mean, unbelievable! What a moron! He's demonstrated that. Just look at the size, the number of pixels of that light he had as it went into the distance. It went smaller, and on the flat Earth, the sun would have to become 1/4 of its size in the orbit that it's supposed to have when it's going, for instance, I don't know, around the little Capricorn or something, and you're sitting on the equator. The change in the distance to the damn thing means that the sun would have to change, become 1/4 of its size at one end of its orbit than the other. And he's demonstrated exactly the point there. By having the thing move away by a factor of, I don't know, about 3 or 4, it became 1/4 of the size. We do not see this. The sun never, ever changes its size, except it gets a bit compressed on the horizon. And flat earthers have done, I keep on trying to find this guy's channel, I think he may have deleted it, who took, over a period of a year, he got the angular size of the sun and he used a solar filter. He didn't let himself get confused by glare, because we all know, looking at something like the Wolfie pictures, or Daz the cameraman, I can't remember which he is now. He's got some lovely videos showing the difference that the glare makes, and if you put the filter on it or off, and you get the size changing by a factor of 2, because obviously things like cameras can't cope with that level of stuff. But if you put on a solar filter, this flat earther had some marvelous. His channel's disappeared. Bloody thing. And he had some marvellous pictures of the sun over a period of a year. He took it, and he had absolutely no variation whatsoever at any period during the day or any period of the season. Well, actually, no, I can't remember. No, I think it was during the day. No, I think he's comparing pictures during the day, because obviously the sun does actually change very slightly during the season, because we've got an elliptical orbit, so it changes by about 3%. When we're further away at this, in summer or whatever, in winter, the focus. Well, I think we're closest. It's actually closest when it's winter for the northern hemisphere. So that means the sun is by about 2%. Slightly bigger, and varies due to the elliptical orbit of the Earth. But during the day, which is what he was measuring, he never ever got any angular size change whatsoever, and he had these absolutely superb, high resolution solar filtered images, and he was desperate to find a change, and he couldn't. And anybody else who does it properly with a solar filter, you will not see the sun change its size during the period of a day, and it has to on the flat Earth, because otherwise, what if it doesn't go further away? How does it become dark? And it's getting further away, has to, because other people have the solar noons above them. So the sun has to move. It has to get further away from somebody if it's a nice close sun. And of course that means it has to change size. And it doesn't. Globe confirmed. Flat Earth gibberish. Sorted.
Okay, so you're basically just going to deny the evidence that was shown.
Oh my God, did you not listen to what I just said?
I did.
The evidence that he showed was that as the sun went away, it got smaller in his little video, and that does not happen. And also, it was also invalid in what he did, the fact that he put some things in front of it, because that is not the level of the Earth, the flat Earth. We are you get sunsets over water, which are supposedly flat in the flat Earth world. They're all, that's your mean sea level, that's your flat Earth datum point. So there's no way the sun can be allowed to get below that in the flat Earth model. Yeah, he just stuck up some objects like a mountain, said, oh look, it's gone behind the mountain. So he made 2 errors. One was to just introduce some mountains and claim that's equivalent to the evidence that contradicts the evidence of the sunset over water, which is your base level, over the ocean. That's your base level. It can't get anything lower than that, and it's not any higher. So there should never ever be able to get anything lower than that on the flat Earth, and that's what we have on the sunsets. That's invalid. So that was a completely irrelevant point that he did there, and he demonstrated that the sun must get smaller. So on 2 points, he got that. He's an utter moron, and just confirmed the globe Earth. So keep on doing it, Dirth. You're supporting the globe Earth model. Keep at it, mate.
What do you think about atmospheric lensing, Rumpus?
Well, there's no such thing. You get compression and stretching, but you don't get lensing as such.
What, you don't get things looking bigger than they should do?
You get them looking stretched or compressed. You do not get them. Well, I mean, occasionally you can get some very temporary, strange phenomena where you can possibly get some horizontal exaggeration, but it's just a temporary phenomenon, but nothing on the scale of the compression, on the normal refraction, the refraction phenomenon that we see, the towering and the sinking. That's caused by obviously refraction conditions. Very occasionally there are some strange circumstances where you can get some other effects, but not in terms of something just looking magnified to a great extent. You don't get that, but there can be some occasions when you can get some strange magnification in the horizontal dimension, very occasionally under very strange circumstances.
Well, you do get magnification. I mean, it's
The only typically one you're going to get is horizontal is only vertical compression or vertical stretching. Those are the only two that you can really get in any normal sort of environmental, in any sort of normal conditions. So if you want to talk about stretching in one vertically, yes, we know you can do that. That's and compression, like Anthony Riley got with his Isle of Man observation. He got the Isle of Man compressed, and we've seen that also with you, with some of your stuff. You've seen you've had stretching vertically and compression vertically as well, but vertically, not lensing.
So you don't think things can appear to be large from a distance, and then the closer you get to them, they get smaller?
Correct. And I know you're going to show me this stupid little video where someone's driving along a road and they're fiddling with their bloody zoom factor. Yeah, they're going along changing their zoom. That's ridiculous. I mean, ridiculous. I mean,
I'm sorry, but do you think the zoom makes a difference to the?
Well, of course, it makes things bigger and smaller. That was the.
No. In relation to
sizes.
No. In relation to there's some objects in the foreground that you can measure it to, and that won't be affected by the zoom.
Okay, has your Skype done anything weird? Mine has just gone all white.
Morning, guys. Morning, Ranty. Morning.
My Skype has just gone blank.
Hello, Aaron. How's it going? Well, if you want to leave the call and rejoin, maybe that'll work.
Okay, yeah, I might have to do that. It's just gone really. Yeah, so I think you're going to show me that. I think from the video I haven't seen this properly, but you can see actually it's vertically stretched. You can see there is some stretching going on with that thing. As I haven't actually found the video properly, but my initial reaction was that is just vertically stretched. But yes, and yes, I'll have to rejoin the call. Something weird has happened here. I'll be back in a second.
Okay. Aaron, how's it going? Me.
Good. Sorry, you're breaking up a little bit there. You're roboting.
There we go. Right, how's that?
Yeah, that's good. Can you hear me okay?
Yeah.
Hello.
Hello, Jem. How's it going?
I'm good, thank you. Sorry about that. I managed to unplug myself.
No worries.
Hey, Jem.
Hi, who's here?
Hey, Ranty. Looks like... Oh, my name's Aaron. You don't know me, but I'm a big fan. Ranty and I were just going to have a chat, but the show looks like it's into full swing. I was the one on your Discord this morning saying, please come on to Ranty's show. My name's Hansel when I'm on your Discord. Hey, Ranty, I'm going to go because I've got to get my daughter ready for school. Just hope that you're feeling better, man, and just know that a bunch of people all out there making sure that we're hoping that you're all right. And just one other thing that I just wanted to add. One of the arguments that flat earthers have said that I've heard anyway, and please correct me if I'm wrong, they say when we don't see a huge difference in the size of the sun as it's going away from us or setting, it's because of, I think, what you were just talking about then, atmospheric lensing. But I don't understand how that could be exactly the same every day, no matter what climate that we're in. So, as I said, I've lived in Saudi Arabia. There's no water in the air when you're in the desert, and the sun doesn't shrink. And you know what I'm trying to say. Like across the world, we must all have some freaky moisture gradient at sunset, which makes the sun be amplified in size. I think that's probably, 68,479 trillion to 1 that would ever happen.
Well, you have a refraction calculator, don't you? So who's to say that the effects of this lensing isn't calculable as well? And it just so happens that it negates the distance that the sun moves away, and it keeps it at an apparent size.
Yeah, look, I think there probably could be the odd black swan when that happened. So if the Earth was flat and it got smaller, and then once every 10 years or we'd see that there was enough moisture in the air to keep it the same size, but not with different humidities and different temperatures. Oh, and I have one more thing. And in Australia at the moment, it's 7 o'clock in the morning or shortly afterwards, and it's freezing where I am. It's 10 degrees. On a flat Earth, have you guys put together some idea how seasons work? I understand how your sun and your moon works, but I don't get how seasons work because you guys, or certainly in the Netherlands and stuff, I heard Arwen complaining last night about how hot it was. I went and had a look online and it was 30 degrees, which isn't hot at all.
Seasons on a flat Earth. Oh, mic check. First off, mic check. Can y'all hear me?
Yeah.
Yep.
Yeah. Okay. Well, seasons on a flat. To me, seasons make more sense on a flat Earth, man. I've been really just trying to be fair about this whole thing and go back and forth. And some things the globe makes more sense. Some things the flat Earth. Seasons definitely flat Earth, man. With the sun getting closer, because I've been asking people about what is causing the seasons on the sphere, and they're saying that the atmosphere plays a minuscule part. Okay, I mean, and if the atmosphere.
Do you want me to explain it to you?
Well, let me break it down real quick, so you'll know what to, so you'll know where to go with it. Okay.
So look,
what they say.
I probably just let me say it's actually supposed to be a globe-proof day. So we don't want you guys to defend your model. I was just quickly asking if there's written down somewhere. Send me to it, and I'll go and have a look. Sorry?
Well, it'd take me but a second. Okay, the sun, in the flat Earth model, the sun is getting closer and getting hotter.
Closer
okay.
to the ground.
So on a sphere, the sun, in the heliocentric model, the sun is about 3 million and some change miles further during the northern winter. So technically, the north should be way colder than the south, but we get way lower temperatures in the south.
Hello.
What's up, Travis?
Do you want me to explain
I'll leave you guys to it. I'll leave.
Do you want me to explain it to you, Brian?
Okay, all
yeah,
right.
well, let me present a problem, and you explain the problem. Yeah, take it easy, man. Explain this problem real quick. Okay, so if the sun is let's say we are right. Okay, let's say we have a flat plane and a globe. Okay, well, all right, on the globe. Okay, if the sun is getting closer, if the angle during the seasons, the angle is getting closer, so the ground gets more energy, right? And everything on the ground gets more energy because it has a more direct angle of the sun. Okay, so but that would I could present a problem with that because you take a mountain, okay, like the mountains up in let's say in the north. Okay, so in the wintertime, all them mountains, okay, they have a perfect angle, and they have let's say in the south even, okay, or the north. The mountains have a perfect 90-degree angle of the sun, where the sun is hitting directly the side of the mountain all the way to the top, but yet the mountains still have snow all over them for the entire winter, even though they're getting direct trajectory sunlight. And once you get up, let's say 5 miles or so, you're past most of the troposphere anyway. And if the Earth is curving down and away from you on every point on a globe, that to me presents a problem. What you understand what I'm saying?
No, there's complete just. What I was going to try and do was try and drawing a diagram. Amazing. Just as I tried this, my machine starts to misbehave. Just as I told Ranty I didn't need to reboot. Bloody hell! Now it's starting to misbehave. Let's go and get an AE map, flat Earth map, and let's see what you're gibbering on about.
I wish I could present, because I could present to you the sea temperatures, the seasonal sea temperature laid over the AE, and it looks perfect. In fact, all the models look like the wind, the jet streams, the wind currents, the sea currents, the sea temperatures. They all look real nice on an AE map.
I could explain it to you like this. Look,
okay.
If you imagine you have a flashlight, right? And you take that flashlight and you hold it above a piece of paper, very, very close to the paper. So it will make a circle of light on the paper. Are we agreed with that?
I'm about to doing a diagram here. Will help you out, perhaps.
Yeah, sure.
Okay. So let's say we draw a circle around our circle of light so that we can see it, so that we can remember what it looks like.
Can you see this, Gem?
Yeah. So now we take that same flashlight, and now you hold it close to the paper again, very, very close, but this time at an angle. At this time, you should get an oval of light, right? Right?
Hey, just before these guys carry on too much, I want to give a shout out to FE News, who stole my thunder, because I was just about to bring up the magnifying video from Mark Sargent's, and he said, could the atmosphere be magnifying the sun as it goes towards the horizon? Rumpus ignoring we have an atmosphere. Indeed, I didn't get to that point. I think Rumpus was expecting it though. Let's see what these guys are carrying on with, but thanks for the super chat.
Change in angle will create a bigger area, i.e. our oval of light will be bigger in surface area than our circle of light. And yet, in each case, right? But we've agreed on that, have we?
Yeah, my simple answer would say the sun's getting closer.
Hang on,
getting hotter.
let me finish the point. Okay, so you've got a circle of light, the first one, and the second one was an oval of light. And I say the oval of light is bigger, covers more surface area than the circle of light. Are we agreed?
Yeah, we are agreed, and light does slow down in cold temperatures. Just so
Let
you
me
know.
finish the point. We're going step by step. Okay, so if the oval of light has a bigger surface area and the circle of light has a smaller surface area, but the light from the flashlight that hit each of them was the same, i.e. the same amount of energy hit each of those things. In the one case of the circle, all that energy was soaked up, was absorbed, if you like, in that circle. In the oval, it was spread out further over that oval. And that's what gives us our seasons. We've got that same amount of energy arriving, but now it's spread out over a larger area. There's other factors as well, but that's
or just the sun's getting closer. Which one works for you? I think the sun's getting closer, it gets hotter. But anyway,
if you could show that was true, but unfortunately you can't. So you can say, oh look, I've got this better explanation, but that may well be a better explanation, but unfortunately, hang on.
When's the last time?
Hang on. Unfortunately, you have no evidence at all that is happening.
Okay. Well, when's the last time you grew flowers and plants next to a fire?
You don't have any. You don't have any evidence for what you just spewed out.
Of course we do. We have mountains of evidence.
No, you don't.
Yes, we do.
No, you don't.
No, the sun is not fire.
Idiotic, but of course we do.
But hold on, you still haven't answered. What I did is I presented a problem with the mountain. If you're saying it's the angle, okay, and not the atmosphere, I'm getting above the thickness of the troposphere, and I'm giving you a mountain with a direct angle of sunlight. Yet there's still snow on the side of that mountain all the way up to the peak, when it has a perfect angle.
Mountains, isn't there? In that they're higher up, you've got lower air pressure. The fact that they're covered in snow or in areas that are snowy, that reflects a lot more of the sunlight energy back off the earth.
Listen, when you got a whole entire mountain range, though, all at the perfect angle.
There's a whole load of other factors involved. What we're talking.
So you'll just ignore it then.
Well, I've just responded to it with about 6 different things. So that is, I don't know how you can say that me saying that listing some things that would cause snow to be on a mountain would be me just your
last question? What was my last question?
You're proposing that because a mountain.
Yeah, you don't know. You're just blurting on and calling somebody a liar. You don't even know what my last question was.
So while I'm responding to what your last question was, you're just going to interrupt me and say that you don't know. So
that's because you're not answering his question, Jem.
Just tell the truth.
Oh my
God!
You are such a
He's got no response.
You are such a
He's got no response, so he starts flipping out.
Yeah.
Has everybody noticed? When you give them a problem they can't solve, they start flipping out.
On and on and on, Jem.
Let me
Just shut up,
again.
Jem.
Well,
shut up, Jem.
Hold on.
Okay, so let him respond.
Okay. Did I go on and on and on? Which one was it?
You did. You went on and on and on.
Oh, right, because he's saying I didn't respond.
Okay, restate my last question, and you can respond. Restate what my last question was, genius.
I will. You're suggesting that because a mountain has a...
No, that is not a question.
No.
I'm restating...
That's wrong anyway.
Why is
Yeah.
that wrong? What I've said
You-
so far,
Okay,
why is
okay,
it wrong?
listen.
Because-
Okay, hold on, guys, listen.
Go ahead.
Right, okay, so let Jem just say his piece, and then if you've got something to say about it after the piece, just let him get it out first, and then you guys can tear it apart after that. Does that sound good?
Yeah, let's calm down also, Jim. We'll start freaking out later, but it's too early.
Interrupting me and telling me I haven't responded when I gave a list of reasons why there would be a snow on a mountain.
You're calling me a liar and you can't even restate my question, bro.
Because when I gave my list of things that would cause snow to be on a mountain, you said, so you just ignore it then. That was a lie. I didn't ignore it. I responded with a list of things that would cause snow to be on a mountain.
Okay, do you want to?
you
Okay,
cannot
so
repeat my
hold
last
on. Okay,
question.
hold on. So hold on. Do you want to? Hold on.
Cause snow to be on a mountain.
Well, I was just going to suggest to you, Jem, if you want to just reiterate why you think or you can get snow on the mountain, and then we'll see. We'll take it from there. We'll basically go back a few steps, and then we'll continue. Is that good?
Fine. So there were a number of reasons, including the altitude of the mountain, the air pressure, the fact that there's snow there already reflects energy, sunlight energy back from the ground. That makes that general area colder. But we aren't talking about the effect on a single mountain. We're talking about the net energy over a large area of the Earth. And in the winter, it's less energy hitting the Earth. It's colder.
Very good. That was my question. My question was, what about an entire mountain range where all the span of all that land and all the mountains all have a almost 90-degree angle to that sun, not just one mountain? And that was my question before you went off and called me a liar.
Where does that happen?
90-degree angle to the sun. What are you talking about?
I know. He's saying that if there's
Any
a
mountain
mountain,
90-degree angle to the sun. Okay, the slopes of the mountains, let's just say, you're never going to be exactly 90, but it's going to be a near 90, a near direct zenith to the sun. If you're standing on the side of that mountain, the sun's going to be over your head. Okay, when the sun comes up about, let's say on the clock about, let's say 3 o'clock, or let's say the sun's about 30 degrees, about 11 in the morning, or 10 in the morning. Okay, and the sun, anywhere standing on the side of that mountain, if you were standing on the side of a mountain, your head would be directly facing the sun. So if it's the angle of the sun, that entire mountain range has a bunch of mountains, a whole span, facing directly at the sun. They got the perfect angle to catch all that energy, yet the snow doesn't even melt. And then in the south, it's said to have a 24-hour sun, so you've got a direct angle, and it always stays low on the horizon. So you've got a direct angle at the side of them mountains for almost a whole day. And if
all
the distance, I'm almost done. If the distance has nothing to do with it, or very little to do with it, and it's the angle, then you have almost 24 hours of a direct sun from the side of that mountain.
What mountain? What specific mountain is facing the sun for 24 hours? Thank you. That was nonsense.
Okay. Yeah, any mountain range. You know what a mountain is, right? It's a slope.
Let's try
okay.
it again then. Name the mountain that has a face facing the sun for 24 hours.
Let me simplify this.
No, just name the mountain. Simple. That would be simple. Just say the name of a mountain.
For those who can't understand or trying to obfuscate.
Yes, I can.
Any mountain, any hill, okay, the side of that mountain. Okay, if the sun, let me explain. If the sun is directly overhead, okay, then the sun directly overhead of the mountain is not hitting. It's the mountain. The side of that mountain is not perpendicular to the sun.
Can you see my diagram,
now,
Brian?
the sides of the mountains, okay, during, early in the day, whatnot, okay, and let's say in the south when it's like a 24-hour sun, but the sun is low on the horizon, the sun is near perpendicular to the sides of the mountains, and yet the snow doesn't even melt.
But not for 24 hours. It's not, is it? Because it's going to move
but
around.
It's near.
It's going to go around if you're stood at the bottom of that mountain, it's going to go 360 degrees around you if it's somewhere in Antarctica, isn't it? So is it? But let Rumpus do his little explanation here because it'll be better.
Yeah. Hey, Rumpus, I'll be back in like 2 minutes. Rumpus, save that diagram for me.
And also, while you were away for 2 minutes, think about how this isn't a problem for you. Why isn't the snow melted on the top of flat Earth mountains?
Right. I just want to go through what Jen was talking about here about the intensity of the light and the energy delivered by the sun at different latitudes and different situations on the spherical Earth, and why basically we have winter and summer. You can see here I've drawn two equal bands of rays of the sun. They're just coming. I've just drawn them horizontally. That'll do as an approximation, and you can see where this light beam. We're just going to take an arbitrary width here, and we're going to say this is the amount of surface area. This area from between here and here is the. We're obviously doing this in 2 dimensions here, but fundamentally it's the same thing. So we've got that length effectively. That which we can also consider as a surface area. Just put some arrows on this. Right. So that is.
But in the winter the sun is closer.
Yeah, but it doesn't make a difference. It's only changing by. It's less than it's only by a couple of percent. So, but what I'm about to make. Just let me finish my goddamn explanation.
No,
Jesus, shut up. Shut up, twat. No, shut up. I'm about.
Wow.
Just let him say his explanation. You've seen him set it up. Let him finish. Why have you got to censor him? Why is it necessary for you to stop him?
I'm not censoring him. I'm just
you're trying to stop him from speaking. He's told you about how he's prepared this
That's
presentation.
because he's
about
uttering
to say it,
gibberish. He's
Right,
uttering dribble, pure
Shut
dribble.
up, twat.
It's utter
Right, so here we go.
dribble.
Shut up. Stop interrupting, you little twat. Right, so here we have a ray of these rays of the same size, the same height, and they've got the same energy in them. And you can see that the length of the circle, which is effectively the same as the area, here we have a factor. This length here, if I were to put this next to that, you should find, if I've done it correctly, it's about 1/3. Whoops, damn it, clicked on the wrong thing. Damn it, bastard. What you will find is that length here is 1/3 or just over 1/3 of this, which means that the amount of energy being received here is 3 times the amount of energy being received up here per unit area. Now remember, the variation in the distance of the sun is only varying by 3 million miles in 93 million. In other words, it's only a few percent. Whereas here, we're talking about a factor of 3. So when the axis of the Earth, which I'll now draw in, so I'm going to draw in the summer for the, imagine it's rotating around this axis I've drawn here, hopefully you can see that. So that the Earth, we will move by, we will change position by, so it'd be by 40 degrees, because 20 to 3 each much. Which means that we will, for instance, in our winter, so let's put it for Britain. So for Britain, we might actually be something like here, and in our summer, whoops, daisy, we will be sort of here. Now the factor there is by a factor of, say, about near a factor of 2, the difference between those two positions. One we'll have in the summer, and the one we'll have in the winter. Because the reason that happens, of course, is because the Earth is round. I mean, I don't know whether I have to explain this, but the Earth will be round this side. In the summer, and this side during the winter. So for the northern hemisphere, that's about where Britain is. This is about where it is in the summer in respect to the sun. So we're getting a difference of about a factor of 2 here in the amount of energy we're getting from the sun per unit area. So that's much more important than the.
Okay. Or
Nearly finished, 10 more seconds. That's much more important than 3 million miles that the Earth is actually further away. A factor of 2 is much more important than a factor of a 20th or a 30th. There we go, carry on.
Okay,
Hold on, guys. I just want to do a mic check with Tim. Tim, can you do a mic check, see if everything's coming through fine?
I don't think it's working.
Yeah, you're working.
Oh, cool.
I hear you. Here's my presentation. The sun's getting closer, things get hotter.
Okay, so why do you have snow on top of flat Earth mountains then?
Because the pressure, temperature. The pressure is lighter, I guess. And you have But you know, the air doesn't
But
tend
why?
to heat up, man.
If the sun is,
I'd
getting
rather Rumpus
closer-
give an answer on that.
Oh, so you don't have an answer?
Yeah, I mean,
No, I'm still waiting to see why there's still snow, because he just drew it out, okay? And instead of freaking out, let's think about this logically, okay? When you draw a mountain right there, okay, and the sun is on the is the flat ground next to that mountain getting the direct sunlight, or is the side of the mountain getting direct sunlight? Okay, we all know.
But how is this different on a flat Earth than a spherical Earth?
Because on a sphere of Earth, man, if you have an entire mountain range and the sun is about 20 something degrees above the horizon, then that entire mountain range, okay, in the southern hemisphere,
but if you believe in the flat
or the
Earth,
northern hemisphere,
hold on. If you believe in the flat Earth, you believe
Wait,
that
no,
this.
why are you
Hold
trying
on.
to censor
You
Brian?
believe that
No, he
this
was
sun is
speaking. Why are
going
you
around
trying to
here,
censor Brian?
so you're going to get
Brian
all
was
the
talking.
angles
You're
you could ever
censoring
want.
Brian.
You're going to get
You're
all
censoring
the
just
angles
listen
you
to-
ever want. As during
Yeah.
today, it's going to go around all
censoring Brian.
the angles.
Yeah, okay. Let's
are
let's
you doing this,
listen to Brian's response, because you did your presentation. I want to get his full response
Yeah.
in if you can.
Now you cannot. You have to say in your model. You have to tell me that the atmosphere is minuscule in the seasons. You know, so that's why I'm taking even more of the atmosphere out of the equation by using mountains. Okay, and because we all know the atmosphere is thicker. Just in case that you try to say atmosphere, I want to take.
Brian.
Hold on.
No idea
So,
what you're talking about.
in other words, the size of all them mountains in that whole entire range, which getting almost 24 hours of sunlight, okay, and in the
No
south,
mountain anywhere gets 24 hours of sun.
and
What's happening?
right, I didn't say 24. I said almost, okay.
What
Okay.
he's saying, Rumpet,
If you're saying there's 24 hours of sunlight in the south, right? You say there's 24 hours of sunlight in Antarctica, right?
It's not going to be shining on.
And we all.
But it's not going to be shining on one side of a mountain for 24 hours, is it?
But there is going to be
About
plenty
it.
of hours of is there going to be plenty of hours? If all it is the angle, okay, majority of it is the angle, that mountain, the sides of that mountain has a perfect angle to the
All right,
sun.
let me
And
try
when
and
I'm
explain this
laying,
to
hold
you.
on, I'm almost done. When I'm laying on the beach, wait, when I'm laying on the beach, okay, hold on, let me finish, dude. Damn, I let him finish. When I'm laying on the beach, okay, in the summertime where I'm at, and the sun is overhead, okay, I got a direct angle, damn near, okay, and I'm hot as shit, dude. I mean, I'm beaming hot, okay. Now, if it's the angle, now hold on, I'm almost done. So now the side of a mountain, okay, in the south, in the Antarctica, according to y'all, if the side of the mountain is the equivalent, it has the same angle as me laying out. Okay, then right there, that sun should be beaming ass hot on the side of that mountain where I'm laying. You know, so that's not a good. You know, you don't have a good explanation for that, man.
Right. What he's saying, Rumpus, is that if you stick a mountain at that high, up in the north there, you stick a mountain there. Now the angle
mountain.
Yeah.
I'll stick this mountain. Okay, let me go and put this
Right.
mountain here.
So now the angle that the light is hitting the mountain's sort of adjusted for the angle of the Earth, and has made it so that the sunlight is hitting it directly. Is what he's trying to say.
Right. So
Just draw slopes the way mountains do. When they get too
doesn't-
steep, they have landslides. Draw slopes.
But it
Well,
doesn't
I've got
change
some-
anything.
Well, I have got some slopes here. I don't quite. But the point is, you haven't countered my argument here on the spherical Earth. You're going to get
Rumpus, snow won't pile up that steep, buddy. Just draw a regular mountain, and I'll shut up.
But the point is, the area where the mountain the mountain lives in is getting less energy from the sun. It is. Doesn't matter what angle the bases of the mountain are. The entire area is getting less energy from the sun.
Am I going to get sunburnt in 5 minutes the way I do where I'm at? Okay, if it's the angle of the sun and I get sunburnt in 5 minutes, am I going to get sunburnt on the side of that mountain with a direct angle?
You
in the winter,
you can get sunburnt very easily on the top of a mountain. Yes.
In Antarctica.
How do I know? I mean, what a silly question.
The
We would
sun
need to know
is
the
much less
temperature of the sun,
intense.
Well, if there's a
how long it's been
24-hour
there,
sun down
what
there,
mountain it was.
if there's a 24-hour sun down there, them mountains should never have snow on them in the summer.
So really
Period.
quickly, I don't have much time. I just really wanted to like speak with Randy really quickly about that video by Dearth, just very quickly. Is that really? Were you serious, or were you being joking when you played that video and that's like answers for flat Earth or something?
No, I presented it as this is Durst's presentation. This is what he believes answers the question that you've just been put forth, and that was exactly what I did. I played his video.
I just caught like right when you were playing the video, so I didn't hear like any of the preamble. Basically, I actually can't believe looking through the comments that there are that many flat earthers that think that's a good video. I mean, Ranty, just really quickly, you do understand that the mountains that he had with the board or whatever was obviously that's higher than the camera, right?
Yeah, it's amazing, isn't it, Tim? It's incredible.
I can't believe it. Truthfully, I'm like astounded. But Ranty,
yeah, but you've got to realise that he's working in a kitchen and he's trying to do something. He's trying to scale the size of the Earth on his kitchen table.
But hold on. He put something. He said specifically because we got onto people flat earthers before where they were doing the coin test. They had the middle of the camera basically under the table. We said that. So he specifically said his camera is above the table, which is like, oh, I was like, cool, okay, let's see what he's got here. And then he has the mountains, a board basically blocking, and he says that this is how sunsets work basically. And you understand, you can agree maybe that doesn't work for, say, you're in California looking from the beach, looking at a sunset that doesn't change in angular size like his little demonstration did, but also gets obstructed by the water, not by mountains or anything like that. That's higher than you. You understand that, right?
Well, I've never been to California, but
you've seen the sunset over the ocean, right?
Yes, I have. Yeah.
Okay, so obviously you're above the level of the ocean. Like I gotta see where your mind's at. You understand how this is ridiculous. I really hope you do, right?
We're still.
Let me tell you what else is ridiculous.
I was asking Ranty though.
Yeah,
people saying
Ranty was answering my question. 1 sec.
Yeah.
Ramble on for just a minute.
We're still looking for answers. That's why I started this show. It's so that I can get answers, and I'm here for answers. So I don't say that I know everything. I put things out there, and people come back to me.
Anybody who thinks.
Hold on, he was almost done. He was almost done.
Hold on, I'm backing him up. I just said he wanted answers. Now back off, boy.
I didn't ask you.
Back off, boy. Listen.
Okay.
Anybody who says the sun doesn't change in angular size is insane. Okay, when the sun comes up in the morning over the horizon, it sometimes is scary huge. You could use your filter, filter shit. Okay, if you're gonna use a filter, okay. How about what about there in a sun dog when you have three little filtered suns? Genius. Okay, not only does the sun change in angular size, it splits off into sun dogs occasionally. Okay, so you're trying to use solar filter? That is a week, and over the course of 1 day, that is weak, dude.
I was talking to Ranty.
That's not reality.
Okay, very good.
You don't want this point to get out there, do you? What does a sun dog look like under a sun filter, dumbass?
Okay, very good. Thank you so much for that.
Does it change in angular size? You need to back off. That's what you need to do.
You need to stop interrupting, Brian. Tim and Ranty were talking.
Yeah, go ahead, please.
I spoke through everything I said. The sun obviously changes angular size.
But you've interrupted the conversation to say it. Why?
I'll be done just in a minute. Thank you. And please don't yell at us. Everybody else has like normal voices. You're always yelling into the microphone. I don't know why.
Anyway, you just spoke through my every word, pal. Okay? So don't think you're going to get respect from me.
Okay. So anyway, just Ranty, I think that the question should be like, what evidence, because you've been around for years, dude. You've seen my Salt Lake. You've seen all these different demonstrations. And there's always this different kind of excuse or whatever. So the question is, you want globe Earth evidence. I think people need to think for themselves as flat earthers and say, what would I actually accept as evidence? Because we have thousands, if not hundreds of thousands of pictures from space, which are all have to be fake. We have all of this evidence from the celestial sphere down to the angular size of the sun. It rises, it sets, the predictions the models actually bring. We can give you all of that right now. But what would you like legitimately accept at this point, man? You've heard it all.
Better proof, Tim. An experiment that will prove something.
Yeah, but like,
could
you devise? Could you like devise one that we could all agree on? Because everything thus far, for 5 years or 4 years that I've known you, you do not accept. But you accept the flat Earth evidence, probably like what we were shown with Dearth, over actual evidence, actual models, everything, man. So like, could we devise something as?
Ranty, can I take that, Ranty?
No, I'm actually asking Ranty because it's his
yeah. Ranty, can I take that one?
I'll be done. I'll just listen.
Yeah, after that, let me answer it, and then you can take it. You can take over. Yeah.
Okay.
So yeah, as opposed to what experiments can we do as a community, this is what this show's for. Let's get our heads together and let's work something out.
Right.
I said I didn't want to be here in 5 years. That was a year ago. So I've got 4 years. So I said I don't want to be here in 4 years. I don't want to be here having this same argument. I want to get some answers. This is what this show's for.
Right. Ranty, do you realise that the flat Earth model makes a number of predictions that we should see, and the globe Earth model makes some other predictions that we should see if that's true? So we can do tests on the predictions that those two models create. So, for instance, the horizon always rising to eye level is a flat Earth prediction. So if we find that doesn't happen, then we know we're not on a flat Earth.
But then we can explain why that doesn't also happen too, due to perspective, due to the fact that if you can't see for infinity through the atmosphere, then it will have the effect of covering over the ocean, which will drop your eye line to the horizon. It's a simple fact of perspective.
No, it's not.
But you just ignore it. Exactly, yeah, but you just ignore that.
It's because you don't understand perspective. You don't understand.
You just ignored it. If you've got a visibility, if you can only see for, let's say, 50 miles. Let's say you're at shore level and you can see for 50 miles, right? Let's suppose you can do that, but that's 50 miles in a circle, right? So you can't see 60 miles or 70 miles. So you are eventually going to be looking down due to the covering of the atmosphere.
No, we're not.
Yes, you will.
No, look. Ranty, do you understand? If you form a sharp horizon, that is where the horizon is. If it's a non-blurry horizon, then you can see that's where the edge of your surface is.
Okay, let's try something else. Okay, let's try something else. So you're in the middle of fog. So it's just fog. Hold on, just a minute.
Hold on, Ranty.
No. Let's start small. And let's start small. And let's start small. Let's start small and expand.
Shut up, Rumpus!
No, we're not interested.
Let's start small and then expand it. Start small and expand it. Rumpus, I want you to listen. Rumpus, this is my show.
And I want you deflect onto 40 days.
You've asked me about if you can see.
Don't talk about 40 days.
You've asked me if we can. I'll talk about what I want. This is my show.
You can't.
And I want to. If you want my answer, you want my answer. I was asked a question, and I want to give my answer.
On a clear day.
So this is my... Never mind. We're starting off... We'll get to your clear day. We will get to your clear day. We will get to that. If you shut up. Right. So, when it's foggy, you can't see very far, and you have to look down to see where you're going, because you can't see very far. Then on misty days, you can see maybe 50 meters, but you still look down. You still can't see beyond that, so your eye line is looking down. That's how the atmosphere works when there's stuff in the atmosphere. Now you can go and you can check any weather report and it will give you a visibility on the day. So you can check it out and it will say the visibility is 10 kilometers, the visibility is 15 kilometers, 20 kilometers, and it will give you different gradients on different days to how far you can see. And that's just to the amount of shit that's in the air. That's the amount of shit that's in the air, right? So when you're saying, if you can go out and you can see the horizon, you will always, due to the air in the atmosphere having particles in it, you will have to eventually look down, because there will come a point where you can no longer see through the air, because it is going to block things out, so you will be looking down. No, that's an absolute fact.
On a sharp horizon day, and you've just spent 2 minutes dealing with a complete irrelevance. I asked you.
No.
I set the problem. I set the scenario about what you would expect to see on a flat Earth. And if you can see a sharp horizon, that is the edge of your world. So anything about fog or mist is utterly irrelevant to the scenario I described. And on a situation where you can see the horizon on a flat Earth, that should be at your horizontal, your eye level. On a spherical Earth, it won't be. So therefore, we've got a prediction of what things will look like on a flat Earth and what they'll look like on a spherical Earth. And guess what? When we look at it, we find that the flat Earth model is invalidated because the horizon's not at eye level. It's always down, and as you go up further, it's further and further down. And I can draw you a diagram of flat Earth geometry showing why it should be at eye level.
So you're just going to ignore my point then completely?
Yeah, absolutely, because our foggy days got nothing to do with clear days.
Let me
scenario I described.
Let me shout out. Let me do a couple of shout. Hang on, wait a minute. Let me do a couple of super chats, and then we'll get into Brian because Brian's waiting patiently. Right. So Godzilla says this 5 is for you having to put up with Gem, and second best Bob says, Ranty, are you a Poe? No, I'm not. Right. Okay, Brian, go ahead. You had a point to bring.
Yeah. You need to quit interrupting Randy like that, man. He's just trying to get a point out. We're going to listen to you. Let's be fair.
Scenario. And he dodged it. He completely dodged the scenario I described for him to comprehend, and therefore he completely ignored it, and he went off into another scenario completely had nothing to do with the scenario I described, and then explained what
it was exactly the same.
Let's bring this down.
It had everything to do with it, Rumpus. It was exactly what Ranty should have said. You're just too thick to understand.
You're a moron. You're an utter moron.
Here's what I have to say. The more of a problem.
You're a moron. You're a moron. Okay.
the more of a problem that we present y'all, the more of a problem we present y'all, the more mad y'all get if you don't have the answer, or the longer the answer.
Your stupidity is
you can see anytime you name a legitimate point, they have to interrupt or get mad, or their answers get even longer.
You don't have any legitimate.
Let's bring this down to common sense. Okay, so I'm supposed to believe that Earth curve changes every day. If Earth curve changes every day, the horizon. We argued that the horizon changed for years. That the horizon moved around. And while you measure, when I make a good point, I get interrupted. You don't even get to finish a point, and then they start getting mad, folks.
I want to understand what you meant by the Earth.
You wouldn't want this information to get out, would you, there, Rumpus?
I'm happy to expose your stupidity. What did you mean by the Earth curvature changes every day?
You'll have to listen, okay, and not interrupt, okay? For years, flat earthers argued that the horizon changes day to day, hour to hour, okay? While I watched you and plenty other people showing, looming, and calculating the 7/6R to make it all match, okay? Then you change your whole entire answer to say that we can't see the geometric horizon. Okay, so how is it a horizon if we can't even see it? Okay, that's common sense, man.
Ron, hold on, just sorry to interrupt you. I didn't really want to. But, Bron, are you aware that 3 years ago, when we were talking about the Isle of Man, we were talking about refraction and the apparent horizon, and people like Ranty and Nathan were going on about how this was a hologram. In fact, I think Ranty used the expression just a month ago that this was all a hologram we were claiming. And we've been explaining refraction for many, many years, and only now have you just understood what were you and other people.
Never once did you apply refraction to the horizon. Never once.
It's all recorded. There's hours and hours and hours of us discussing it.
Right.
Well, look,
we've always said this. We've always said.
Go look at the Isle of Man debates, and you will see 3 years ago how I and a couple of other people went on and on and on about refraction, and we said everything's loomed up, all the mountains, trees, and it's all loomed up. And then people like Reggie said, you say it's all moved up. It's all moved up.
Let me ask a question then. Let me ask you a question.
You've now caught on to this.
Rumpus,
answer me honestly. Let me ask a question.
Point was.
Right. Did you ever once, in all them years, apply that refraction to the actual horizon? Be honest.
Yes, we worked out what the hidden value was for things like the lighthouse on the Isle of Man, and we used.
So you applied You applied that refraction to the horizon.
Hold on, 5 seconds.
We did.
So we applied the formula for refraction to what we saw, and we saw that it got quite a good match, and even better than using the geometric, just using a pure normal radius of the Earth. So we applied.
Here's the thing, guys. Here's the thing. You guys didn't add in anything to do with angular resolution. Okay? There's nothing to do with angular resolution. In other words, the apparent... It's not irrelevant. Stop that nonsense. The point is, here's an observation we can all agree on.
Resolution is.
Listen, if we had a sensor on a camera that's infrared, and it was balanced and directly at zenith towards Earth, and we took off, We made sure from frame to frame that infrared from point A to point B, it was equal elevation. It was a horizontal frame. That meaning that when it would take a caption of Earth between position one side of the frame to the other side of the frame, there would be a horizontal plane taken. Correct?
I have no idea what you're talking about, I'm afraid.
I don't really know what you're saying.
Yeah, it's gibberish.
So when they're doing, let's say they're taking high elevation topography, okay? They have to be horizontal to the Earth. Each frame to frame part of the sensor has to measure equal elevation or
frame to frame. I just don't understand what you're saying. It's just gibberish, utter gibberish from start to finish.
So if you have a 36 mil sensor and a 21 millimeter lens, and you are 60,000 feet in the air, you can capture about 50 square miles of Earth. Okay.
Oh, so well, you're bound to have got it wrong, but I'll accept it for the sake of argument.
I think
that doesn't sound right. But how high up are you? Did you say
60,000 feet with a 21?
Oh, you'll see much more.
Yeah,
you'll see much more than 50 square miles. You can
60,000 feet
from 60,000 feet. You see hundreds of miles.
Rumpus, he's got a lens in here that's limiting the field of view, though. I think.
So the point of the matter is. The arbitrary. It's arbitrary what lens it is. It's a very large field of view. Is the point? The point is from frame to frame, you're going to see equal elevations of the topography of land. In other words,
we're talking video now. We got a video. We're talking about now.
I'm talking infrared. I'm talking when they do topography of the Earth. Okay.
Frame to frame. What 2 frames have we suddenly got?
Yeah, is this all in your imagination?
The field of view.
Hold on, hey,
Listen,
let me say one more thing, Data.
Stop. The field of view is what you see from one edge of the frame to the other edge of the frame when you're using a lens. Okay. So in this particular fact, we have a 36 millimeter sensor, and we have a certain size lens. At 60,000 feet, you're going to see frame to frame a horizontal piece of land.
Frame to frame, you mean edge to edge of the frame is what you mean by that. The field of view.
Frame to frame means
one side.
Do you actually have this piece of evidence to show us?
So any topography, high altitude pictures, if we now insert a 6-foot observer in these pictures, and we're looking down at zenith at the 6-foot observer, that 6-foot observer is going to see an apparent junction well in advance before the frame-to-frame edge is filled with that field of view shot. That 6-foot observer sees an apparent junction of the sky and ground that he concludes to being actual physical Earth curve. When from zenith, at a certain altitude looking directly down, frame to frame, you have a piece of horizontal land that you're looking at, clearly indicating for the 6-foot observer that it's an optical limitation to angular resolution and the wavelength of light based on the sensor that we have in our eye that receives the visible wave.
How's that got anything to do with angular resolution? Angular resolution is all about seeing the smallest, determining what the smallest thing you can see. It's got nothing to do with the field of view.
Your eye has a constant. It's the 1.22. It's in every camera system.
Yeah, we know that. It's got nothing to do with what you're talking about.
Which you can use to calculate the distance to the horizon, just as this formula goes.
No, you can't. Right.
Listen,
here you go.
If I was a 5, let me finish.
Hold on.
Let me finish.
Let me finish, Rumpus. Rumpus, let him finish.
If I was a 5'7" observer, and I divided it by the tangent of the degree of the angular resolution of my eye, which is 0.0213 for a 5'7" observer, I get a horizon line about 15,500 miles. Okay, this is just basic trig telling me. But I'm using something really important. I'm using the 0.0213, which, if you times it by 180, divide it by pi, it equals 1.22, funny enough. So listen, gentlemen, spare me your shit. The Earth is not a spinning ball through infinite space, and you guys are just bullshitting everybody, and it's so wonderful to capture. It's so wonderful to capture.
Are you going to let us respond?
Thank you so much.
Yeah, now you've had 2 or 3 minutes, you tosser. Now we're going to respond.
Go ahead, Rumpus. Go.
Right, you utter moron. You've mixed up 2 formulas and 2 concepts. One, the angular resolution of the eye with the formula for the distance to the geometric horizon for a 6-foot observer. You utter idiot. I'll explain to you. The angular resolution of the eye is using the formula for the Rayleigh criterion. The Rayleigh criterion being, as you can see on screen, the
Can I tell you, 1.22 times 0.0000005 divided by 0.005 equals radians 0.000122
Why are you
times this
talking again?
by 57.30 times this by 57.30.
Where's the wavelength? Wavelength divided by.
I just told
so
you.
hold on. So here's the Rayleigh criterion.
Hi,
Here
PJ.
we go.
Hi.
Here we go.
Hello. How you
I'm
doing?
still in the middle of
Just
responding.
can't let him speak.
Yeah, I'm in the middle of
Got to
responding
censor him. Got to be censored.
Right, here we go. Here is the formula.
Interrupt again. So that's about 5 times you've interrupted him.
Yeah,
so
I
far.
let you go. For 2
You're like
minutes.
children.
I let you go for 2 or 3
Rump is your bum boy, Jeremy. Are you a rum boy?
You're one to talk, Jeremy. Calling us children. You're one to talk.
If you are children, you can't make a point and then let someone make a point and respond.
So here we go. So the angular resolution formula, which is the Rayleigh criterion for the eye. Why is someone screeching there? Right. So here's the formula.
How long did it take you to yell at me?
Be quiet. Be quiet. I let flat Earth data go for 2 or 3 minutes. Now here we go. So
Dude, you didn't let me say one thing without interrupting me, but I'm gonna let you go.
Make a screeching noise. Right. So the Rayleigh criterion, which is the thing that sort of flat Earth data sort of referring to without realizing it.
Is it me
when
I come
Shut
on?
up, you twat.
Well, no,
Be
I
quiet.
just want to make sure. Wait, hold on. I just want to make sure. Is it my microphone that's making this?
You guys must be so proud. You must be so proud of your debating skills.
Travis, your mic is low.
You're so great. You look so intellectual.
Travis, your mic is low, buddy.
Right,
Let me
okay,
control
right.
it.
Let's get some control. Right, come on, guys.
Let me take control, Randy, and let Rumpus
Hold
speak
on.
there.
Yeah.
Just, Rumpus,
Let
what are your
Rumpus
objections
finish.
to what Flat Earth Data just said? Off you go.
You're brilliant. You guys are brilliant.
Right, so there is a formula for working out what the resolution of someone's vision is, and that's dependent. I'll just draw a little line here. You have to have a gap between. Oh, I've still got the arrows on. Pardon me. Oh, Jesus Christ!
Embarrass me, Rumpus.
Right, so when you have a light coming in here through a gap, we have this Rayleigh criterion formula. So if a light ray comes in here, get rid of that bloody arrow. Right, so make that yellow. So if you have a light coming through, that should be a sine wave. Apologies for not having time to do that properly. So that should be a sine wave.
Desperate sine wave, Rumpus.
Be quiet. So there we go. So that's a light ray. You know, you probably can't see it, but let me just make it a little clearer. So there's a light ray coming through a gap, and the Rayleigh criterion says that you can determine the resolution of your eye or a camera or something else from this formula: 1.22 times the wavelength of the light you happen to be dealing with, which we'll say this is a wavelength of whatever. Usually the wavelength light is given 500 nanometers. Is a typical wave. Whoops, 500 nanometers. And the
just put 0.
What drives the light to travel in that way?
And something
just
like
turn it to meters, man.
So,
you'll turn it to meters anyway. So just
did your
do
attention
next.
span run out?
No,
Yeah,
I just already know. I already know this.
The
formula,
45 seconds too much for you.
Right. So
listen, it's a waste of time, dude.
Yeah.
Right, so this formula here is for the situation I've just described here, where that gives you the angular resolution. So the result is an angular resolution of the eye, which is basically saying if you have two objects close to one another within that angle, you can't distinguish them. So in other words, you have two lights in the distance, how it'll tell you what angle they have to be together before you cease to be able to see the two objects. So that's one issue.
Right.
That's one formula. Now the other
Wait, you are not counting the ground as part of that viewing angle, dude. So this is all a waste of time. You're not counting the ground as part of the viewing angle. So that is lack of common sense, dude.
This has got nothing to do with the ground. That's the whole point of the formula of the Rayleigh criterion.
Yeah.
It doesn't matter whether you're it doesn't matter whether you're looking at a mountain.
Okay.
Along with the Rayleigh criterion, Rumpus.
Can I finish my point, please?
Let him finish his point, Fed. Finish your point.
He
Rumpus.
did
Come on,
finish his
continue.
point. He did finish his point.
I have not finished my point.
Well, sum it up, man.
Right. So the point is, this does not have anything to do with whether you're looking up, down, or different. This could be two stars up in the sky. This could be the determining by.
Right.
And the other formula that idiot face has mixed it up with, for God knows what reason, is the distance to the geometrical horizon.
Oh, whoa. No, you're going to try and make another point? No, hold on. Let us respond to that one. Okay.
Observer, it's something like 1.23 times, I think, the square root of something.
Come on, Rumpus. Let it go there. You're only guessing at this stage. Let me just ask you. Let me just ask him, Flat Earth Data. Rumpus, when you talk about calculations to an horizon, is that a geometric horizon you're calculating?
Wait, go in 10 seconds. Right, the point is, there is another formula that tells you the distance to the geometric horizon that looks a bit similar for a 6-foot observer. And this idiot moron has mixed up these two equations, one giving you a distance and the other one giving you an angle, and then somehow has mixed them up into some strange theory that he's come up with.
No, he's not.
Anyway, so go ahead, Pete.
His theory is perfectly rational and reasonable, right? When we understand that the Earth is not a spinning ball. But Rumpus, when you talk about calculations regarding the Rayleigh criteria, do you always have a geometric horizon in your view?
Rayleigh criterion's got nothing to do with horizon. The Rayleigh criterion, as I described about 5 minutes ago, it's all about telling you how two things that are separated by a particular angle that whatever it is, whether it's a camera lens or your eye, you will no longer be able to distinguish them.
Yes, but you're applying it to reality.
5 seconds, and that's got nothing to do with the horizon, which is all to do with geometry and the sun and the curve of the Earth.
So you
would the ground, hold on, Pete. Hold on, Pete.
Okay,
would the ground compress that angle? Just one quick thing, Pete. Would the ground compress that angle?
No,
see, that's where you have no common sense. Watch how I'll ask him a question. He'll go, huh? He'll go, huh? What? I don't know. What are you talking about?
Brian,
Gibbers.
Brian,
A simple little question.
Brian, it's a good question. Let me ask Rumpus. Rumpus, are you applying the Rayleigh criteria and the behavior of the light waves to a geometric horizon? When you're looking at an image and you're trying to explain anomalies over a seemingly geometric horizon, how are you calculating the geometric horizon?
I'll tell you again. The Rayleigh criterion is only about distinguishing things so small or so close together you can't distinguish them. That's all the Rayleigh criterion has got to do. So if you're dealing with big objects like mountains or wind turbines, the Rayleigh criterion is utterly irrelevant.
Watch me demonstrate his lack of common sense.
And he has been saying for the longest of times that the globe Earth is hijacked perspective via the Rayleigh criteria.
Can I navigate just using the 1.22? Can I find the distance of something just using the 1.22?
Well, you have it wrong as well, Flatter Data. You have it wrong now.
Who is pumping up their bicycle tire or something in the background?
Can I calculate the distance to an object using 1.22?
Ranty is masturbating.
God. Right. Say again.
Can I use the 1.22 to calculate the distance?
When you say
to
the 1.22, are you talking about the Rayleigh criterion formula? Is that what you mean by the 1.2?
So here's the thing. When I look at previous.
Is that what you mean by the 1.22? Are you referring to the Rayleigh criterion formula?
Well, if you take 0.0213, which is the angle degree of the human eye, the resolution of it, you times it by 180, divide it by pi, you get 1.22, and if you times that by the square root of the observer's height, you get the distance to the horizon.
Right, that's just accidental.
I'm just saying a formula works. I don't need earthquake in this.
No, you've mixed up two formulas.
No, I can use it and it's fine. No, what I did is I took what I took is the height of the observer. I divided by the tangent to the degree of the resolution of the human eye. It gave me the distance to the horizon. And again, not using the earth curvature formula. Just using basic geometry and using the angular resolution of the eye. The best part about the 0.0213 is if I times it by 180, divide it by pi, I get the 1.22.
Flatter data. Rumpus takes away the extended span, the extended plane, right? So he says that the visible horizon is the geometric horizon. What are you saying? Are you saying that the horizon extends to possibly eye level for an observer? Or are you not going that way?
So this is what I know to be true. That if I had arbitrarily positioned a whole bunch of observers in one spot at different height elevations,
you can't know that to be true. You haven't done it.
Well, I understand the principle behind it because we've seen photographs of these things.
No, you don't, because you're mixing up two formulas.
So listen,
unless you've incorporated the mirror water layer into your thinking.
Exactly. There's many. Listen, there's many. Let me explain. There's the wavelength of light, the distance we can see based on the wavelength, plus there's humidity in the atmosphere, which causes refraction. No, it's not relevant. It's what happens. It bends light, so it also bends light downward. So the whole point is
that's correct.
But it's the combination of the conditions of what we're looking at. But there is a limitation. That's why there's an apparent junction. The apparent junction is an optical effect caused by the human eye. Nothing more.
But where is the real horizon?
How? And it changes. That's what he says.
Listen,
gibberish.
Let me demonstrate his lack of common sense, man.
There's
common sense.
Brian, you like this, Brian? Rumpus. Would you agree that if the decided distance to the sun is wrong, then the evaluation of the speed of light has to be wrong necessarily? Would you agree with that?
Well, the speed of light's been measured independently of the distance.
Forget about that. If the distance is, imagine they said that, well, we're wrong about the distance to the sun being 93 million miles. It is, in fact, half of that. Would you agree that they would have to have gotten the speed of light
No, because the
wrong
speed
then?
of light's measured by lots of different experiments and observations.
Well, is the speed of light, hang on, is the sunlight that is leaving the sun right now 8 minutes behind in terms of its destination? Yes. Right. So so you would agree with me. If the distance to the sun is wrong, then the speed of light and all calculations.
No, because we've got lots of independent determinations of the speed of light.
Well, are you talking about unnatural light?
Wait a second.
Are you talking about natural light or unnatural light?
No such thing as unnatural light.
Wait a second.
Well, there is. Natural light is sunlight, right? Unnatural light is a neon light, where you apply electricity. Remember the two factors I was asking you the last time? Rumpus, you have a material factor and you have an electrical factor. Electricity applied to neon gives you neon light. That's an unnatural light.
The light's the same.
Well, if the sun distance is wrong, necessarily the speed of light calculations have to be wrong, right?
What? Well, here's a common sense. Hold on, give me 1 second, Pete. Let me demonstrate his lack of common sense, man. When we're trying to talk to him. Okay, when I ask him this question, he'll go, "Huh?" or "You're gibberish," or he'll have to repeat it. It's a simple question, okay? Now, when we look up at the moon, I can see a 60-mile Copernican crater, okay? Now, the picture they show from the moon to the Earth, we can't even make out the Andes. Why is that?
You can't see a 60-mile Copernican crater.
There's no zoom on the moon.
Floating around.
You can't see that with the naked eye. It's not true.
He had to get white-knighted because Rumpus was about to go, "Huh? What are you talking about?" That's what I mean. He doesn't have common sense.
All the time, but you can't.
Okay, so we can't see the Copernican crater with the naked eye. Is that what you're trying to tell me?
You can see the ejector rays from the Copernican crater, but you can't see the crater itself with the naked eye.
Anyway, what Rumpus was about to do is say, "Huh? He's got no common sense, guys. He doesn't even understand that the ground is part of an angle. He doesn't even understand that the ground is a part of an obstructing angle.
Let me ask you guys something, if I may. Can I ask?
Let me just say to Brian, Jeremy. Let me just say very quickly on the same topic, Brian. Have you ever been in a hall of mirrors, right? And you have a singular source which is producing a vastly different sort of reflection to what the source is projecting, right? And if you didn't know what the source was, you'd be very confused by the mirror reflection. This is the same thing that's happening with the moon. All craters are one crater. We're just looking at it from a different perspective, and this is key in one sense. I have to go, Jeremy.
Hold on, guys. Right, just before we get into Jeremy, I just want to shout a couple of super chats out. Cleary says, "Rumpus, any surveyed curvature?" ? And Rob Keane says, "Flat Earth data gets it." Indeed, both of them do. And before we get into Jem, actually, one thing, I've been having a discussion with a Glober in chat. Seem to be talking about this distance to the horizon, whether you're looking down or whatever. He was talking to me about being in a plane. And he said that from his 38,000 feet in a plane, he can measure 4 degrees of drop. Okay, so I asked him to figure that out in a calculator as to how far that would actually be, and he said that would be 100 miles. The problem is that the globe mathematics would say that the horizon would be 250 miles away. So how is that going?
Screwed.
So how is that working for you guys? How do you see a 4 degree of drop from 38,000 feet?
And Ranty, how does he identify the horizon? Because it's always a blurred line with the atmosphere.
So
it changes. Exactly. It changes. You could have said 69 degrees for 1 degree, so that makes sense at 4 degrees, but it changes, okay? It constantly changes. Plus, you got to figure the plane is green. Plus, the plane is pitched up at 1 to 2 degrees, or even up to 3 degrees.
Brian, in your brain, whoever has that image up on screen, in your brain, spiral that back into one source, and you'll understand you're in a hall of mirrors. It's waters above, reflective sky, right, of a certain contour. This is the key.
You said all this.
Ranty, what was that guy?
Okay.
Pete, I see what you're saying. I don't think it's that kind of conversation today, but yeah, I'm with you.
Okay, right. So, Rumpus, what was the guy called?
The guy's height. You said he said an observation from how high?
38,000 feet. So the distance to the horizon on your globe model should be 250 miles.
Check that. Hold on.
But he's calculating a 4 degree drop, which only puts it at 100 miles. Now, that's a problem. And he's a globe earther, bearing in mind.
Hold on.
And he actually
let's not forget.
And he actually said
the plane has got a 1 to 3 degree pitch.
Well, he actually
also,
said
so that makes it even worse.
Well, he actually said that that's close enough. He said,
yeah,
he said,
that's what bowlers do.
That's close enough. Oh, you can
That's
only
what bowlers do. Let me just say to Brian Leakey, Brian, you showed your grandchildren on air. I think I remember you one time doing that. Fair play to you, man.
Yeah,
we're dealing with the likes of faceless and nameless characters like Rumpus. They're Rumpus and Gem Panda. Oh, these passionate characters.
Yeah,
give them a certain leeway, but not beyond a certain point.
Just gonna let him make up stories about people. Then
what do y'all got to be scared of, though, man? I mean, y'all are on the right team, right?
I don't want to be part of that.
Because just in case, but I mean, I don't get it.
Just going to indulge a mad person's fantasies.
I'm mad, and you're faceless, right?
So, Ranty, So I didn't understand. So according to me, according to the calculations I do, he should have an angle of 3.4 degrees. If he's at 38,000 feet, that's the same as 11 kilometers, 11,582 meters, which should give you a dip angle of 3.442 without any refraction. You were saying he measured one of 4.8 or something. Did you say?
4 degrees.
4.
So
right,
he was close enough then, wasn't he?
Well, no, it's not. It's not.
Wait, let's not forget the plane. Hold on, let's not forget the plane is 2 to 3 degrees pitched upward. Let's not forget that.
What would that make?
You moron, Brian!
It would make 2 to 3 degrees
No, it
difference.
wouldn't. He's looking out the window. He's got the bloody thing horizon on. He's got a thing that allows for the how angled it is. He's orientating presumably a little foam thing with an app on it. It doesn't matter what the bloody plane. It doesn't matter if the plane's going vertically. You twat.
Okay, and does the horizon move around? Doesn't the horizon changes anyway, man?
I did have a question.
Why don't you put some common sense into the argument, man? You got no common sense, man.
Right, okay, let's bring this back to
If that degree changes, then you got a problem, bud.
Okay, listen. Let's bring it. Hold on. Let's bring it back to Gem Panda because I know that. Hold on, I know Gem Panda was waiting to.
This guy is stupid beyond
Rumpus.
belief.
I know that Gem Panda was waiting to get in with a question before.
Well, I wanted to ask about this angular resolution idea that has been put forward. And my questions are, if this is true, how do you intend to establish it to be true? And also, if it's true, where is the table that shows us what obstruction we should expect to see at a given distance and height and I don't know, whatever other parameters you chucked into it.
Well, hang on.
Yeah.
Why don't you go ahead and show us what...
Hold on.
Oh, shout over me.
Right, listen.
Hey, hold on. Rumpus would be ray tracing up to a dumbass airplane.
Listen, right.
Rumpus would draw a ray tracing diagram to an airplane.
Listen. My question, are you just going to shout over the end like a bunch of lunatics?
I would like Flat Earth Data to respond when you finish the question. If that's okay.
Okay. And the question is, where is the table that shows us what we should expect to see at given distances and elevations? And if you're claiming this to be true and you're claiming it's supported by the Rayleigh criteria, etc., how are you going to now establish it to be the thing we all consider to be true?
Okay, so if you look at the diameter of Earth, they claim it's 7,918 or 18 miles, right? Well, if I times that by feet, I get 41,807,000.4 feet, 40 feet. Okay. Now, if I square root that number and divide it by feet again,
he's definitely flat Earth data, right?
I get 1.22459. Now, the point is that they've taken our eyesight, which happens to be an apparent junction, and they've used trigonometry because they are measuring what we see. They're measuring what we're seeing. The calculations are going to be 5 feet. Look, let me finish. Hey, don't interrupt me. If you're 5 feet tall and you have an angular degree of 2 degrees, or 0.0213 in this case of a 5.77 foot observer, you do basic trig, it's going to tell you that there's a horizon line there. This is not based on anything but an angular.
Hold on. Let me get one quick point in.
Let me finish.
Let him finish.
Let me back you up here. Well, okay, go ahead.
So this basic calculation, it's no different than Eratosthenes going 500 divided by tangent of 7.2 degree, and he gets a 4,000 mile sun. He's not going to agree to that. So what he does is 500 times 360 degree circle divided by 7.2.
Okay, but so let me
finish. Let me finish.
Come on, man.
Let me finish.
Just saying a load of numbers, dude. It's meaningless.
No, it's not.
Jeremy is asking you how it works in reality, Flat
I
Earth
want to
Dad.
know, where's the table that shows me this? I think what you're saying to me is that.
Okay, well, look at your response, dude. You have to draw 400-mile-an-hour ray tracing up to a dumb up to an airplane.
Okay, listen.
I have a question.
Hold on. Could we just have it between, for the time being? I just want it between Gem Panda and Flat Earth Data for at least 5 minutes with no interruptions, please.
Okay, so
can I conclude what I was saying?
Ranty, I like when you're feisty.
If you look at basic geometry, Euclidean, okay, this is observing what we see, but based on what do you call it? An axiom, right? Well, there's a convergence there, part of the human eye, that seems to be neglected in the globe model understanding of vision. What's convergence, Gem Panda?
You're not answering my question, and I'm not going to answer any of yours until you've answered.
Okay, I'm sorry. Okay? So you're trying to ask me what standard.
Right,
you're trying to say what model do we view world in?
Your answer to my question should not require me answering a question.
That's true.
So where is the table? And I think what you're saying to me is that coincidentally, this actually works out the same as the Earth curvature calculator, more or less. Is that what you're saying? With all these?
No, I'm saying that mine is mine is accounting for angular resolution, which is reality.
Okay,
and what the curve calculator does is presuppose reality.
You're right. What you've said is absolutely correct in every way. Where is the table that shows me, that makes predictions about what I should see at given distances and elevations? And how are you going to?
So here's some basic.
You can't make that prediction because of refraction. You can't.
The military know it, Travis. Come on.
You can listen. You can based on the eyesight and the 1.22 diffraction limit. I'll tell you how.
The horizon rises to eye level.
I need to know how. I need to know where the table is.
Gem Panda, I'm going to give you the math.
That shows me.
I'm going to give you the math.
I don't want the math. I want the table or the calculator that shows me this.
I'm with Gem Panda here, Flat Earth Data. Does the horizon rise to eye level in a reality setting?
Why haven't you already drawn up a table showing what we should expect to see?
Everything I've ever encountered when it comes to measurement always puts the horizon at eye level. It doesn't matter what it is. It's never construed any other way. It's always at our eye level.
Then over water, Flat Earth Data, it has to be water, right?
So you don't have a table that shows us what we should expect to see at given distances.
So
the military
if we have 10 miles.
Okay. How are you going to establish this idea to be the truth, to be the established truth? How are you going to go about it?
If you allow me to get it out, you can use the calculation. If you attribute it, it's the same thing as arbitrary integers in any kind of measurement. It's arbitrary. It's just what we attach to it, just like money. Okay?
Oh, so it's just anything then?
No, it's based on the actual size. It's actually based on the size of the human aperture and the wavelength of visible light. The derivative is that.
Hang on.
The convergence
hang on, Jeremy.
The convergence factor of the human eye is based on that light and angular resolution, whatever it's subjected to being bounced off of.
Okay, Flat Earth Data. Hang on, Jeremy. So Flat Earth Data, you're just after admitting that the astronomical horizon is the true horizon where the water ends and the sky begins, because the horizon always rises to eye level. And if a dip is ever experienced, it's an illusory dip, which is what Rumpus has always been calculating for the geometric horizon, which is the illusory horizon. We're looking over an extended span of water.
It's
excellent.
Right. It's a visible
excellent.
when you have light entering a medium, which is also a debunk of the heliocentric model. The heliocentric model is based on everything happening in a vacuum, the way the light. Snell's law debunks that whole principle because it's actually of light passing through a medium. So there's a big oxymoron with the belief system of the heliocentric model and Snell's law.
Right. We know that Jeremy and Rumpus here are defeated long since, right? So it comes back to what the reality of things is. And you've agreed that the horizon is always accepted as rising to eye level. Now, Travis, I think, is in the panel here, and he talks about his ether band. but the visible or apparent horizon is always
Everybody
below
drink.
horizontal. So if the horizon always rises to eye level,
No, it
when
doesn't.
we see a
It never
target
does.
and it's
It never
mirroring,
does.
we
It never
have
does.
the
It never does. That's bollocks.
we have every excuse to understand that the water might be reflected.
Bollocks. The horizon does not rise to eye level. There are numerous videos on YouTube of people taking a water level device from sea level.
Wasn't talking to
going
you,
up
Rumpus.
100 hold on, going up 100 meters, then going up 1,000 meters, or was it 1,000 feet or something? And you can see that the horizon goes. We've got
over an extended span water with perspective, Rumpus.
Like we're using the little app that I was talking about earlier that shows the angle of what's horizontal, and you can see the horizons well below it. You just said something that's completely and utterly untrue.
Well, Rumpus, now that you're here...
Hello?
Rumpus, hang on, please. Hang on, whoever's talking there. Now, Rumpus, now that you're here, because we go back, 4 years at this stage, 2016, every image that you were presented, did you always need to know the observer height to be able to calculate what looks like the visible horizon?
Yes.
And when you try to explain anomalies with targets beyond that visible horizon, it was always invoking refraction. But you always need to know the observer height to calculate that geometric horizon, right? Is that true or not, Rumpus?
Yes, it's true. Yes.
Well, thank you.
Moron.
How's
that got to do with the price of fish? Idiot.
Hello, I would like to ask a question. Hello, I'm Khalid.
That destroys it all there, Rumpus.
Right, hold on. Crow XE, hold on. Crow XE's here, so it's been a while since you've been on, mate. How's it going? And you wanted to ask a question?
Yes, for that number 1.22 or whatever, this is for the human eye, but most of the
this is not for the human
observation.
eye, it's for everything.
Rumpus,
This is for
let him
everything.
finish. You don't know what he's going to say.
He said it was the human eye, not just...
Jeremy.
Oh, no, but he might be going to agree with you. You don't know. Just
He's on your team, dumbass. Rumpus ain't got no common sense.
He's a moron.
What I was saying,
You don't know that, Rumpus. You've only heard him say
I know. He's an idiot.
why this formula is only talking about the human eye. When
my boyfriend does.
we see it through telescopes or E900s, obviously with different, what do you call it? That opening is wider than the human eye. So why are we latching on that number?
The formula.
So do you know what limited diffraction systems are?
Hold on. Let me just answer this.
Do you know what
limited
can I
just spend 5 seconds?
If you do, then you'll know where the 1.22 is in all any device with a circular aperture.
Rumpus, shut up, Rumpus! The question wasn't to Rumpus. Shut up, Rumpus!
Rumpus, that wasn't for you.
That's to Rumpus.
That wasn't addressed to you. It was addressed to Flat Earth Data.
Yeah, know your place, Rumpus. We all know you're a liar, right?
Okay.
So
He's retarded. He's the best flat earth recruiter there is.
Okay, right. Let's hear Flat Earth Data's response.
If you go online and type in limited diffraction systems, you will see that it's in relation to anything with a circular aperture and a lens. 1.22, the idea is that either your sensor is more powerful than your lens, or your lens is more powerful than the sensor. But the derivative of the 1.22 is the maximum angular resolution of that light based on the nanometers.
1500.
It's about the nanometers of wavelength of light. You get the 1.22 calculation for the human eye, and the Aries disk formula. It has to derive from the standard 450 nanometers, 500 nanometers at a 0.004
You're not
or
answering
0.0.
my question.
You're just saying loads of numbers again. This is not compelling in any way if you're trying to make a point, dude.
The aperture of the human eye is for the human eyes.
You're
but
just
I'm
trying
talking
to
about the
sound
aperture
clever,
of cameras.
Jim,
Yes.
quit muddying the waters, Jim, and back off. Let him talk.
Well,
Listen, if you just go look at limited diffraction systems, it's in microscopes, it's in telescopes, it's anything to do with circular apertures and lenses. Okay,
We know
there you
this.
go.
Hang on. Hang on. Flat Earth Data.
Just because Jim doesn't understand, he thinks nobody understands.
But hang on.
Okay, so let's hear. Hold on. Let's get a response back from Crow, because it was Crow.
I didn't say I didn't understand. I said he isn't making a compelling argument if all he's doing is spewing out lots of numbers that people can't see. They haven't got calculations in front of them.
But
Okay, well,
expecting people to just visualize
let me just say
the equations that he's
Can I just explain?
No, you can all wait a second. You can all wait a second because CrowXE asked the question to Flat Earth Data, and I want to see if he thinks that that's a reasonable response. It was his
I'm
question.
trying to give him an answer.
Yeah.
Well, yeah, but he asked Flat Earth Data.
But you're Rumpus.
Sorry.
Yeah, well, hold on. Well, let's listen to what Crow thinks. Go ahead, Crow.
Here's my response. I know diffraction depends on only two things: the wavelength and the aperture width. That's it. So
Yes,
1 point.
that's on screen.
That's what I said.
The formula is
That's
on
what I
screen
said.
for you, Pro.
But
So
There
any
it is, on
limited
screen,
diffraction
formula.
system that contains a
Rumpus,
circular.
at no point has he disagreed with you. You just think he has because you jump. You
No,
jump
right.
to a
No,
conclusion.
you wait, Jen.
He's got no common
Let me
sense.
just hang on, please. Let me just ask Flat Earth Data.
Hold on, Pete.
When all these
Hold on, Pete.
hang on, please. When
Hold
all
on,
these
Pete, one
evaluations
thing.
were made, when all of these evaluations were made, Flat Earth Data, what were the limits of the human eyesight tested in comparison to, for instance, if did they have a straight stretch of 3 miles and see
Why are
what
we
they,
not dealing with Crow's question?
without incorporating Earth's
I thought we
curvature?
were
This is
dealing
my
with
point.
Crow's question. Can we deal with Crow's question? See if
That's
Say-
exactly the same question.
Hold
So
on.
say that again, Pete.
So, hold on.
So
Has Crow- is
when
Crow
all of these
satisfied with the
limitations to
answer?
human eyesight are evaluated, let's say they take a span of 3 kilometers or 3 miles, right? And is it gauged against what we should be expected to see over a curved Earth, or is it understood that it's a straight horizontal span? Do you understand? When we're talking about, let me just finish by
the
saying,
earliest-
when we're talking about images that we're evaluating here, Ranty has images going over 20 miles. What should the human eye, process and evaluate, and us get a reasonable reflection of truth? Do you understand my question?
Gibberish.
It's not gibberish.
Well, you're trying to basically sum it up as where they're neglecting a part of the human vision. We all agree a certain wavelength of light has a limitation. We already know that infrared light, like if we have longer infrared light, we can see farther. So that's why if you take a lens and you change the nanometers, you can see a little farther. You have a little.
I'm trying to say, Flat Earth Data, I'm trying to say that we know the ball, we know Rumpus and Gem Panda are actors, right? We're trying to get at the real nature of things and why this coincidence takes place.
Listen,
at the end of the day, it's already placed on a spinning ball.
It's called the New World Order.
Get some treatment.
It's called the New World Order.
Yeah, you're a lunatic, Pete.
It's called the New World Order, and what they have to do is they have to find another alternative to the word conspiracy theorist, and Flat Earth is it.
My eye can see many miles. It depends on the factors that we're taking into consideration here, right? This is what the ball earthers, Gem Panda and Rumpus, will take away from you, looking over an extended span. Now, if we can see further than what has been determined by official science as it applies to the eyeball and limited circumstances, Flat Earth Data, I'm saying we have to change our point of view, forgive the pun, right, and consider what we are capable of seeing over this extended span. And this is where the horizon rises to eye level, water being the medium all the way, all the reflection down to water itself.
It does not do that. You look at any person who made an observation at a height and they can show you where the horizontal is. The horizon.
Alberuni, tell us about Alberuni. What did he have any magnification abilities? Rumpus,
No,
to hone in on the horizon.
Didn't need to.
Why didn't he need to?
Hold
How
on,
would
let
he
me get
just
out of
pointed
point.
it?
Because
let me get out of point real quick,
Over an
Pete.
extended span, if you're out by a tiny percentage in angle, Rumpus, you could be out by many miles.
So what? It was 1,000
Exactly.
years
Hold on.
ago.
Hold on. Rumpus, can you draw me? Hold on. There's a question for Rumpus. Can you draw me a ray tracing diagram from the horizon to an airplane moving at 400 dumbass miles an hour? Huh?
You've got to do anything, you twat.
Because, man, that's how you rationalize. That's how you rationalize things. You try and rationalize things like with ray tracing all this stuff. And look, if that horizon is off by 1 degree, it's off by 100 miles.
Exactly, Brian, and we know it, and that's why you showed your face and your grandchildren. Rumpus is here. Yeah,
I've got to explain
Rumpus
to moron. He's just demonstrated so many. The fact he's unbelievably stupid. You measure the dip angle, you twat. You measure the dip angle, you twat.
How did he measure it, Al-Biruni, Rumpus?
Used
Did he
an
point?
astrolabe.
Did he
Yeah,
point
there
to the
is- there is
astronomical
no- you
horizon?
can't
Hey,
measure-
Rumpus,
Can I ask Rumpus a question?
Hold on, I'd like to
Rumpus,
answer Pete's question.
you measure.
I'd like to
Listen,
answer
Rumpus,
Pete's
you measure the.
question. Be quiet, be
question.
You measure the
be
dip
quiet,
angle, right,
be
Rumpus?
quiet, be
Rumpus,
quiet,
you measure
be
the dip
quiet,
angle, right?
Be quiet, you twat.
You measure the dip
I've
angle.
got
You
on
like
screen,
saying you
I've got
measure
on
the dip
screen,
angle.
I've got on screen what's going on with the Bruni situation.
Okay,
Here
so
we've got
listen,
Bruno.
do you
Be
ever
quiet,
measure?
Be quiet.
Do you ever measure?
Be quiet, moron. Be quiet, moron. The thing you
Rumpus,
measure.
know your place, man. Hear his question out, and then you can say what you have
Do
to
you
say.
ever
not
measure?
You do not.
Do you ever measure the human eye's perspective?
Shut up, moron.
Right.
Do
You
you
heard the
ever
question,
measure the
Be
human
quiet,
eye's
moron. Be
perspective?
quiet, moron. Be
You
quiet,
measure
You
the
should limit
dip.
Rumpus's ability to...
Okay, listen. Let's take
the eye's perspective.
This is just ridiculous.
Yeah, let's take some control. Right. Who's got an open mic that's not speaking? I think it's you, Brian.
Gem Panda, take control of your man, Gem Panda.
It's just
So here we go.
horrible,
Here's
really.
Right. Okay. So one at a time, please. Right. One at a time.
Here's Al-Biruni at this observer point here, and Brian, leaky brain moron, seem to think you're measuring distance and therefore the velocity is involved. No, you just measure this dip angle here. That's all you need to measure from the horizontal to the horizon. You don't measure distances, so the velocity doesn't get involved at all. You just measure that dip angle, and on a flat Earth, that angle would be zero.
But hang on, Rumpus. Hang on, Rumpus. Did he point? This is the point of my question, Flat Earth Data. Rumpus, he had no magnification abilities, so he must have compared the dip angle to an horizontal, right? By pointing straight. So, right. So, did he assume that you were on the ball and this apparent horizon was the geometric horizon, everything disappeared beyond that? Or did he consider as well, at the same time, which he should have done, that we could possibly be looking over an extended flat plane of water, and water in that great distance will act in a different way than water in the near distance?
He had a dip angle, therefore he cannot be on a flat plane, and from this dip angle you can work out the radius of the Earth. And he did it with an astrolabe. I think it was.
Can I ask about your drawings, Rumpus?
Hold on, the astrolabe.
Rumpus.
Hold on. The astrolabe that he used was very large, so he got a reasonable result. He did ignore refraction, but because he was coming up from such a high mountain, he was able to get a value that was 2% within the right value, because he came from a high mountain looking down. Therefore,
So who clarified it? Who clarified it after him, Rumpus? Who clarified it after him? Did he assume that it was a sphere he was living on?
I've just explained to you the dip angle not being zero means you're not on a flat Earth and you have to be on a sphere.
Right, but who clarified it after Al-Biruni? If
Many
can't be taken as a stalwart.
Let me ask Gem Panda.
The next person after him. Who clarified it, Gem?
Who cares? John Matthew did it.
I care because Al-Biruni was limited in his abilities in the 11th century. He was pissing into a pot outside.
You haven't cared enough to look and find out, have you? What about
so listen, guys.
There was no telephones or hookers or anything like that.
You're a moron.
In your drawing there, Gem Panda.
Look and find out what, Gem. Look and find out what. What record is there about what Al-Biruni
Well, let's
did?
see. Do you want to make the claim as well that since Al-Biruni?
I just asked you a question. Question.
Well, do I need to answer it? Let's see. Let's
you
see.
made a claim.
So
you made a claim. I asked you a question. No, I haven't made a claim. I asked you a question.
Let's see if we do.
I asked you a question.
Can I answer the question? Or are you just going to speak over me?
Do you remember what the question was?
Repeat the question and then make the answer there, Gem.
Okay, let me repeat the claim. We have made many, many thousands of measurements of the Earth's curvature since Al-Biruni did it 1,000 years ago.
Who's the first guy after him?
I'm not going to bother to support that. If anybody wants to claim that the opposite...
Come on, Jeremy.
Go ahead. Then I'll support
You have to say that at least it was clarified by modern sort of principles and modern technological capabilities that Al-Biruni was correct. Who was the first guy to say, yes, I clarified that he was correct? 400 years ago.
I have no idea. You know,
exactly.
No one cares, Pete.
Al-Biruni's son, maybe.
Yeah,
who cares?
Cousin.
Well, who cares? It's irrelevant. what? Of course, who
Science
cares?
doesn't care who the order. They just care.
My reality, my picture of reality isn't based on what Al Biruni.
Hang on, Gem Panda. You and Rumpus care because you've spent thousands of hours debating dumb flat earthers on the same issue. Now, when I ask you, Rumpus brought up Al Biruni. Hang on, let me finish, Jeremy.
We've had since Al Biruni 1,000 years ago. We have much more. We have much more.
Yes, but the point is, did he consider what he might be seeing over a flat extended plane of water?
I'll just
As a
talk
true scientist.
I'm just going to keep talking over you, Pete, if you're going to do that to me. Okay?
You've already spoken.
Okay. Since Al Biruni, we've made many thousands of measurements, okay? Geodetic measurements. Now, if you want to claim that we haven't, fair enough. I'll then get the evidence to say that we have. But I think we can all accept that that's been done. And I am not reliant.
Has Gem Panda, have this been done? Listen, this orthographic drawing you guys have, right? Has it been done?
Speaking.
This orthographic drawing that you have up on camera here.
I'm not going to answer.
You see that arch, right? You see that arch from the feet of the observer, right? You see that arch going.
I'll finish the point I was trying to make.
Come on, give and take, Gem Panda. Off you go, flat earth data.
So listen, in your orthographic drawing, right? Listen, in your orthographic drawing, from that 2 points there, right? You've got an arc there, right? There's an arc from the observer to the horizon. There's an arc, right? Well, there's an arc there, right? That's what your arc is.
Yeah.
So when I'm looking off into the horizon, am I seeing physical Earth curvature, or am I seeing the ground and rise and apparent junction based on the angular resolution limit of the human eye?
Got nothing to do with the angular resolution of the eye.
So then what's causing the apparent junction, the rising upward into the center focal point?
Well, you can see from this diagram here, we've got an observer. If we assume light rays are straight, then it will meet the horizon at this point here, and that'll be your apparent horizon.
Okay,
what's the
Rumpus,
problem? How's this difficult?
I was really clear. You just jumped over it again. Listen, you have an arc there. There's an arc drawn between the observer's feet to the point of the horizon. See, in reality, Rumpus, the ground doesn't actually rise. It's parallel. Wouldn't you agree? That's why it's an apparent junction, correct?
I don't know what you mean by an apparent junction. Are you talking about the horizon?
Okay, so I'm just going to repeat it again. I'm going to repeat it again for you.
It's all a fucking farce, I tell you that.
In your orthographic drawing, you have an arc. Okay?
You're referring to this green line here, are you? You're referring to this line here.
You have an arc.
Are you referring to where I'm pointing? Can you see what I'm pointing? This thing here. Are you referring to this
clarify. I'll clarify.
Are you referring to this green line here, twat?
See the observer's feet to the horizon line. You guys claim there's an arc.
Line here.
There's an arc there. Where's the arc then? If I'm not pointing to the arc, then what am I?
Give and take, guys. Again.
Can you see this? You cannot see what I'm just pointing at. This green line is the arc part of the Earth's surface. Is that the green line you're referring to?
Is it the arc? Is it the only arc between the observer's feet and the horizon line? Or is there more arcs?
No, that's the only one. Yeah, that's the
only one. A load of arcs.
So listen. In reality, Rumpus, the ground doesn't rise. It only appears that way. That's why it's called the apparent junction of the sky. That's why it's called
it falls to the glober flat earth data. All globers hold that the horizon falls away from us. Flat earthers, what do we decide? I say it rises to eye level.
It doesn't.
This means when we're looking over ocean waters. This means when we're looking. Hang on, Rumpus. This means when we're looking over ocean waters. Even though the horizon appears to dip, it's an illusory horizon. The ultimate horizon is the astronomical horizon.
Pete, but not Pete, Rumpus. You have to talk over Pete when he's trying to make a point now.
Right.
Yeah, but he keeps
and I made an excellent point.
Bring some evidence.
Right, Pete.
Rumpus, hang on, please.
Okay, can you let Pete finish just what he was saying then?
Rumpus, you can't entertain that. What looks like the visible horizon is not the geometrical horizon, give or take. Over a flat span, right? This visible horizon is an illusionary horizon, and the horizon always rises to eye level. That's why the astronomical. I'm nearly finished, Rumpus. I'm nearly finished. That's why the astronomical horizon is the real
Get
horizon.
some supporting evidence, because every piece of evidence you will find in YouTube and pictures that shows where the horizontal is from anything more than a few feet high, you will see the horizon is below. Let me finish. The horizon is below eye level. You will
Right.
find
So for the bowler, the horizon always has to drop away. Every point beyond your feet is dropping away from you. To a flat earther, can you entertain an opposing point of view, Rumpus? A flat earth point of view. That if it's not dropping away and it's extending over a flat span, Rumpus, let me finish. Can you then understand that the horizon would necessarily rise to your eye level?
Pete, on a flat Earth, the horizon would be eye level, but all the photographs, all the videos that we see show that that doesn't happen.
But they're illusory. Over water, water behaves a different way beyond a certain point, i.e. it compresses and reflects. Much distance is compressed into a short area.
Will show the horizon is dropping below eye level. You have no evidence to support.
Can I just say to the audience and anyone in the panel here, Rumpus has said that no one else in the history of Earth, right, or in the history of current science, has offered up this explanation in terms of the mirrored water layer over an extended span, except Piche. Is that right, Rumpus?
Stick in the head, yeah.
Okay, I might be, but
you are.
Are we not all sick in the head, the Rumpus?
Hey, listen, we've had another super chat from Cleary. He wants an answer to this, Jem, if you're around. Jem, any surveyed curvature?
Yes.
Jem Panda.
Oh, sorry.
Cleary said that he wouldn't answer it, so
yes, there is plenty of surveyed curvature.
Ranty's like the referee on the side of the ring, throwing monkey nuts into all the invaders.
So, but is there surveyed curvature, Jem? It's been surveyed.
Yes.
Could you tell us?
Many thousands of times all over the world. All of the world's land masses have been surveyed, right?
So if that's true, Gem Panda, then if I'm at an elevation, if I have high elevation photography and I have a particular size sensor, a particular size wide angle, I have a field of view. Inside that field of view, I'm going to be able to take topography of Earth. Now, I don't know if you've seen the data, but I have. And the data is basically laying, if you had a flat book and you laid material topography on that flat book, that's what we're basically looking at.
Okay, but you'd need to show. You would need to show that that's true, because I know that that's not true.
So listen, from the high elevation looking, looking down. Let me finish. High elevation looking down.
I was
from
talking,
zenith,
wasn't I? I don't know why you're interrupting, but go ahead.
High elevation from zenith, looking downward, being able to see a 6-foot observer's radius view. That 6-foot observer sees an apparent junction, but that zenith position doesn't see what the 6-foot observer sees. The 6-foot observer is telling the world they can measure physical curvature. A high elevation drone shot that's looking down with a field of view that matches from frame to frame, which is well over 50 square miles, like you said, at 60,000 feet. The point is that it's field of view frame to frame, and there's no curvature registered there, but yet a 6-foot observer is measuring curve. Give me a break.
Can I answer the question that Cleary asked me? Can I finish answering that question, maybe? After that monologue of more irrelevant numbers. Okay. Yes, curvature has been measured all over the Earth. All of the major land masses have been measured in this way. I think, according to Flat Earth data, the people who have been doing this, the different generations of people over the last 200-300 years in different countries, different economic, religious, political backgrounds, apparently they all just got it wrong.
It's just rhetoric now, Jeremy. You're not expressing your own point of view.
Wait a second. Are you saying that all the
support?
See, here's the thing.
He was saying at all.
Come on. This is not helping the audience.
You have all these previous cultures, right? Understanding where they live to the point where you had Sorrel celestial prediction methods, which was done in the 1300s before spherical geometry was introduced. So listen. Yeah, but that's the point, is that all these guys had it wrong too. And all of a sudden NASA has it right when you cannot even prove that in 2020 there's actual physical curvature without trying to reach for a space photo.
Okay. Flat Earth data is there beyond all the theater flat Earth data? Is there a singular source of all skylights? Come on, man. Come on.
A singular what?
I don't need
singular source of all skylights, right? And a flat Earth.
That's very good, useful, accessible evidence.
A single source there has to be
without any doubt that the Earth's spherical.
So the
I agree.
problem
Eyeball
is
Earth.
in,
Hang on, Flat Earth Dad. We agree with Jeremy. Eyeball Earth, right? Now, what might that mean, though? Is there something intact below that's divided above? What do you reckon? A singular source to all skylights is the question I asked you, Flat Earth Data.
No, I think it's attached to something charged through reflecting in, right? And then because of our atmosphere, because we have a gas is being produced at the lower part of our atmosphere, and we have an angular resolution limit. It's very easy to see a sun move away or any object move away and not reduce in major angular size like something in our personal atmosphere. So,
right, except we don't see that with any object.
Right,
ever.
so here's the thing: there is Gem Panda is not being authentic. There is documented proof.
Okay, what objects do we
sun
see
angle
change like that? Where
Let me
an
show my
object
screen.
moves away from us, but it doesn't change size. Give an example.
Actually, hang on. It's
Gem Panda,
perfect
you're
timing.
wrong. There is evidence of
Well,
the
let's
sun
see it.
changing.
Well, hang on. I have it. I have
Okay,
it. Perfect timing.
One at a time.
Ranty, I have it.
One at a
Perfect
time.
timing.
Okay, right.
I was
Pete,
actually going to
Shay.
ask Ranty, can I play this earlier on? So
Yeah,
Ranty,
okay,
perfect
Pete.
timing.
Is this going to be a bit of glare around the sun? Because
No, the opposite. The opposite.
expect me to take that
See,
seriously.
just so you don't, just in case you don't know, on Red's show, maybe last year, evidence was presented on his show, and it was taken off right away. He deleted the debate. So there is stuff that will show you that there is an angular size change in the sun.
Right. I'm going to show it to you right now. I'm going to show it to you right now. And we understand, how many times do I have to say it? We understand that Jeremy and Rumpus are playing parts, but we're trying to get to the reality of matters. So let me share my screen.
If you say that again, Pete, I'm just going to go. I'm not going to allow you
not
to
much
sit
to
there.
me.
Listen,
I'm trying to Flat Earth Data.
Listen, I'm not going to allow you to sit there making up stories about me, okay? You're not going to do that.
Right, nothing personal.
Okay.
Nothing
That's
personal.
I won't say that again then,
do when
Jeremy.
we're in a conversation with each other.
Let me, Ranty, let me, this is only a 40-second video, right? So it ties in both sides here. So the audience as well. We have to take concern for the audience, right? We're looking for clarity into what is the true nature of things. Now, when we look at the sun, when we look at the moon, and we think of a solar eclipse, right? We think of one covering the other because of relative sort of sizes and relative perspective. Now, when it comes to what the eye perceives and what actually is in reality, how can we discern these things? First of all, we have to have a sort of a fixed standard backdrop, and this is where the spherical ball Earth with the horizon always falling away to you versus the flat Earth where we accept that the horizon always rises to eye level.
Is there any evidence?
Conflict, right? So here we go. So I'm going to present this video.
Share your screen, Pete.
I'm going to present your screen, and I'm going to share my whole screen. Right. Can you see that?
Yes.
Right. Let me go full screen.
That's the sun with glare. I'm just going to laugh at you. Goodbye.
You are a
Hang on, please. Hang on.
I'm not even going to bother.
Hold on.
So I full screen. Well, before I press play, Ranty, yeah, you're probably commenting on all the links I have. But like, they're just honestly, this is like Germ Panda has been arguing the same questions since 2015 with sort of consistency.
Make up a story about me. Be careful, Pete.
Okay,
right.
listen.
I'm not saying that.
Okay, right. Listen. Play your video, please.
Gem Panda, you haven't advanced because you can you tell me the definition of convergence when it's in relation to the human eye?
Let me play this. Let me play this.
Yeah, just play
and everyone can comment on it. And let me just summate the point behind this video because I've seen it, right? It is that what we see does not necessarily represent reality. Now, in my own brain, I've gone on to say what the sun might be anyway, at least. But here we go. Let me play this. It's only 43 seconds.
Okay.
And he brings a camera. Yeah, I'll let it go.
Sorry,
Notice the clouds stay the same size. Notice the clouds stay the same size.
What is polarization lens?
Yeah, it's a polarizing filter, isn't it?
Yeah. So what?
So what?
Right. So what?
It can be just a neutral density.
Hang on,
it's
please.
a neutral
This is the
density
point.
filter that's adjustable. That's it.
Right, but this is the point, right? This is the point. When you tell me that the what do you call it? Let me stop sharing here. When you tell me that the angular size of the sun and the moon are roughly the same to our vision, when I measure the angular size of the moon, I have to have some extremities and some boundaries to measure via. Right? Now, when I'm doing the same with the sun, right? I have to do the same thing. Am I measuring what actually is as opposed to what appears to my eyeball? Right.
Yes, because
via the reality I place myself in, and that is the spherical ball Earth reality and the infinite space reality versus
Pete,
whatever flat Earth reality. That's it. I'm done.
Yeah, stop sharing your screen because you're roboting.
And Pete, this is not a solar filter; it's a polarizing filter.
A polarized, but you'd notice the clouds stay the same size, Jeremy.
That's what polarizing filters do.
Yes, but there's no variation then in scale, Rumpus.
Then why should there
They are
be?
not as bright as
Because
Oh
the
my
sun,
God.
as we're seeing it at the end.
Pete Shay, I don't know what you just showed there, but you didn't show angular size change of the sun, bro.
What a moron.
Is distorted through atmosphere, right? Hang on, please. This is getting to the reality of things that we'll all have to deal with.
No, it's distorted through two lenses, isn't it?
Yes, but hang on, Jeremy. When you measure the angular size of the moon...
Shout out to Good Servant for the $2 super chat, who says Jem is playing a character. Thank you very much for the super chat.
You've placed your crosshairs on that as a fixity. Now, there's also images of the moon shrinking to a size very similar to the sun, a size as we see there in the polarized filter. Isn't that very interesting? And it ties in with flat Earth data. What appears to the eye, well, how much can we trust it? When you talk about the 1.22
the cameras are the same thing. The cameras are.
Let me just when you talk about that, what tests have been done in the eye over distances of 3 miles?
Is this honestly what you guys have got to offer?
Yeah,
it's embarrassing.
I would like to tackle the main point that started this whole thing off about the confusion that flat Earth data did between the distance to the geometric horizon and the Rayleigh criterion. I just want to go
an excellent point.
And I want to go this for 60 seconds or so just to make the point.
Okay.
Right, so here we go. This is what flat Earth data did. He had this formula for the Rayleigh criterion here, which is this formula here, which gives you the angular resolution of the device, whether it's an eye or a lens or whatever. This formula here, where W is equal to the wavelength and D is equal to the aperture here of the lens. The distance to the geometric horizon is another formula. This is D to the distance to the geometric horizon, and it's equal to the square. This is approximately, but it will do for up to a good few tens of miles, if not more. Yeah, probably more than that, actually, 100 miles. Is just simply equal to the square root of twice your elevation times the radius of the Earth. So these two formulas, and then it just so happens that they come up to similar numbers if you have a 6-foot altitude. And so for some reason in his moronic head, flat Earth data has then said, right, because there's been this discussion of Rayleigh criteria, I'm going to mix that up with the distance to the geometric horizon and then mesh it together, do something, and then come up with the saying they're the same. They have got
Eyeball Earth,
nothing-
right? He just showed you, bro. He just
They have
showed
got
you.
nothing to do with one another.
Why does this apparent junction happens of the sky? What isn't that have to do with the angular resolution limit of the human eye? The apparent junction?
When you say the junction,
it doesn't.
Do you mean horizon? You keep on using these strange terms. Are you referring to this horizon here?
The apparent junction is not a strange term. It's in the definition of the word horizon. If you look up horizon in the definition, it says the apparent junction of the sky and ground.
Okay, you could just say horizon then.
Yeah, you could just say horizon. Okay, if that's what you mean by it, then
but
fine.
I'm being more specific for you so you have a little bit of time understanding.
It's
not.
Yes, it is. It's from the definition.
He's considering the honest audience listening, right?
Yeah,
Pete, let them talk.
Everybody else calls it an apparent horizon, but if you want to call it the junction, then fine. The rest of us will call it the apparent horizon.
The definition is the apparent junction of the sky and ground, bro.
Yeah, that's the definition of the apparent horizon. Yes, so
that's the definition of horizon. No, it's a definition. of horizon.
There's lots of definitions of horizon. There are lots of definitions of horizon.
Horizon is apparent. That's why they call it.
No, there are other horizons. There's things
Rumpus don't like definitions.
No, there are about 4 definitions you can have for the horizon. One is the local one. Let me just finish. One, for instance, is the astronomical horizon, which is actually the extensions and join this diagram. This is actually what's called.
Quit obfuscating, dude.
Damn. Twat. So this is actually the astronomical horizon. This thing here is actually referred to as the astronomical horizon, i.e., what the eye level extends to. Then there's the apparent horizon, which is where
the flat Earth horizon.
Be quiet. That's when the junction. Hold on, where the junction of the sky and the water meet. That's called the apparent horizon. There is a geometrical horizon. Hold on, nearly there.
Let's get all 4.
Nearly finished. Nearly finished. And the geometric horizon is the one where the horizon would be if there was no atmosphere.
Right.
Then there's also
List of
something
4.
called
List the
Rumpus,
four. No,
Rumpus, it
hold
doesn't
on.
solve your problem.
Guys,
There's
listen.
an angular resolution limit to the human eye.
Nothing to do with anything.
Accounting
We have
for
a
it.
point of agreement here,
First and
though.
foremost, listen. First and foremost, guys, can we just get Rumpus? Can you just list the four? Don't tell us what they do. Just list all four, one after the other, please. These four different horizons that you say is there. Just the names, nothing else.
Okay, here we go. There's the geometric horizon. There is the apparent horizon.
Who's typing?
Me. Sorry about that. I'm typing.
You're typing at the same time.
What?
Right, go on. There's a geometric. There's a geometric horizon.
There's the geometric horizon. There's the astronomical horizon.
Right.
And what's the fourth?
And then there is something sometimes called the geographical horizon.
Right.
Or topographical horizon.
Right. Now you've named the four. Now, can I just, for clarification, the astronomical horizon, Rumpus, is over theoretically over a flat span. The horizon rising to eye level. Is that right?
No, the astronomical horizon is this thing I've drawn here in purple. This thing here, your eye level. This is regarded as what's called the astronomical horizon.
Right. But you agreed over. But hang on, Rumpus. You agreed over a theoretical flat span. That's right, Rumpus. But I'm just connecting you and flat Earth data. You agreed over a theoretical flat span that the horizon would rise to eye level, right?
On a flat Earth, yes, the horizon.
Thank you. So flat Earth data, a flat Earther has also agreed that the horizon would rise to eye level. Those with ears hear. Okay, off you go.
Right, let me explain why that. Perhaps people don't understand why that would happen. So if we draw a flat Earth here, right, and then
all Earth, flat Earth data. I'm with you there, bud.
And so we then draw an. Whoops.
The issue is the issue keeps getting like overlooked. Listen,
that's because Rumpus is an obfuscator.
I know. What's causing the apparent horizon to apparently rise to eye level, even if it's a degree off, like you say. Even if it's a 2-degree dip. What's causing it to rise? Is it physical Earth curve, or is it the refraction properties of our eye and the angle of light?
Right. Basically, what you're saying is, if you have a picture of something, things further.
Our eye is a lens, right?
Answer the question. Answer the question, Rumpus.
Shut up. Right. So basically, your perspective, the fact that things further away seem to come up to rise to your eye level.
What's causing that? Is that Earth curvature, or is it?
He can't answer that.
Refraction index of our eye. We have a lens, right? That lens bends light upward into our eye, right?
I'm in the middle of answering. I didn't interrupt you. Jesus Christ.
Well, do you not agree that light bends up into our eye because our eye is bent? Like we have a round eye, right? So light refracts coming up into it from the bottom into the top, right?
Let me finish my answer, then you get a chance to speak. So, it appears to rise up due to perspective. That's what causes it. It does not rise up to your local horizontal.
Okay, so it has nothing to do with Earth curve, right?
Then there is refraction, which also raises things up a little bit more, but again, it doesn't bring it up to your local.
So the general convergence of our eye, would you say that is caused by the limitation to the wavelength of light and the angle of resolution limitation based on the aperture size?
Nothing to do with it.
Based on the lens of our eye. See, our lens of our eye has to bend light from the ground up into it and from above down into it, right? That's how a curved lens works, right?
Would it end up from the ground more than the air? Why not say it bends light from the higher up down?
So would you agree that when they look at your vision, and when you go to a doctor's optometrist, and you get your vision tested, they're going to divide your vision from like 30% above and 30% below, right? They're actually going to divide your lens of your eye. Now, the way I'm trying to conclude to the audience is that when you look down a hallway, you have the same effect happens, except for there are smaller angles. Therefore causing a quicker convergence. In other words, you don't have to see a large distance away, because your eye is responsive to the distance of light coming to it. So if you have a limitation to it, there's going to cause a diffraction limit. There's going to be a refraction limit. There's going to be an angular resolution limit. So these things don't exist in your math. Your math
that are too close to one another. That's got nothing to do with
your globe math, the heliocentric model.
Horizon.
The heliocentric model has literally taken.
What two close things can be to one another? What's that got to do with horizon? Particularly when you're looking at big math.
Listen. The resolvable detail to an object is based on obviously the angular resolvability of the human eye. That's calculable. The point of the matter is there is diffraction. The eye experiences diffraction. It's not in your Earth calculator. Your eye experiences angular resolution limits. It's not in your Earth calculator. Your eye has a limitation to visible light and its distance. That's also not in your Earth calculator. So there's none of those factors listed in your Earth calculator.
See the horizon. We do not have a resolution issue with the horizon. It's utterly irrelevant. The diffraction.
So listen, if you have a 2-foot object,
things are so
3 miles,
you can't see. You can see the horizon, so it's irrelevant.
If you have a 2-foot object and it's 3 miles away, and let's say it walks away from you, what happens to that object at that 3 miles for a 6-foot observer?
Yeah.
What would it do?
If that's a situation you're worried about, then yes, it will disappear. Well, not disappear, actually. We'll still see 1 pixel. But yes, then
it'll be blurry. It will be blurry. But guess what happens to it, Rumpus? Guess what happens to it? Because our eye has a size aperture and it has a refractive property, the angle of light is going to be limited.
And 2 ants, and you went further and further away from 2 ants. Well, what distance would those 2 ants become 1 ant? That's what the diffraction limit or the radius.
Listen, you can calculate. Listen, Rumpus, you can calculate the Ari's disk by taking the 0.007, which is the maximum angular resolvable detail of the human eye, timesing it by pi, dividing by 180, timesing it by the distance in meters and kilometers and miles, and you will actually get the size of the Aries disk.
There is no connection between that and the horizon. None.
Hang on, that's what I meant to say earlier on, Flat Earth Dad, is that the majority of the controversy between flat earthers and people like Rumpus and Jim Panda here is beyond the resolution of the eye into the resolution of the camera. So when we're analyzing all of these effects, and Rumpus specializes it over you, Jeremy, right, as you know, but yeah, this is what the decoding involves. And of course, as we know, the ball earthers say what they see, right? There's no possible decoding to be made into these images, i.e. they can't see 2 sides of the story. Okay, we're told the official story regarding the spinning ball Earth, right, and the geometric horizon. What if we're looking over an extended span? And that's where you and Rumpus, Flat Earth Data, would agree that the horizon always rises to eye level. And if we're looking over water, therefore it has to be water in that theoretical sense. And that's
made that up, Pete. You just made that up. You've no evidence for that.
You agreed in a theoretical flat Earth, right? Yes. The horizon would rise to eye level, Rumpus.
In reality, it does not do that.
But I said to you, you agreed that in a theoretical flat Earth, the horizon rises to eye level.
Rumpus, what do you explain happens in a long hallway?
Majority of the time.
Explain the difference. Listen, explain the difference between a long hallway and what you see as a horizon. They converge. They're just at different points, right?
Want to respond to Pete. Pete, you have no evidence that the horizon rises to eye level, and the fact that it doesn't do that invalidates the flat Earth.
Right, but Rumpus,
first-person perspective.
Hang on, Flat Earth Data. The true scientific mind, Rumpus. Hang on, Flat Earth Data. The true scientific mind can encompass many different possibilities to come towards the truth. So, as the opposing point to the spinning ball Earth and the fixed geometric horizon, you admitted earlier on, over a theoretical flat expanse, the horizon would always seem to rise to eye level. Is that true or not?
But it doesn't do that in reality. Therefore,
right. But I didn't say it did, Rumpus. I just quoted you as saying that if, in this theoretical sense, that was the case.
It doesn't do that in reality. Therefore, we can reach that model. That's
right. You missed my point here. Is in conflicting or contrasting the seeming positions of you and Flat Earth Data. Whereas Flat Earth Data is a flat earther, and he holds the water or the horizon does rise to eye level.
Rumpus, please listen to people when they're speaking instead of just talking over them.
I have a question. I have a question for.
Let me just sum it up then, Randy. Ranty.
Right, hang on.
So my
Everybody's
point was
trying to
beyond
talk. Listen.
Rumpus's literal taking of things. He agreed over theoretical flat.
Right. Everybody's muted right now, so nobody can. The only people that can hear anything is myself and the audience, right? So at that point in time, we had around about 6 people trying to talk over each other. And it's absolutely ridiculous. We've got all these people in here all talking at the same time, and nobody's giving any consideration to anybody else. So I've put them all on mute now, so nobody can hear what they're saying. Even still, they're still rabbling against each other. It's ridiculous. You need to take a breath. You need to take a breath, guys. Seriously.
One point. Pete says, on a flat Earth, the horizon would rise to eye level. But
theoretically,
but it doesn't do that. Therefore, we can reject that model.
Yes, but theoretically, I was just presenting the opposing argument over flat Earth. Would you agree, Rumpus, theoretically, that the horizon would tend to rise to eye level?
Yes, but the fact that it doesn't.
Thank you. That's all I stated, and you said I was wrong, and you spoke over me. That's all I stated.
Yeah, but don't you care about reality, Pete? Don't you care about
I do. So when I incorporated Rumpus, let me answer, please. When I incorporated flat Earth data as reality, this is for people listening who holds that we live on a flat Earth. Over an extended plane, over an extended span, the horizon will always rise to eye level. Over water, it's water all the way to eye level.
Find some evidence to support that claim, because you will find there is none.
Yes, but that's from your point of view.
Should contradict what you just said.
Right. Okay. Listen. Can we do a quick mic check with? Well, first and foremost, actually, Jem, because your mic seems really low. Can you just say something?
Oh, hi. I've moved it a bit closer. Is that any good?
Yeah, that's a bit better. And can we just do a quick mic check for Ruhif as well, because we've been joined by Ruhif.
Hey. Hello.
Oh, hi, Ruhif.
Jem's mic is fine, Randy. He's just jaded.
I am, because this is just. You know what? People talk about my server being horrible and toxic, but this is. I feel sorry for you, Ranty, because I hear you're trying, but this is 10 times worse than the conversation in my server. We would never allow this. It's horrible.
Do you want to promote your server? Do you want to promote it?
Sorry. That was a bit of a shame.
Anytime Rumpus is on, it's what you'll get. Rumpus is the.
I've been to your server, Jam Panda, and it's the same bunch of liars going over it. And I say you're lying for the good reason, right? The awakening of humanity. We have to come out of the illusion. So I don't take it personally, Jam Panda.
It's because you're a vile.
I'd have a drink with any of you. I'm not vile.
That has to disparage your fellow human beings if they challenge your absurd.
I don't do that. I'm trying to encourage our fellow. Jam Panda. Okay, just to contradict. Okay, Jam Panda, hang on a second.
Why would you think that? Why would you think that, Jim?
Well, hang on a second. Hang on. Just to contradict Jim Panda, are you capable? Hang on, fellow data.
About people who challenge his view.
Well, Jim Panda, are you capable of considering the alternative that, as opposed to a sphere with a fixed geometry, a flat plane, would the horizon rise to eye level over a flat plane?
I don't care. My question to you is, if you believe.
So I'm the one who's bigoted,
if
right?
all
I
of this stuff
can't
is
entertain
true,
different ideas.
If all of this stuff is true, how are you going to establish it to be true? That was my question about an hour ago.
Well, my answer, Gem Panda, is Aristarchus is revealed.
It comes in numbers.
Oh my god.
It comes in numbers, Gem Panda. It's the same reason why you have a server.
With ears here, Aristarchus is revealed.
Listen, before you start again, I understand that you feel that you can make a compelling argument. How are you going to propagate that compelling argument is my question. I don't want
everything is recorded. Everything is recorded. Everything you say, think, and do is recorded.
I'm
right?
still talking. Why are you interrupting?
Right, you've got the point across, though, Gem Panda.
No, I haven't. How do you know?
Jim asks him a question, then rambles on.
I'm about to make another point that you haven't heard, but you've just decided. No, he's said enough. It needs me to talk again, even though I've totally dominated this call, like I do every hangout. I'm just gonna keep blotting out.
Well, just get out the last part of your question then.
Pete, you've spoken about 10 times more than Gem Panda, and you won't even let him get out a full sentence.
I just said it.
Well, shut up and let him finish.
I apologize.
It's just so frustrating. You just.
I thought I got the point of the question, but if there was an extra point, you said I didn't get it because I didn't hear it. Let's have it.
Thanks a lot, Ranty. I know you tried. See you guys.
Yeah, we're all supposed to feel sorry now for somebody.
You've spoken more than anybody else in this hangout by
None of you can answer my questions. He just accused me of something that I can't. I knock everyone with a different point of view than myself. And I asked him one simple dichotomy. Can he entertain an alternative to a spinning ball Earth with a fixed geometric horizon, as in a flat plane? Hang on, Rumpus, let me finish. As in a flat plane, and how far would the horizon rise up to? He would agree with you, right? Which rise up to eye level over a theoretical flat plane, which agrees with flat Earth data and me and the rest of us over a flat Earth. It rises to eye level.
Pete, that's exactly what I do. Pete, that is what I do. I say, right, let's imagine we're on a flat Earth. What predictions does being on a... This is the thing I asked Ranty about now, whatever goes ago. What predictions would being on a flat Earth make? So let's go out and see if those predictions match reality.
Yeah. Let's go out and see, okay? Let's take...
Shut up, you twat! I was bloody...
I'm gonna answer your question.
You moron.
Define the components of the flat Earth.
Mid-flipping sentence. So what we do is you say, okay. I entertain the model of a flat Earth. And then say,
I heard your question, dumbass. I heard your question. Now shut up.
Now, so then predictions would that make, and then you go and test that against reality, and then you find they don't match reality, therefore you reject them.
Okay.
No,
well, let's.
hang on, Ranty. Let me just respond.
No.
To that,
I want to have a go at this one.
Hey, did Rumpus just remove me from that call?
Who?
It said you left.
Brian Lee.
Rumpus just removed me from a call.
Randy, let me just say to Rumpus very briefly.
I wanted to respond to that. I've been listening quietly.
Well, he hasn't defined all the components of flat Earth. So if you put yourself on a flat Earth, Rumpus, what is the sky? What is a possible alternative to the explanation given for the skylights given above? You haven't considered any of these things, and you
just utterly being talked over here by Pete Shea. I'm not sure he's going to be on the show much longer if he does this.
The horizon was at the same point at 120,000 feet as it was on the ground. Stick that in your pipe and smoke it.
What do you mean the same point? The same angle from eye level?
You know and you heard.
Yeah, I heard. I'm clarifying. The same point.
Brian, you're not just good, you're very good.
You need to measure it from the horizontal. Unless you're measuring from the horizontal, it's not you're not doing anything.
No
if you're not
horizontal on a ball Earth, Rumpus. There's no horizontal. Nothing can be defined steadfast as a horizontal.
Yes, Pete, there is.
You can only hide reality so much before it sneaks through.
Can I finish the sentence?
The truth will always sneak through, guys.
Can I finish the sentence? So when we do have horizontal on the globe Earth, it's where if you have a vertical that's pointing down to the center of the Earth,
Ranty, Rumpus keeps removing me from the call, man.
So that perfect.
Right, Rumpus, please stop removing Brian.
That changes. You shouldn't be given. Yeah.
And that changes an angle where on the Earth.
So there's no fixed definition. Hang on, then. There's no.
Let me finish. So for every point on the surface of the Earth, you have a different horizontal and a different vertical.
Right. So there's no fixed definition for horizontal. It's ever changing. For any individual on the surface of this Earth, there is no horizontal or vertical. If we point in what we think is a horizontal direction, it will never equate to anyone else's in a different spatial position as horizontal.
That explains this. Here's the diagram. So
then if something has no fixed definition, Rumpus, it's meaningless.
Let me respond to your point. So here is what actually happens on the spherical Earth and in reality, because we know that the verticals at different positions are not parallel. So you have lots of, for every position on the surface of the Earth, there is a local horizontal and a local vertical. And these local horizontals and local verticals are different for everybody on the Earth. So for instance, I've got Paul Voigt down here as a little block down here, and his vertical down is pointing in the almost opposite us.
So there's no fixed definition for it. There's no clarification or classification for it. It varies for every single individual. Rumpus, like children must become. You can't understand this as a listener, as a child, and it's not true.
Does this diagram not define exactly what the vertical and the horizontals are?
I understand your definition of it, but when you equate it, hang on, Rumpus, when you equate it to solid terms, right, no individual's vertical will be the same.
Rumpus, please stop talking over him. Please. He's just answered. He was giving his answer, and I'm sick of you talking over people. And that goes for you as well, Pete.
Can I ask him a question after he finishes?
Okay.
God.
That was a good point I made, though. Ranty, on a ball Earth, there's no horizontal, no vertical, because every horizontal and vertical will be differing necessarily.
When you see the
On a
whole
flat Earth, if we all point up in unison on the plane, we all point in the same direction.
You see the
That's
word
the dichotomy.
Okay,
here.
so Crow XE, you were trying to get something in then. I'm sorry, but you would kindly talked over there. So do you want to say your point there?
Yes, was asking, wanted to ask Pete. So, do you want to say that Australia and England should have the same horizon or the same orientation of horizontal? Is that what you're saying? And if not, then something wrong with the globe?
I like that question. Excellent. Is that Josie?
That's Crow XE. It's a glober.
I like that question.
Crow XE is a glober.
Well, he aimed that towards Rumpus, right?
That was towards you, Pete.
Oh. Apologies. I thought that was Josie for the first of all aiming it at Rumpus. Well, if you want to, do you want to go through that again? Well, let me just say, I got the general point. I say on a flat surface, right? If we all pointed up at this particular moment, we're all pointing in exactly the same direction. That defines vertical. When we all point 90 degrees to the vertical towards the astronomical horizon, horizontally, that's universal. When they make a $2 spirit level in China and calibrated in China, and it works perfectly well for a dumb paddy builder here in Ireland, 3/4 of the way or a quarter, whatever, half the way around the Earth, well, it's not because we are around the Earth, we are all on one plane where horizontal is an absolute. Rumpus has no fixed definition for horizontal, and that's my point.
And you can't see the Star Trek.
Horizontal is perpendicular to the direction of the center of the Earth. That's it.
Right, but you were after invoking the center of the Earth, and we were involved in this very discussion. What is the nature of the Earth? If you're already going to say the Earth is a ball, this is what we're disputing, bud. This is what Rumpus and Gem Panda and yourself have probably spent thousands of hours fighting.
I've got the definition on screen of horizontal, Pete.
We are presenting a model, and that's why we're using what the model says.
The model is busted. Earth has never been proven to move. It's always been assumed to move. I mean, if we understand, let me just say, get this out. This is the basic.
No.
Children must become. Let me get this out. And someone didn't let me get it out.
Yeah, quick,
let me get it out.
Come on. Everyone, let Pete speak. Come on.
Let me get this out. Let me get this out. Hang on, Ruhif. Let me get this out. Because this is the fundamental point. Back to basics. If the Earth doesn't move, then the sphere is ruled out on the basis of our universal experience with water, that at similar temperatures and pressures, right, i.e. atmospheric temperatures and pressures, water is always flat when still. Simple as that. Earth was always and ever assumed to move, and then the sphere came after the movement. Simple.
That's all good. But we are talking about the horizon on a curved Earth, and that's why we have to mention the center of the Earth.
Well, that's why I mentioned the $2 spirit level built and calibrated.
I have to ask this young fellow. I have to ask this guy a question. Listen. How far away is the horizon for a 6-foot observer?
I don't know, maybe 5 miles or something like that.
Okay, so can you describe what happens? Let's say it's 5 miles away. Can you describe what you're visualizing, what you see?
What I see is the meeting of the sea or the horizon and the sky.
Is that a physical thing or an optical thing?
What I see would be optical, which is not far. Most probably from the real thing.
So the clouds and the ground don't actually touch. They're parallel. Would you suggest they're parallel, or would you suggest they're curving over?
They're curving over.
Right. Okay. So your
because
angular
he trusts
resolution.
His eyes, right?
Yeah. So the angular resolution. Now listen, when you look down a hallway, there's a convergence that happens, right? A hallway is usually made of rectangular plane pieces. You'll see a convergence. You'll see the ground rise up, and you see the ceiling converge. That is not caused by the hallway, is it? Or is that caused by what?
Perspective.
Well, your eyes, right? Your eyes are causing the convergence.
No, eyes don't cause perspective.
So, well, your convergence of the light going in, the light going into the angle into the eye is what's causing the convergence. It's the limitation to the angle.
No, it's
converging at a
nothing to do with
point.
limitations whatsoever.
I get your point.
Listen, gentlemen.
Yes.
Listen, gentlemen.
Rumpus, if the eye doesn't cause perspective, Rumpus, what causes perspective?
Okay, I think I'd like Glenn to speak. I could just talk and respond to that, but I think Glenn deserves a chance to join.
Well, give me a brief response. If the eye doesn't cause perspective, Rumpus, what causes perspective?
The fact that you are a distance away and the light rays from the object causes perspective. I can draw a diagram.
You are a distance away. What? My leg? Is it my knee? My knee is a distance away. Is it, Rumpus?
Okay, I'll show you a diagram.
Fuck your diagram.
No, we don't need diagrams.
Here we go.
Rumpus, you agree that convergence happens in a hallway, right? You see it. We see it, right?
I'm going to say.
Would you agree? Let me rule. I want to answer too. Listen, if you want to accept something, you have to accept that the fact is that there is an apparent convergence. There is a vanishing point that happens. That vanishing point is based on light, based on angles of that light coming back to the human eye. Right. If you have smaller angles, you'll have a faster convergence.
No, so nothing faster. No, it's gibberish.
Well, it's just a word. It's an adjective to describe.
Here we go.
Here's an adjective. Let me finish. So this particular function of our eye you call and label as perspective, which is great.
But it seems that
your
eye.
Yeah, it's not a function of your eye.
So it's a geometrical principle of our eye. We cannot escape
Nothing
perspective.
to do with your eye.
It's not something we can remove. It's something we can escape. We see all angles of light pass through our refractive part of our eye.
Yeah. So does a camera.
The aperture. Yes, that's right. The 1.22 is in every diffraction limited system. The 1.22 comes from the standard visible light of the human eye. This is the
perspective has got nothing to do with refractions. I've got this diagram on screen.
Didn't say refraction, bro. Not there yet. So listen. Refraction is another side factor to the apparent.
To do with perspective.
Let him finish, Rumpus.
Refraction.
He's been speaking for 2 minutes now, and I haven't got a chance to respond.
Let him finish his point there.
Yeah, make him finish his point.
The point is that there is a convergence there, and it's independent of physical Earth curve. You're denying it. I don't know why. You want to conflate it as something else, when in reality it can be demonstrated clearly that there's a vanishing point, vanishing line. The smaller the angles, the closer the vanishing points, the closer the vanishing lines.
I have a question regarding the hallway. Regarding that hallway. All right. On a flat Earth, you are on a hallway, or there's a hallway in front of you extending to forever. Now,
right?
Would the roof get drop, and this the floor drops more than the ceiling?
But you can't have a hallway.
So listen,
hang on, Flatter Data. You can't have a hallway. Hang on, Flatter Data. You can't, and this is important to Earth as well. You can't have a hallway without a ceiling. You can't have a flat Earth without a sky. And this is where it comes back to when I'm directing certain questions towards Flatter Data. They're beyond the obvious.
You interrupted him, and I said there's a ceiling and there's a floor.
Right.
I say there's a ceiling and there's a floor. And do they converge with the similar angle, or one converges down more than?
No, to eye level, always. And that's where the eye comes into it, right?
Go look in optometry. You will see that the eye is divided. Usually a horizon line is a natural divide in the human eye, and it will be 30% above 30. Now, these are loose numbers. They can be calculated to be 28.6 degree, whatever, divided into 2. The point is, this is a cone of vision that we have. It's a standard. It's a geometrical principle with most eyes, because we. It's an integer, arbitrary integer to quantify many languages of experimentation.
To quantify our divinity?
Yeah. Right.
Hang on, Rumpus. You deny our divinity.
You and him have been speaking incessantly for the last 10 minutes. Barely anyone else has spoken.
Divinity.
Right.
I'm talking to a
I'm now going to talk about perspective here.
Shut up,
Pete. Here's a diagram showing what the perspective. Shut up, you twat. Be quiet, twat.
The eyes are the key to the soul. Rumpus denies we have a soul. Rumpus doesn't want us talking about the deeper issues that connected with flat Earth. Simple as that. He wants to get back to the same things. That's why he's called the Rumpus, and he's a faceless, nameless character. He swears that he's ranty. Get on your Photoshop.
Right, hold on, right.
Rumpus
No
swears
personal
by
attacks.
his character.
No personal attacks.
His avatar is genuine.
Pete.
And I say it's a Photoshop disaster.
Pete. Pete, there's no need for the personal attacks. Let's just stick it to the points.
Right.
I'm going to demonstrate how perspective works here. Here I have a little observer 2 meters high, and here I have a 3 meter arrowhead at 3 different distances.
Notice how he draws more cones instead of drawing the floor.
Why has my sharing been stopped? Who keeps on kicking me off the sharing?
I just shared my screen. That shouldn't kick you off, though.
It did, yeah.
Oh.
Yeah.
Oh, kick me off then.
That's you, is it, little devil?
Right. Look how Rumpus draws more cones instead of extending the first cone.
Here we go. So here we have an observer, and here we have 3 objects.
Hey, why 3 cones, Rumpus? Why not just 1 cone?
Oh, just shut up.
Be quiet. So here we have the effect of perspective, which is basically to change the angular size of something at different distances. And we can see here at 6 meters it's 28 degrees, at 12 meters it's half that, and at 24 meters it's then half that again. That is perspective. That has nothing to do. Notice there's nothing in there about the diffraction limit of anything.
Listen,
Rumpus, draw that in a hallway.
Rumpus,
draw that in a hallway.
Rumpus.
Quiet.
At what point is your drawing? What point does your orthographic drawing show the rising of the ground? What point does your orthographic rising? It doesn't show the rising to the ground, dude. It doesn't show the rising of the ground.
That's meters.
You're not representing reality. You're not representing reality, dude.
Did Rumpus leave or did he get kicked?
He said he left. That's what I read.
Wait, why don't he draw that same 3 cones of vision in a hallway? Everything he does is deceptive, man.
Right.
Yeah, everything he does is deceptive. Yeah.
The point is here, he's dealing with meters. Every image we are here for debate the controversy is over a manner of miles. Let's equate like with like. Have you extrapolated that to miles, Rumpus? And have you extrapolated?
I would like to finish my point.
Let me finish my sentence. Have you extrapolated in light?
I would like to finish my point.
And
Brian, you kicked me, so there you go. You keep on kicking me. Right. Right, so here we go. Here's the explanation of perspective. We've got 3 objects at different distances, and
Ranty, I'm getting kicked out repeatedly.
You keep on kicking me out repeatedly.
Right,
you little twat.
right, both of you stop kicking each other out. For God's sake, grow up.
He keeps on doing it first.
I'm not kicking you.
Well, it says Brian Leakey kicked me.
Questions here.
It says in the chat, Brian, that you kicked me out.
How do I kick you? How do I even kick you out? How the fuck can I kick you out?
Well, that's
right. Well, now that you know that nobody's kicking each other out, just keep your buttons away from kicking each other out.
Well, that's what Brian's been doing to me repeatedly.
Rumpus, before you continue, when we left off,
I would like to finish my explanation, and then you can come at me.
Quick insertion.
I would like to. No, I would like to finish it. I would like to.
Oh my goodness me! This is shocking. Grown men that can't just get along and just have a conversation. Just listening to these guys in the background is doing my head in.
You can see there is nothing about the diffraction limit that in any way enters into this equation, which should be obvious to anybody, gives you the angular size, which is the same as the perspective position, has nothing to do with the device about the eye or the lens or the diffraction limit. Now, go ahead.
Right, thank you. Right, so briefly, my point is the points of controversy here have been over a matter of miles, not meters. So have you extrapolated your findings to incorporate these extended distances? And also, my second part of the question would be, is that extrapolation against the backdrop of a spherical ball Earth geometry? That's been pretty clear now. And again, those with ears here. Let's hear your answer, Rumpus.
The rule I've got here, Pete, is absolutely independent whether you're on a flat Earth or a spherical Earth.
Why? How can it be?
Because perspective, it doesn't depend on what the surface you're sitting on, you twat.
But you've only analysed the space of 24 meters.
The perspective effect is only dependent on the distance from the observer.
Right. Right, but you talked about 24 meters, right? Hang on, Ranty. You talked about 24 meters, Rumpus.
Things. Glenn,
can I get my objection
This is me. I've shared my screen. So I know that Brian was asking you to draw it along the floor as well and to see the floor tiles as well. So I've actually done that. I'm presenting an image.
You've been busy, Shane.
I can't see you.
You can't see my screen.
No, not in. You're just showing up your avatar and
so. Rumpus.
I can see it.
I was doing
but
some research on perspective and what causes
I
it.
see it.
Do you know what causes perspective?
I just
the
described
angles
it.
that
Diagram, I just-
angles of light coming into
Go ahead.
whatever you're saying.
I'll let Glenn answer for me.
Yeah, perspective is just the
Yes,
angles
Ruhif.
between points coming into whatever you're looking at or looking with. Sorry.
So do the clouds curve? Do the clouds converge with the ground due to optics or due to Earth curve?
So again, do the clouds merge with the ground due to Earth curve?
Right, but you've decided
So the
Earth
clouds
curve,
drop
right?
in the distance due to Earth curve. That is the dumbest shit I've ever heard.
But it's not an open scientific mind,
you
though,
get 'em.
Brian. To consider that it might be down to perspective, as flat Earth data has been suggesting, and over a flat plane, things in the distance will seem to converge to an horizontal
Actually,
level.
both.
But no,
Ruhif.
but that's
So
the
listen,
consideration,
gentlemen,
though.
Listen, gentlemen.
That's a
Hey,
consideration.
Glenn, is it Glenn? Is it Glenn?
Yep.
It's Glenn, right?
Yeah.
Glenn, there's a rotation of the Earth. That's one movement, right? There's the tilt of the Earth. That's another, the equinoxes. That's another movement to the sun. Then there's the velocity around the rotation of the sun, right?
Yep.
Right. And then there is the elliptical path. It's calculated as circular, but it's elliptical path based on the seasons, right? So you have the equinox movement, then you have the season movement, right?
Get your point.
And then the fifth other motion, which is it's all traveling through the universe, right? The whole solar system is being dragged by the sun at 580 million miles an hour.
None of us feel a goddamn thing.
Do you think that it's plausible? Do you think it's plausible that for some reason all objects follow the path of perspective? If we're given wide enough angles, do all objects follow the path of perspective as they move away?
You went from the Earth's rotating, we're moving.
Five motions, right? The Earth has
So
five.
something is
motions.
moving, Fed. Something is moving, right?
Well, I understand, but I'm just trying to get him to acknowledge the five motions of the Earth.
Sure.
And yet the sun follows the path of perspective. So there's all these five motions involved, but yet the sun appears to rise towards us and appears to set from us, right? But it follows the path of perspective.
What is the path of perspective?
Okay, so we looked in a hallway. If I had a little remote control car on the ground, it would move forward away from me, and it would follow the path of perspective. It would appear to converge into the vanishing line or point, but it doesn't. It's actually on the ground still, but it will appear to converge, right?
Right, the path of perspective. Birds, planes, clouds,
That's
everything.
right. So it's called the path of perspective. Let's say you can kind of use your brain for that, right? So let's say we just sum it to a hallway and we just expand the angles. Everything follows the path of perspective. So in your model, you have 5 different Earth movements, but the sun follows the path of perspective. On top of that, in your heliocentric model, when you ask astronomy now, you say, what causes on a globe Earth, how do we see the sun and moon above the horizon at the same time? And it can be seen quite regularly, sun and moon above the horizon at the same time. They acute it to refraction. Okay.
Oh, you're talking about Selenians.
The issue is, I'm talking about Selenian yet. The issue is with refraction.
Right?
No, I did not. I'm talking about
did.
No, I didn't.
I
never said.
Let's keep it simple for the audience.
Every day, every day of your life, you will be able to see the sun and moon above the horizon at the same time. Okay. When you ask astronomy now that question, they equate it to refraction.
Let me demonstrate.
Let me finish. Don't interrupt, please. They equate to the Earth being in the center of these two celestial objects, the moon on the left, let's say the moon on the left in this orthographic image, moon's on the left, the sun's on the right, and Earth's in the middle. But based on atmospheric refraction, we have the light being refracted up. This is what your model states. Now, my question to you is, if they're refracting the model up, how do they calculate a 5-degree elliptical movement of the moon if it's refracted up? So it's like
there's no such thing.
Spotlight on you, Ruev.
Anyway, on top of the Seleninian,
I'm sorry, I have to interrupt you. You're saying a lot of wrong things. I'm sorry.
No, no.
I'm sorry.
Not at all.
There's no such thing as
Hey, don't hand wave it. What am I saying wrong? Don't hand wave it. What am I saying wrong? Don't hang wave it. What am I saying wrong?
Right?
No.
What you call my mama?
He says I'm saying something wrong.
He's trying to tell you. You keep on interrupting his answer. Shut up.
What is it?
Well, let him tell you, Fed, what you said was wrong.
Jesus,
Are you talking about a selenelion flat Earth data?
No,
it wasn't.
Earlier
No.
point
Okay.
of the
So then the
conversation, I was
answer
not.
to the question, the answer to your question of why we can see the moon and the sun in the sky at the same time, is that the moon is at up to a 5-degree tilt in either direction.
Okay, here's the problem, Ruhif or Glenn.
The problem.
In your model, it says that the sun and moon are refracted up. It has nothing to do with the 5-degree elliptical of the moon. It says it's refracted up. Now, that's my question.
That conflicts with the official explanation, Ruhif.
That's my question to you,
No,
sir.
I've asked
if you're excellent,
specifically, are you
listen.
talking about a selenelion? You said no.
No, again, you're deaf, dude. I've said 4 times no to you, and you're still
Then what's
sucking it like
refraction
it
got
was
to do
something.
with it?
Yeah, it makes
Let it go.
gibberish.
Listen, in your model, this is your heliocentric model. They claim, if you go to astronomynow.com and you say, how is it possible on a globe to see the sun and moon at the same time almost every day of your life on a ball? And when you ask this question, they'll tell you. And they'll give you a nice little orthographic drawing, and they'll show you that the moon is refracted up and the sun's refracted up through the atmosphere. This is what they say. And my question in science and for the math is, if it's refracted up, how do they get the 5-degree elliptical of the moon then? You just said to me, ignoring refraction, tell me that's not how it is, when you can actually go look at Astronomy Now and it's exactly what they tell you it is. They negate the 5-degree eclipse. You quantify the 5-degree ecliptical and negate refraction. In your model, you literally have to have no atmosphere for your math to work, but at the same breath, you calculate refraction.
Oh, castrated. You castrated him. FDD, you did.
Listen.
Can I say something?
Well, the question is for me. Actually, Crow, you go, and then I'll go.
Okay.
Crow, go quick.
First of all, the question was asked. That question, I am sure it's asked about the selenelian eclipse. That's the only case where. Second thing,
again, you can see the sun and moon above the sky all the time, dude.
Yeah,
not
and
just the
Rumpus
sun
is drawing it right now.
Yes, and we don't need refraction for that. That's the first point. We don't need refraction to see the sun and moon at the same time. It's only during the selenelian.
Are you saying that Astronomy Now and actually NASA are wrong? Because this is right on NASA's site, bro.
No, listen.
You're not listening. They claim on NASA's channel that the reason why you can see the sun and moon above the horizon at the same time is not because of the elliptical path of the moon. It's because of refraction.
You claim that.
This is right on NASA's channel, dude. So you guys are just pathetic. You don't even know your own model.
Are you talking about
you don't even know your own fucking model. I'm not talking about the selenelian. Listen, you can see the sun and moon above the horizon regardless of a selenelian. You understand?
Stop talking about
They can only perceive that as a selenelium. That's the only way they can understand it. They don't got common sense, man.
Dude, every day of your life, you can see the sun and moon together. Side by side.
Absolutely.
Not side by side, but left
we hear you.
We hear you. Pathway.
Listen. All right, can you see what Rumpus is drawing?
Idiot. Unless you're just listen. You know what's fascinating about Australia, bro?
Can you see what Rumpus is drawing?
There is an organization there that is doing both sides. Australia is the birth origin of conspiracy. They're the ones.
There you go. Now let's wait for him to come back. That was me, by the way. That's my first ever boot.
You can't do that, man. You can't do that, and you should be ashamed to do that. We know you're liars, man. Whatever flat Earth data's ultimate objective is, you're our liars here. Yeah. You should be given short shrift, and I've said that before.
Today, Pete, I don't give a shit.
He was getting
a
problem there yet to solve.
I have to say, it's not looking good for the Globers here. Keep kicking out the flat earthers. It seems like they're getting their asses handed to them right now.
Ranty, once again. Shane, hang on, please. Ranty, once again. 40-second video. PJ is going to bring two sides together and elucidate a comment. And this is for Brian Leakey, especially, right?
Could I just a diagram?
Let me just say this, please.
I've just spent some time drawing a diagram to answer the question on the table, and then someone just a nanoseconds ago bloody taken me off, so I could just finish this.
It wasn't me.
Well, hang on, Rumpus.
I know. Well, let me just bloody make this point. Hold on. Let me be very quick.
No,
really
shut your mouth. Someone will kick you out again.
I'm answering the question on the table. I'm answering the question on the table.
Place, right?
I'll be only 10 seconds. Here we go. So I've got the sun here. I've got the Earth here. I've got the light rays from the sun in pink. I've got the moon up here. Here's an observer here. They can see the moon and they can see the sun at the same time. Jesus Christ.
Yeah. All right. Go on, Flat Earth Data.
Listen. Let me just bring two sides together.
Hey, NASA. Or let's go to NASA's site and look up, ask the question, okay, because you're not drawing what NASA's showing. What you're doing is you're showing an orthographic to suggest that you can see the moon on the sphere. This is the problem. Is part of the pathway of the moon? It's on the opposite side, so it's not above on the center point. It's actually 180 degree across. Okay, so if you do 180 degree across, listen, don't interrupt me.
Are you talking about a selenium?
You are doing. No, I'm talking about any
you keep
moon
saying
cycle.
No, but you mean yes.
Any moon cycle of any time of the year, you can see the moon, sun and moon above the horizon. It has nothing to do with selenium. So stop it.
Listen, okay, so hang on, please. Now, we got your saying 40 seconds, Ranty, just like the last killer video, which reduced the sun down to its proper normal size, right? So this is independent verification for something I found 2 years ago. I think you probably know what's coming up. But when Flat Earth Data talks about the sun and the moon, as flat earthers, we've got to decide what the sun and the moon is, as Ruhif and Rumpus have gesticulated over much time at this stage. The official story is well clear. Well, this is a 40-second video, an independent sort of comparer, I guess. And
oh, Jesus, get on with it.
Right, I'm done now,
Jesus
Rumpus, with my
Christ.
introduction. Right, so this is, yeah.
Oh my God.
Listen to this. Shut your mouth, Rumpus. For anyone observing out here, right? This is for flat earthers. If it's all a different scenario than what we presented, I came up originally with the idea of the Milky Way and the weight on the moon, which is taking up a quarter of the moon, or a match. Right? Shut your mouth, Rumpus. You ignorant
He's just basically saying you can match a bit of the Milky Way against a crater on the moon. We're not interested in your sick, ludicrous, mentally deranged gibberish. Be quiet, and we've had it explained to you now about how you can see the moon and the sun at the same time.
Hang on, please. You got kicked out and asked for your 10 seconds, and I granted you your 10 seconds.
Why are you not adding any refraction in your model?
No,
in this model here, why are you adding any refraction?
I don't need to.
Well, this is how your model is explained. They explain to
you
how they see the sun and moon.
Here.
Has nothing to do with the Seleninian. Listen, has nothing to do with the Seleninian. You can actually go right now and go to NASA's site. They use refraction as an explanation of why the sun and moon appear. You're not. No, Rumpus.
Yes.
And has nothing to do with the Seleninian.
You've got it confused, haven't you? You've got confused.
No, buddy.
Situation with these. How do you
hold on.
You can see the sun and moon
say that.
Selenium, whatever it's called.
No, that's not in NASA's site.
So you claimed it had nothing to do with the selenium, and you said you could see it all the time. And I've shown you the normal situation. What you're talking about with refraction? Let me explain to you the thing you're talking about, which Glenn also spotted. Here is the moon, and what you're going to say is how come there have been occasions for an eclipse. We've got an eclipse. Therefore, when we've got an eclipse on the moon, we've got a shadow here. Determined here. So in other words, we've got an eclipse caused by the Earth's shadow. So I'm going to put that in black here. So there is the Earth's shadow, and it's eclipsing the moon.
You don't even know what he's talking about, do you?
I don't know exactly what he's talking about, and so does Glenn.
Flat Earth Data doesn't know what he's talking about.
Yes, exactly.
We asked directly.
Y'all don't know what he's talking about. You want me to tell you what he's talking about? Layman's terms?
Exactly. He doesn't know what he's talking about. So here's the shadow of the moon.
Put up that meme of the see-through moon, where there's no other half of the moon.
Earth. Here's the shadow of the Earth, and it causes the therefore they say, hold on, if you've got the moon in the shadow of the Earth, that means it has to be directly opposite the sun over here. So how come you can see both at the same time? If you're an observer, say
no, you're giving an apple answer to an orange question, bro. That's not what he's asking.
Right, please. Okay, let him finish. Let him finish. This is the best. This is the best. What we get the best answers from is when they're just allowed to speak.
It's a bloody explanation. So the point is, in theory, you'd say, aha, if unless you were right at this peak here, how can you see both of them? But the point is that the light rays from the sun and the moon refract. So in fact, the sun, because we know that you get refraction, the sun can appear when it's below the horizon.
Dude, you just said there was no refraction, you didn't need it, and now you're talking about refraction. It's just a nonsense with you, dude.
Shut up! I'm nearly
there.
In this one case,
pure nonsense.
Yeah, just let him finish, please. Let him finish. I want to get him to the crescendo of his argument.
Right, so they try and sabotage any complete argument, any complete explanation. So here we go. So the point is the sun is actually below the horizon here. I've just drawn it closer. But so this person should not, in fact, be able to see the sun. But because, as we know, when the sun is set, it's actually below the horizon because of refraction. So this enables you to see some things that are 180 degrees opposed to one another at the same time. And so you can see the shadow, which is caused by the sun, and the moon, and the sun at the same time because of refraction. Go ahead.
Now address his fucking point, dumbass. He's not talking about a selenium.
He absolutely is.
Y'all have no clue what he's talking about, do you?
Talking about, in effect.
I'm not.
Hang on. I know how to settle this.
He told you he's not talking about a selenium. Okay? When you got the sun and the moon at the same time. Oh my God, dude.
Yeah. I know how to settle this. Flat Earth data, post
can you
I'm
bring
gonna let him keep humiliating themselves, Randy.
Bring a site.
It's a rumpus tonight, Randy.
Flat Earth data, post your link.
Then you've got this situation where you can see the sun and the moon at the same time, no problem.
Rumpus, I posted a video earlier on which showed that with a polarized lens that the sun can be reduced down to
dealing with that.
Yeah, but hang on. What is the real sun? You would agree that there is atmosphere between you, the observer, and the sun on the horizon.
Don't distract from us. Here we go. So the wise flat earth data having a problem when I can show geometrically that the person that's here can see the sun.
Now do it without an eclipse, bozo.
It's all a psyop, Brian.
Flat Earth data needs to post his link.
Well,
is this an eclipse?
No, the same guys. These guys know the Earth is fucking flat.
What they're failing to understand. Okay, here's what y'all are failing to understand.
Well, here's the thing,
What you're failing to understand that if the sun is 93 million miles away and the moon is 240,000 miles away, and you got the sun and the moon in the sky at the same time, okay, and you got all that light on the moon that is it's not mathematically lining up, okay, not an eclipse, okay. Okay, the sun and the moon in the sky at the same time.
Post your link.
Yeah, if you want to post your link,
I guarantee you'll be selenium.
Okay, and we've also got hold on. We've also got CrowXE. We've got CrowXE in the chat, and he did a presentation on the sun on this show. I think he was the second or the third person to do a presentation. So, if anybody should be answering this question, I think it should be CrowXE.
He's gone, isn't he? Oh, no, still
yeah, okay. He did the Analema presentation. That was pretty good.
Post your link.
I'm going to establish the nature of the arena.
Hold on, I want to listen to CrowXE.
What the motivation of your opponents are.
Does nobody
this is a debate towards nothing, infinitely extending onward.
Pete, does nobody listen to me? When I sort of like say, CrowXE should be the one that speaks, why does everybody else then just talk and
he didn't speak, Randy.
He just started to speak.
Because you
Oh, sorry, I missed.
And I don't like you to repeat.
I did miss that. Sorry about that. My apologies.
So first thing, there's any case where the sun and the moon is hard to be seen at the same time, except an eclipse. It's very tricky. That's why some people are asking why or how can we see them. Second thing, during the eclipse, there is no the inclination of the moon is the moon, the earth, and the sun are at the same line, so there's no need to infer the 5 degrees of inclination. Second thing, regarding the refraction, that half a degree of refraction that lifts the sun up. Like one and a half year ago, I made a sun calculator on my own, just my own research based on the orbit eccentricity, the spin rate of the Earth, and the tilt axis, and it was good. But I realized there was like 20 minutes off, and I didn't realize that I didn't put that half of a degree of refraction. And when I put it, all the numbers came correct.
Right, and all,
I
did
know
you entertain an alternative hypothesis that instead of the spherical Earth modeling, you had a flat Earth modeling?
That would
but
be your
with
job,
a different
not mine.
source.
That's
Hang
your
on,
job.
please.
You are
Hang on,
smart
please.
enough.
Let me finish
You
my
are
question
smart
to the
enough
man. Excuse me, please. Let me finish my question to the man. Have you considered an alternative hypothesis and exhausted all possibilities? I.e., we're on a flat surface and there's a contoured surface above us. We possibly have a singular source to all skylights. Have you exhausted those possibilities?
Okay, Ranty knows because he asked me that question, and I
Sure.
said I did, but I failed. And since
Right,
you
but
or other people can be smarter than me from the flat Earth
no.
community, because
But is it true that you've been in Gem Panda's server for the last 3 years? What's the best
Don't know
argument
me,
that a flat
don't
Earth?
talk about
Excuse me, Crow. I know you under a different name. What's the best
Now,
argument that a
just
flat
give me a
Earth guy
question and
can
I said
offer up?
Oh my God, are we going to just change something completely?
Shut your mouth, Rumpus.
Yeah, okay,
No,
so
Pete, you're distracting the You're completely
Listen,
deflecting the
I know
conversation.
when I'm dealing
Be
with
quiet.
fucking liars
Shut
here,
up!
right?
Shut up! Stop
I
distracting
asked
from
the
the
man a
conversation.
question.
The
What's the
matter at
best
hand.
argument flat Earth can offer up,
Jesus
Rumpus?
Christ! Shut up, Pete. Let Crow finish what he was saying and stop interrupting and going on to some other stupid points.
He finished it.
Right, so here we have the two cases, neither of
he
which...
finished it, and you're on now, Rumpus.
I'm sticking to the point. We've got
I'm done.
Hold on, we've got flat Earth data, but apparently can't understand the simple geometry of this example here, of where you can see the moon and the sun at the same time. God knows why he's got a problem with that. We do not understand. The only
Where'd he go?
only problematic case is this selenium case, where you've got the moon in the Earth, eclipsed by the Earth, and therefore they should be opposed to one another, and therefore how the hell can you see both at the same time?
You guys claim Earth's shadow. You claim Earth is the...
You guys
Sun, the moon, flat Earth data. Get to the point. What is the moon flat Earth data? It's a flat Earther over 5 years.
Is refracted around the surface of the Earth, and therefore you can see both of them.
So wait, you guys believe the Earth's shadow covers the moon, right? That's the cause of the moon's shadow is the Earth's shadow covering it, right?
No! This is an eclipse, the special case. I've drawn this diagram here. Here you can see that the moon, the Earth is in shadow.
You get paid for this, man.
Nothing to do with the Earth, you twat.
Rumpus, you're probably on 100 grand a year for what you fucking do.
In that cycle there, that goes. In that cycle there, it doesn't enter Earth's shadow at all, ever.
Yeah. Post your link, Flat Earth Data. Post your link.
It does in lunar eclipses. So we'll have
There's not. Is there a lunar eclipse every month? I don't think so.
No, there isn't. No.
Flat Earth data. To accommodate the flat Earth, to accommodate the flat Earth audience out there. Flat Earth data. Your own in-person opinions. What is the moon? What is the moon in a flat Earth data?
Again, you distract.
Well, when I
shut your mouth there. I'm not asking you, Rumpus. I told you already earlier on.
A subject that filmed it. Flat Earth data.
Ranty, what is the moon, Ranty?
Do you want to keep up? Do you want to see this out, or do you want to go into bloody?
It's a fucking reflection of the sun. That's why the two of them are the same size, but they're reflecting off a contoured barrier.
Flat Earth data's problem with seeing the sun and the moon at the same time. Let's
shut your mouth, Rumpus. You can't entertain anything outside the thing that you're parroting.
You're a mental nutter. We don't need to explore your.
I'm trying to get to what is here. Flat Earth data. What do you think the moon is?
Do you understand why? Have you got still a problem with understanding why you can see the sun and the moon at the same time?
Rumpus, I'm gonna make this easy for you. I'm gonna ask you a question. Why, from the airplane or anything above about 20,000 feet, is it eclipse? During the eclipse, why does the moon look like a small black dot covering about 5% of the sun?
Brian. I can tell you why, Brian. I can tell you why.
Pete, are you talking about a solar eclipse now? So a solar eclipse is something different again. So you managed to distract. So here's a solar eclipse. Here's where the moon is in a solar eclipse, and it's because it's the same angular size as the sun. It obscures all of the sunlight. So obviously this sun is much too big and needs to be if it was much further over to the right, it would be the same angular size. And when we mean seen by the angular size, that means if I was to draw a line from here.
So you've never seen a high altitude eclipse, have you?
Hang on.
Right. So the angular size means that it's the sun would be the same as those things.
Right, thank you, Rumpus. Ranty, share my screen there with the audience, please. And Brian, this is to answer your question. Is it roughly the same size as what I'm about to share right now, Brian? And tell me this, because it's important, right? And I just shared this before, right? So we look at the sun.
Oh my God!
Hang on, shut up, Rumpus.
It's got nothing to do with
Brian. This is for Brian. Brian, we see the eclipse, Brian, and that's the moon. Does it go down to roughly that size?
Irrelevant. Utterly irrelevant.
Yes or no, Brian?
Utterly irrelevant.
I can't see it.
Can't see my screen.
Oh yeah, now I see it.
Does it roughly go down to that?
Just like, yep, about like
polarization.
Size,
yeah, exactly.
Excellent. Thank you very much.
Except the sun
and
stays
the fucking moon are
its regular
reflections of one
size.
another.
Nothing to do with flat Earth data than with seeing the sun and the moon.
Excellent, Brian. So we've just seen the sun go down to that size, Brian, and I've seen that images that you're referencing. Hang on, Rumpus. Shut your mouth, please.
They don't want this information getting out.
And
Get towards the truth.
the problem with
They gotta
understanding.
censor this,
Get
Pete.
towards the truth. We know your version of it. We left it behind.
Brian,
From airplane,
Hey,
the moon
gotta
does
censor
go
this.
to the same size as
My
the sun.
phone's got to die. I got to be back. I got to go charge my phone.
Okay. Ranty, can you
Can't
come and
hear
moderate,
an
please?
opposing point of view, but that's because he's given the ability to talk over people. Brian.
Well, Ruhif, I'd like to listen to Ruhif. You must have a point on this.
Yeah, but they
I'll-
gotta
I'll
censor
say
this.
that too.
Pete, they cannot let that information out, dude, Pete.
Of course,
they
I
can't
know
let that
that.
information out.
And Brian, this is what I'm telling you. The sun is a reflection of the moon is a reflection of the sun, right? This is why they're
That's
the same
awesome, dude.
size and appear to us the same size. But because there's an intervening medium, which is not just water vapor, but it's something else as well. Ether is a reality. But this is getting to the heart of matters. Rumpus, I know we'll go back now to arguing the point of flat Earth data.
That's an awesome observation, bro.
Retort. But flat Earth data hasn't told me what the moon might be.
until it's resolved. And flat Earth data has sort of hidden himself away now. I don't know whether or not he now understands why you can see the moon and the sun.
He didn't hide himself away. His battery died, so he just said he was leaving.
And Rumpus, science is about questioning. Have you any questions, Rumpus?
More than you could possibly imagine. Why?
Right, so tell me this, Rumpus. Have you imagined that if the Earth is not moving, then all changes?
Oh dear, I completely.
Well, so you haven't. So all you do is parrot.
How about we finish the point? Let's finish the point.
Yes, let's finish the point. Let's finish this point. Let's get to the crescendo of... Because here's the point, right? What Pete's saying is that you guys are saying that it's a physical object. We're talking about physical objects that you can actually fly to, land on, play golf on, and moon buggies and all that kind of stuff. And Pete's saying, well, what happens if it isn't actually a physical object?
Yeah, let's get to that after the selenium.
Yeah, which incorporates you accepting that it is a physical object in the first place. Everything to do with a spinning ball Earth is fantasy. But more than that, it's not just the musings of like...
You're going on and off again. You're trying to change the subject, Pete. You're trying to change the subject. Stop it. You're trying to change the subject. We haven't finished with this selenium. So why don't...
Right, okay.
Are exposed as well, right?
Right, tell us. Right, let's get this over with. I mean, you know, this is driving me nuts. Right, literally, just close up your point here, Rumpus. Tell us why we can see this selenium.
Okay, I'll make it again. The point is, it's a good question initially, raised by flat earthers. How come we can see the Earth in the shadow of the moon? In other words, there's a lunar eclipse at the same time we can see the sun, which would mean that the sun, in theory, is being blocked out by the shadow. It would have to be 180 degrees opposed, and it's basically the answer, as is usual with these things, is refraction. The sun, when we see the sun at sunset, it's actually already, if it's the bottom of the sun is actually touching the horizon, it actually means that most of the sun is actually below the horizon, but refraction has lifted it up, and that basically enables you to see the sun and the the eclipsed moon at the same time. I don't know if Glenn wants to develop that any further. Because he has
Oh no, it's refraction.
Yes.
No.
Okay,
can
so
you explain my picture?
So if
let's just get it. Hang on, please. Rumpus just as a polar.
He didn't make his point. Someone else. Crow was trying to make
that was a polar response. Let me give a flat Earth response now.
We barely heard from Crow
here.
Right. Okay. So if the sun, hold on. if the sun is moving at 15 degrees per hour, right? Okay, and you say there's less refraction if you look directly up, right? So there's going to be no refraction if you look straight up. It's just going to be the sun coming straight down.
Right.
So when you're looking at the horizon and you're seeing a refracted image of the sun, at what point does it change from being refracted to being the real sun? And at what point? Hold on. And at what point then?
I got a better question than
And at
that,
what
Randy.
point? Hold on. And at what point then does the 15% break apart? Because it should change.
As well.
All right, do you want me to answer that one?
I'm interrupting here. Ranty,
Yeah.
I didn't. Oh, Jesus Christ! Be quiet.
Choose who to answer, Randy.
Okay, clips to a filter.
Right. So here we go. So, oh my gosh.
We see-
Oh my god. Right. It's always refracted. Refraction is always happening all the time. It never ceases to be refracted.
Okay, so when we look through a filter, okay, I thought we're seeing the actual sun.
Right, so the sun is always being refracted.
Nice one.
And therefore there's no stop and start. And now when you said something about 15%, I didn't quite understand what you meant by that.
Right, so it's supposed to...
Quit kicking me off.
Not 15.
You keep booting me, man.
Not 15%.
Yeah,
it's
stop interrupting.
15 degrees, right? So the sun moves across the sky at 15 degrees per hour. So if you're seeing the sun at sunrise, the very tippy tops of it, and that's refracted, right? But yet you don't get any refraction if you look straight up, right? Because obviously, so there is going to be there's going to have to be a change between where it's refracted and where it's not, which should speed up or
measurements, right?
Right, so that's a good point. That's a good point. In other words, you're absolutely correct. When you look straight up, just following Snell's law, there is no refraction. The sun's directly above your head. You're looking straight up. That means that the layers of the The layers of the atmosphere are basically perpendicular to your line. Oh, shut up! Are perpendicular to your line of sight. So there is no refraction when the thing's directly above you. And gradually, there's a gradual function to more and more refraction until it gets to a maximum when it gets to the horizon. So the gradual increase
what about the polarized filter I just showed, where the clouds remain the same size, but the sun diminished to a fraction of the observable sun size as we all observe, which is the same as moon size.
Quit kicking me, man.
Oh my god!
Right, Ron,
I'd like to
figure it
give a
out.
complimentary answer for Ranty.
Answer that question.
What question? I'm confused now.
Yeah,
People
right,
kicking each other out.
I just showed a video.
you've got to take
I just showed a
control,
video
Ranty.
where the sun via polarized filter, right, was reduced down to a fraction of its observable size, as we would recognize if we were to put a measurement on the sun or the moon angular size. This is what we go for, the extremities. I just showed you a video where the clouds remain the same size, but via polarized lens, the sun decreased into a small ball, and it also relates to the small ball that the moon reduces down to, from what Brian Leakey was talking about there, from a solar eclipse from above the clouds. So do you understand that?
The clouds don't have glare. There's no glare for the clouds.
What angular size are we measuring, man? What angular size are we fucking measuring? This is my point.
The sun with a solar filter, so the glare doesn't overwhelm the sensor.
Right, so the sun with the solar filter reduces the sun's size, apparent size, down
Or
to
reduces
a
the glare.
fraction, in hundreds of percent, to its what it appears to us in real
No,
size.
what you're seeing without a solar filter.
Dude, he's kicking me out faster than I can join. He's kicking me out faster than I can fucking join.
Stop interrupting.
Will you both stop kicking each other out? I mean, I'm seeing that you kick it. I mean, come on, guys.
I think you've got to take control, Ranty.
What can I do?
That's a good question.
What
Come
can
on,
I
answer that
visit?
question.
What can I do? Can I reach through the screen and ring the necks for them? No, I
You
can't.
can determine who's interrupting the most and temporarily block them. That's a good idea.
Well, you
Whether
have
you
to have
think
some
it's-
bias and respect flat earthers a bit more than the bull earthers, but the question remains the same. If we're looking through layers of atmosphere, which mostly consists of water vapor, there's no separating the water
does
vapor
not-
from the air, right?
Okay.
I rule it.
Right, listen,
Let
we've
me
had.
ask you a question out.
Oh my
Right,
goodness.
If we're looking at a
Brian.
distorted version of the sun or the moon, what is the actual size? And as I've just shown, last 10 seconds, fuck's sake, last 10 seconds, as I've just shown by the video I just showed with a polarized lens, right? It will reduce the sun actual size down to a tiny dot, which is a scan fraction of the original sun.
Right. Who do you want to
Okay,
answer?
right. So I will.
Ruhif, answer that.
Okay, Ruhif, you can
Okay.
answer that in a second, but I do need to shout the super chat out because it's on topic. And putting your ears back, right? Rhett Priestley says, for $10, Rumpus, put the Southern Cross in the Earth's shadow, then go to the other side of the sun. Do we still see the Southern Cross? Put the Southern Cross in the Earth's shadow.
Would that...
Go to share screen again. Share screen again.
Okay,
That
right.
is impossible.
Yeah, I don't think that's possible. Yeah, I'm not sure that's possible. Yeah, I'd have to think about that. I don't think it's possible.
It's along the axis of the Earth.
Yes.
That would require 90 degrees of declination, not 23.
I can. Yeah, I'll show. Right, so I can show. Okay, I can explain this. So if we have the Southern Cross, which I'll draw as a little. Oh my God! Shut up. So here I've got the Southern Cross here, and it appears, I think, at an inclination. I can't remember. Perhaps Crow knows what the angle it is. So if this is the north. So if this is the North Pole. Let me draw on the north. So if this is the axis here, right. So if there's the north and the Southern Cross, I think. So that means the equator would be. Let's draw the equator in. If I rotate that by 90 degrees,
the sun would have to be perpendicular on the North Pole in order to have Southern Cross in the shadow of the Earth.
So there's the Southern
Southern stars are a reflection of the northern.
Right, so here we go. So here's the sun. Hey, be quiet, Pete. Be quiet, Pete. I'm in the middle of explaining for someone's super chat. Be quiet, you twat. Right, so here we have the Southern Cross, and it's I can't remember what the angle is off the elevation. It's something like that, I think. It's not. It's not close to the pole at all, the Southern Pole. So that means that it's below, in effect. So if we look at the ecliptic plane, so we've got the sun and the moon. Sorry, the sun and the Earth in this plane, and we've got the Southern Cross down here. There's nothing. Remember, the Earth. I'll draw the Earth moving here. The Earth moves like this in this diagram. In this thing, there is no position that the Earth can be in that it would not be able to see from Australia or some part of the Southern Hemisphere, the Southern Cross. So it's not a problem.
He's not here to defend his point, Rumpus. But will you accept that from the spinning ball Earth's point of view, perspective within the universe, everything appears to rotate in unison? Would you accept that?
Well, except
on a daily, nightly basis, on a sort of continuous basis.
Proper motion that the stars undergo as well. But yes,
I can tell you an alternative to your idea of motion, which is the transference from a minus 23.4 degree to the horizontal to the plus 24 degree travel or traverse every year, right? I say that over a flat plane, there's a singular source in motion. And what's been reflected against the sky mirror, I guess the best way is what's happening below. So as above, so below. No, I know it might be gibberish. Hang on, please.
We're trying to talk.
But at least you will accept that, Ruhif. At least you will accept that from the Earth's spinning point of view. The equator, the rest of the universe appears to rotate in unison.
Go ahead, Crow, or Glenn. One of you two. Can you just?
What was the original question?
This is not the old days the Earth discussion show.
I think before the Southern Cross question, I can't remember where we were. Then we had the Southern Cross question. I can't remember where we were before that.
Was it refraction?
The southern sky is a reflection of the northern sky. Everything apart from Polaris. Hang on, Rumpus. Shut your mouth. Shut your mouth. You're not the center of the show.
Yeah, no, Pete.
I want to talk. I'm not.
Crow's barely spoken.
Here. Shut your mouth.
I want to talk and say something.
We embraced it and we left it behind.
Be quiet, twat. Crow, go ahead for Christ's sake.
Yes, just to follow on your answer about the refraction of the sun, the half a degree of refraction.
Yeah.
Yeah. So I think I read that starting or above 35 degrees, it's totally negligible, and the more the sun goes down, it increases. And the effect on that, if you are using an equatorial mount, that the sun would be slowing down tiny little bit, that if you are zoomed in, it will try to escape from the view, unless you are using what is called King tracker. That's what incorporates the refraction, the effect of refraction, in order to continue following the sun or stars or any other.
Well,
That's it.
getting closer to reality for flat earthers out there to present the alternative point of view, the Rumpus, Ruhif, and Crow here are incapable of even entertaining, in any true scientific sense, on a flat Earth, right? Well, on a spinning ball Earth, first of all, we're told that the sun is the center and all planets rotate in an elliptical fashion around it. Now, on a flat Earth, if we can take some observations as valid, right? On a flat Earth, what should occur to us is that everything is rotating around us in an elliptical fashion. Right. This is about.
It's not elliptical. It's circular. You twat.
How can it be circular? In your model, it's elliptical, Rumpus.
No, it's not. The stars and everything rotate in circles.
Right. Listen, Rhett isn't happy with you. Rhett isn't happy with you. He says He says that you didn't go to the other side. You have not gone to the other side.
Sorry.
I can read the super chat again if it helps.
Okay. Right. He was asking about the Southern
Put the
Cross.
Southern Cross in the Earth's shadow.
But you can't do that. That's my point. You can't put it in the shadow.
Put the Southern Cross in the Earth's shadow.
You can't do that.
Then go to the other side of the sun. Do we still see the Southern Cross? So you've got to go to the other side. You've got to go to the other side of the sun.
No, the point is, it's the Southern Cross is below the ecliptic. Here's the ecliptic. The Earth, I mean, what is the point of me giving explanations? The Earth moves like this, you see. This is the Earth's orbit, going past the sun. This is what it does. So anything that is below the ecliptic cannot be, so that the stars here, the Southern Cross, cannot be obstructed by the you cannot draw a straight line between the sun, the Earth, and the Southern Cross, because it's below the ecliptic. So you can't do what he's suggesting. You can't draw the Southern Cross in the shadow of the sun because it's not in the ecliptic.
No, the shadow of the sun.
Whereas the
moon,
the
shadow of the Earth.
But the moon, because
No,
the
of
moon.
the Earth.
Hold on, shadow of the Earth. Sorry, the shadow of the Earth. You can put the moon in the shadow of the Earth, but you can't put the stars that are below the ecliptic in the shadow of the Earth.
But Rumpus, when you talk about the
Is this
ecliptic,
not clear? I mean, how can you not understand this, people?
are you talking about there is a fundamental north-south bias in terms of our perspective here on Earth. So we have the North Star and the Southern Star equivalent. And Earth, in fundamental principle, just moves in relation to this axis 23 degrees north of the horizontal and 23 degrees south of the horizontal. Is this the fundamental picture you're painting?
I don't know what that gibberish was. Here is the Earth. This is what it. Let me just get rid of some of these other ones. Hold on.
Yeah, see, you're not allowed to say something that was very coherent.
You don't understand simple stuff. I have to keep on. So here we go. Here's what the Earth does. It moves like this over the period of a year. So I'm now going to put it at the 6 months opposite. Here we go, and then it's going to go. Then it's going to carry on and go behind. So I'll put that in the behind position.
Yeah.
Oh, well, never mind.
Don't worry, Stuart.
Hey, Rumpus, I got a question. We'll bring it back down to Earth.
Have we finished
Rumpus.
the Southern Cross question?
Yeah, let's finish that first.
Yeah, okay, let me reword it. Okay?
Does the person who asked the question understand that you cannot get the Southern Star?
Rumpus is so passionate, isn't he?
Fair enough. I hear that answer. Okay, let me ask you a question. Okay, this question's for Rumpus.
You can only do that with things that are in the eclipse, which the moon does periodically.
What is the
eclipse? All right,
eclipse?
shut up and answer this question. Hold on, Pete. Hold on. Rumpus, if I'm out in free space, okay, and I'm falling over backwards, okay, am I going to see two star trails am I going to see parallax and two star trails off to the right and off to the left? Am I going to see parallax star trails if I'm in free space falling over backwards in one direction?
I've no idea what you're saying. Absolute gibberish.
I do. You should.
I knew I'd have to explain it. I knew I'd have to explain it. Okay, because if we're on Earth, we're falling over backwards in one direction, yet we're seeing deviation at the equator. Okay, so if I'm in free space, am I going to see that same parallax? If I'm in free space falling over backwards, am I going to see that same parallax?
What does that mean? Falling over backwards? I've no idea what you mean by that.
It means the star trails show fucking parallax. It shows star trails. Okay, I want to know, would we see that in free space? If I wasn't standing on the Earth.
Talking about a shot of the stars with an extended not time lapse, long exposure. That's what you're talking about. So you're seeing the circles that are mapping out the motions of the stars. Is that what you're talking
In
about?
free space, when I see star circles up to the right and up to the left, if I was falling over backwards, just like I said, if I'm falling over backwards out in free space, when I see star trails, when I see parallax.
No idea what you mean by falling over backwards and you see
Well,
parallax.
we see parallax here on Earth. We see star trails, right? We see star trails due to us falling over backwards.
Parallaxes. You
Because
don't,
us
do you?
You're
moving.
not falling backwards.
You're not falling backwards. B, you're not subjected to parallax. So 90% of what you've been saying is utter gibberish.
Okay, what do you mean? I'm not falling over backwards?
In relation to the star. Hang on, please.
So it's the stars moving.
Hang on, Brian. Rumpus. He's either falling forwards or backwards in relation to the stars because remember the North Pole is fixed. Hang on, please, Rumpus. No, hang on. Can I get my sentence out? Because remember, Rumpus.
No, he's got to suppress this.
North Pole.
He must suppress this.
Right? Everything revolves around it. That's why we can see it all around here.
The Earth rotates. If you're talking about the Earth rotating, yes, the Earth rotates. Yes, so what?
So falling over backwards in relation to surrounding stars, right around the central axis.
I what you mean by falling over backwards. If you're talking about being
on the surface of the Earth,
and the
Earth
Earth
on a fixed axis.
that means I do not understand what falling over backwards means.
Yeah.
Right, okay. So
rotating, basically.
Rhett Priestley just wants to finish up by saying that you're still not doing it right, but he has done it on with a globe and a light bulb.
Well, I don't understand how he cannot understand if the southern star is not on the ecliptic, then the Earth's shadow cannot cover the direction to this star if it's below the ecliptic. If it's down here and the Earth is orbiting up here, you cannot draw a straight line of light from the sun to the Earth to the southern star. It's not possible.
Remember this. This is all an exercise in mental sort of facility, right? How far we can go in imagining. If the Earth doesn't move in the first place, all of this is nonsense. It's fantasy, and that's exactly what it is. But it's not just fantasy; it's metaphor. Don't throw it out and recognize. Hang on, please. Don't just throw it out like we recognize the fakery of the moon landings and say, "Well, I recognize the fakery. I don't need to know anymore." No, the truth is always known. And the lie is built on the truth, and that truth applies to you.
Okay, well, whilst Pete is going on one of his monologues again, I'm going to shout out Darwin for the $10 super chat. It says, I'm an hour behind and Rumpus is rumpsing, so I guess I'll listen live to Rumpus rumpsing. Thank you very much for the super chat, much appreciated.
Right. So anonymity on the internet. That's the beauty of the internet.
Oh Jesus! Shut up.
Old friends.
Right. So hopefully, I don't understand how this guy cannot understand this southern star issue. I think I've resolved it as far as any human being can do. And we've hopefully resolved Flat Earth Data's problem with understanding how you can see the moon and the sun at the same time from this simple geometry. God knows why he thinks that's weird, because I'm sure he picked up the idea from this, as Glenn and Ruh have said, the Selenian case, where it is more problematic. But the fact that he doesn't understand this simple geometry here is just extraordinary. But I don't understand why this guy then is...
You get a woman soon, Rumpus.
What does this guy... Who was the name of the guy who had the problem, Ranty, who was asking about Southern Star?
That was Rhett Butler.
Red Butler. Okay.
Frankly, my dear, I don't give a damn.
Right, Priestley, okay.
In order to have the Southern Cross in the shadow of the Earth, that means that the sun is above the North Pole, perpendicular all along the year.
No. Polaris is above the North Pole. What's in a name? Sometimes everything. In the beginning was the word. Polaris Starkus.
I'm just addressing the question.
Excuse me, Crow. The primary reflection. Remember, this is an alternative point of view for you to consider. We all know the official story, right? So, Polaris, the primary.
No, I don't know the official story.
Right, the primary reflection of this is all about imagination, isn't it? We're all considering a different alternative. So the primary reflection of Aristarchus, the divided tree of life, this is what we remember at Christmas time. We get the cut tree, put it on the X, and then over the top of it, artificially light it up, over the top of it, place a star. That star is Polaris. Polaris is the primary reflection of Aristarchus. The secondary reflection is the sun. So the sun is the primary reflection of Polaris, right? And this is where the moon and the sun, as flat earthers, right? Why are the moon and the sun the same size? The globe explanation is that, well, cosmic coincidence. One is 400 times away, 400 times smaller, right? But, well, we know that's all nonsense as we get into the flat earth. So, yeah, they're both the same
Don't
size.
say we.
One is a direct reflection of the other. We're dealing with the hall of mirrors. All moon craters reduce down to one crater, which is Aristarchus, which, well, let me tell you, ultimately reduces down to one thing, the Big Bang, which is the sperm meeting the egg. What if the sperm was an inversion?
Can we just cut the crap? Right, so Crow, God's sake, say something to interrupt this utter gibberish.
Well,
I was just done.
Good.
Yeah. Regarding the moon and the sun, I was just playing around with these things, the orbit of the moon and the sun, and studying them. And then I realized that I, on my own, a humble person with high school science, I can predict the path of the solar eclipse.
Ranty, stop being dishonest and show
Stop
all
telling
the
me
stuff I
about,
sent
Arcturus
today.
or whatever. I can make based on
Anybody can presuppose a sphere,
Hang
dude.
on, Brian. Excellent, Crow. Bring it up.
Nah, but not anyone can predict the path of the eclipse.
Bring it
No
up
one
right
can
now.
predict.
And let's see what. Let's hang on, Crow. You made the claim. Bring it up right now. You, a humble person with humble abilities. Bring it up right now. Predict the next solar eclipse that I'm going to see over Ireland here. And let's see what factors you have to take into consideration. I think you'll find, Crow, and your name, Crow,
Ranty,
is
stop
very
being
specific,
dishonest
right?
and
Let's
show
go
all the
777.
stuff I
fellow at
sent
NASA
today.
who predicts the eclipses, he uses a geocentric model, okay? Right.
No, I don't know what they use, but I don't use that.
I'm telling you what they use. They use a geocentric model. The guy at
They
NASA
do not use
admits
a
it.
geocentric model.
You're a liar. You are a liar because you don't know. You're just blurting shit out, bro.
No,
I
I
looked
do
this
know.
up.
Hold on, I said hold on.
Okay,
hold on. I
Rumpus.
said I don't know what they use, but what I use is the heliocentric model.
What they use is called the
I'm telling you what they
topocentric
use.
model.
They
No.
even NASA even says they're not responsible because for the guy they don't say they're not responsible. They name the guy who does their eclipses, and that he uses a geocentric flat Earth model.
Exactly.
It's a old one too.
Let Glenn speak, for Christ's sake.
What they use and what things like stellarium and all those other things use is called a topocentric model, which means that rather than using the center of the Earth, the center of the sphere as the reference point, it actually uses your location on the Earth to determine what you'll see. It's very specific.
You are
in that.
talking blabberish. Okay, he uses the North Pole as the geocentric star and all the stars rotating around. Okay, he's been doing that for NASA for years. Okay, you're just blabbing shit, dude. You don't even know.
It's called topocentric.
Okay, listen, I just want
Things
to...
like stellarium have a topocentric reference system.
I want to get one last thing in. This is for the Rumpus. So, the reason he's not happy, he says, that you're not doing it to scale. So...
Yes, I know. Oh, God. And how am I supposed to do it to scale? You'd have one
You have a
dot smaller
computer?
than a pixel. It's like saying put the moon... Let me show you what the solar system looks like to scale. I've got a document here to give you some idea of just even trying to get the solar system, let alone a bloody star.
I saw when you did that, Rumpus. That was excellent work, and it's sort of a great insight into the obnoxious nature of our reality. The sun is right there, and you put it a million billion miles away.
Here we go. This is what the solar system is like to scale that I did.
I'd say about 4 years ago.
Yes, I'm trying to do a 3D version of it, but here we go. No, what's going on? Here we go. Right, so this is a to scale thing of the solar system. Right, here we go. I don't know if you can see this. This is what. On zoom in, you bastard. What's going on?
Twad. It's not a bastard. It's a twad.
Why are you not? Oh, it's gone down to the minimum. Okay, so this is the minimum scale I can put in this program. Will have me have. So there we have. Why? This doesn't seem to be everything that I. Oh God! Just screwed this up.
Rumpus, is it Patricia Steer or tranny or not? Is Antonio Subrat's a liar or not?
And Sonia Subarats is a liar, yes.
Well, he was writing her when he realized something was not quite right. Not you, Ryan.
How long have they been together?
I know, that's mad, isn't it? The two, Mrs. and Mr.
right.
Flat Earth. It's almost like it's scripted, right? And
How long-
Ruth being
how
hang on,
long have they been
Ruth.
together?
Astir also being castrated bull calf,
Yeah.
right?
How long have they been together, Pete?
About a year, I think.
Right. Do you reckon they've had sex many times in that time?
I reckon so. Well, as the story goes.
So, if Antonio Subarats is so transphobic, right, you would think after the very first time they had sex, he would just go, "Oh, I'm out of here."
Yes.
Right. That didn't happen.
Right, because I say it's all
happen until
theater.
after.
I say Ruhif. I say it's all theater, right? Theater within theater. Superats backwards is star I B us. Now, when I say what I say about R I star C H us, I realize it's all theater. And I was just going to say to Ranty as well. One thing we'll all agree, Ranty, is that this arena is filled with some great characters, right? That's for sure.
Sorry. Just having a bit of a fight finding this bloody document. Right, found it at last. Jesus Christ. Right, here we go. So here is the solar system to scale. So there is the Sun, Mercury.
Rumpus, I can't see the Earth and the Moon. I can't see the Earth and the Moon.
Well, that's something. That's a little treasure to come in a minute. That you'll have to wait a little bit on that one, I'm afraid, Glenn. Oh, it's now saving the bastard thing. Oh, gee, sorry. Give me a second. Right, it's finished. Good. Right, so there is the scale. So that's where Mercury is, and you can see Venus is sort of, it's roughly equal. So this is the ecliptic. That, in other words, these planets all orbit in the ecliptic, in this plane, or most of them do. Mercury actually is slightly inclined, and Pluto's way off, but most of them are sort of within a few degrees of this plane. But it's not quite the same. Right, so there we have. That's 147,000 kilometers. That's 147 million kilometers. So let's zoom in to where the Earth is to scale. So I'm going to zoom in a bit more. So we were at 5%, and I'm now going to move into 10%. Now that's not actually the Earth and the Moon. That is me zoomed in. There is the Earth and the Moon finally to scale, and the Moon is there, and the Earth, and that's a factor of 1,200 I've had to zoom in. So if I have to start drawing things to scale, you get into terrible trouble.
So quick question, Rumpus. As the light from the sun travels in straight lines, essentially,
yes.
Should the Moon not cast a shadow? It's almost ultimately full size on the Earth when we have
no, Pete.
No, I've actually drawn that.
Hang on, Rumpus, because of the scale. Just taking into account the scale there.
No, because it's.
Why should it focus? Why should it focus in on the Earth?
I can
focus in on something similar.
I've actually drawn that line in this diagram. Actually, that.
But why? Why should it focus in on the Earth if the Sun is separate to the Moon? Well, and it's traveling. All its light rays are traveling in
it's
fundamentally horizontal.
Right, so this ecliptic that I showed you here. When the Earth.
I think you're in trouble around this.
Right, here we go. So when the Sun and the Earth shut up! When the Earth and the Sun and the Moon are all on this line, then the Moon casts, and the Moon is nearer to the Sun than the Earth. Then
no direction in space.
Oh, Jesus! Shut up! The Moon will then cast a shadow, which I've actually drawn a line on this damn thing all the way from. Let me just see where.
Why would it focus in to a sphere of diameter 70 miles as opposed to
it's like saying if you hold a penny. It's like saying if you hold a penny in front of your face against the sun.
No directions in space, Rumpus.
Twat! If you hold a penny up in front of your face between your eye and the sun, then obviously the penny's obscuring the sun. And obviously that will only happen if you hold the penny in a particular place. Right. And it just so happens, let me finish, because the Moon orbits the Earth in this plane, or just about 5% off, it'll then cross it, and then it has to be pointed in the, because if it was exactly in the same plane, then you would indeed have an eclipse every month. But because there's a 5-degree angle, of the plane of the orbit of the moon, and I've got that drawn here somewhere as well, then it will only catch it, one every, whatever it is, 18 years. There's an 18-year cycle.
You fucking idiot. That's not what I'm talking about. I'm talking about the parallel rays from the sun as it casts its light onto the moon, as it casts its light further onto the Earth. We should get a full-size moon shadow.
No, they're almost
Because why
parallel.
would there be any central focal point? Why would the Earth be a focal point for the
Almost
sun's
parallel.
rays if it's just in every direction arbitrary? And another thing is the moon shadow should, excuse me, let me finish my point. The moon shadow should extenuate outwards because the sun's rays are going to be moving in an outward direction as opposed to parallel. Right?
If you draw a line, which I've done, let me just see if I could find this damn thing here.
Yeah, why wouldn't it be
nonsense,
versus on the
isn't it?
moon?
Is that the ecliptic?
Oh, nonsense, Brian. You know
Why
it,
wouldn't
right?
we get the same
No,
rate of
but hang
shadow
on,
on the
Brian.
moon?
Brian, that we're told. So if we see through the literal, we're told that the sun lights the moon. Well, hang on. If there's a container up there, and if space is not empty, space is not what it is. Well, what could it be? Water, for instance. Where did the Earth's oceans come from?
Right,
Well, we know
there
the
you
water
go.
is reflective. That last point, we know the water is reflective. So can we correlate two things here?
No, we
If the
can't.
sun is said by official science to be a reflection, if the moon is said to be a reflection of the sun, could it actually be a literal reflection?
We're not going to indulge or drivel. So here is the light from the shadow of the moon, and as you can see in this particular situation, I've drawn it when the moon will actually create a full eclipse. But actually, and it comes to a point just beyond the Earth. Now, when the moon is further out, this actually does not cause a complete shadow, and it actually ends. Actually, no, you're always going to get
in front of you.
There.
Okay. Wait. Does that scale the same for the moon shadow during a lunar eclipse? Does it scale the same?
Well,
or is it massively different?
But the Earth is much bigger than the moon, and therefore the shadow of the Earth.
That's why I asked you if it's scaled. Does it scale the same?
Sentence. This is all to
well, your tricky little response.
Up twat. So the Earth's shadow is much bigger.
Hey, I thought I was a twat.
That's why I said scale, you fucking idiot.
From the moon to the other side, the Earth's shadow is much bigger, and therefore the shadow.
So hang on, Brian.
So does it scale the same? Does it scale the same?
Right.
I don't understand what you mean by that, you twat.
So hang on, Rumpus. Hang on, Brian. So
Okay, let me
magnify
explain. Let me
that.
give some comments. Hold on, Pete.
All
Okay,
right.
so if the moon is blocking about 1/18 of 1%, okay, now judging that the Earth is bigger, okay, shouldn't it scale to where the Earth blocks the 4 times the amount of the moon? So the shadow should be blocking about 10% of the moon. Okay, does it scale?
For fuck's sake.
Now you understand?
The Earth is bigger than the moon.
That's why I'm asking, does it scale?
The geometry is the
No,
same.
it's nowhere
Geometry
even
is the
near
same
the
size.
same.
Well,
You just blurt shit out, dude. It's nowhere even near the same. Do the math.
Hang on, Brian. Let me pose this question. Hang on, Ruth. Let me pose this question, right? Because it's a similar point, right? Rumpus. So we consider this the sun, the moon, and the Earth, right? So if we consider the moon to be sort of like a magnifying lens, you know the way you hold.
No, it's not. I'm not going to consider it being.
Yes, but hang on, please. Let me finish the point.
That crap.
Let me finish the point.
No, I'm not
The
interested in
moon
you.
shadow should be normally. If the moon, excuse me, please. Let me finish my point, you little bollocks.
Discussing lenses. We're discussing
Listen,
eclipses. We're
If
not.
the moon, imagine you had a massive light directly
Shut up,
behind
let
the
him
moon.
finish his point.
We're not interested in that.
Right. Imagine you had a massive light just directly behind the moon and it casts a shadow in a parallel direction
We don't
all
care.
the way to infinite space.
We
right.
don't care about lenses. They do
Hang
not.
on, please. Let me finish my point, man. Right. Imagine you had a massive light behind the moon and you cast a shadow. Can you see a picture casting a shadow at infinite distance into space, which will incorporate the thickness of the moon,
Pete,
the diameter?
Can I say something very quickly?
Let me just finish the point,
Because-
Ruhev. We can all imagine that very easily. Why can't you
Look,
accept
I have
that?
to leave in like 1 minute, so can I just make a point and then I'll go? You've got a big sun and a small moon, all right? The
Sure.
absolute shadow that the moon casts will reach a point. It's like conical shaped. Do you understand
Right.
that? Right.
Yes.
Whether that point where it ends is in front of the Earth or goes past the Earth, that determines the size of the shadow.
This is excellent, actually.
Okay, if the moon is casting a shadow about 1/100th of its size, and the Earth casts a shadow 1/100th of its size. So you're not going to cover the whole moon.
Those ratios are meaningless.
That's just a wild number, but I'm trying to teach you scale because you don't
You're
understand.
trying-
You
let me
learn
just
shit
say-
out.
I've literally done this in GeoGebra.
Right, but you haven't considered all. Have you considered all options?
All right, I gotta go.
If
Hey.
all right, you're out of
Bye,
here.
bye,
right?
Glenn.
Well,
Yeah, see you soon.
yeah. What's the
Well,
point of this? For fuck's sake?
See you later, Glenn.
the shadow decreases not by a ratio; it decreases based on an angle and a distance.
I was talking about parallel
Can you
rays.
say scale? Can you say scale?
Let me just say, Brian,
The shadow of
parallel
the
rays.
eclipse is
I was
not
talking about
to
parallel
scale.
rays behind the moon and the shadow it casts, right? Well, we should be the diameter of the moon, and it should be on Earth. Rumpus is saying that this moon acts like some sort of a focal lens and hones the shadow, which should be, what is the diameter of the moon? To reckon about 2,000 miles or something like that. That should be cast on, but it hones into, hang on please, let me finish the point. It hones into 70 miles. So my ultimate question is, at what point, if we continue on with the magnifying lens analogy, at what point does it hone in to a 0 point? Are you saying it's going to be the
Annular
center of the Earth,
eclipse.
something like that?
Yeah. On the annular eclipse, it
So
happens.
what makes the Earth special then? Why would the Earth be a special focal point for the moon shadow in relation
not
to
the Earth,
the relative? Hang on,
the
in relation to the relative distances from the moon to the Earth and the moon to the sun, as Brian just pointed out about the scale. Why would the Earth be a special focal point?
Right. Hopefully, I can
said
show you this.
it's not-
Sorry, Crow, Karen.
Yeah. Okay. Yeah,
You're very
I
polite
was
with one
saying
another.
the size of the shadow decreases to create the umbra and increases to create the penumbra. And this increase and decrease is not up to the size of the object. It's up to the size of the light source, which is the sun, the angular size of that light source. Half a degree. That is, the umbra is less by quarter of a degree, and the penumbra is larger by quarter of a degree.
Right.
And that can be calculated.
Okay, so.
Well, can I join? Hold on. I want to
Hang
show
on,
this
Rumpus.
diagram.
Hang on,
No,
please.
I'm
If
gonna
it's your
show
side,
you
you pass
how
it over to
works.
him. Shut
No,
your
no,
mouth.
yeah,
You
and now
pass
I'm
it
going
over
to
to
come
him.
back and show
Hey,
you
Crow,
how it
if I go
works.
out and try to
So
measure
here
the
we
angular
go.
size of
There,
the moon.
Pete, is the light
If I
rays
go out,
from the
I'm not going
sun.
to let him
No,
shut up now.
I'm
I'm not
going
going
to
to
intervene to
continue
save
now,
you
right?
of us. Explain. There's the light rays from the sun hitting the moon.
Hang on.
So it carries on there to the moon. If we could just move that a little bit further
I'm
back.
going to let you do that because you're a faceless, nameless character, Rumpus.
There's the light rays. So if you have a point on the Earth, that's where the light rays, and we've turned it into a shadow here.
Just
Crow.
scale it in degrees, man. Scale it in degrees.
Hang on,
You
Brian.
keep
Let me ask
saying
Crow
like
this
degrees
question.
is opposite of scale.
Hey, Crow.
Scale it in degrees.
Brian Leakey. Right, so there we have the shadow of the moon. And there's the sun, like from the sun coming onto the moon, and then then giving a shadow onto the Earth. And there's no special focusing in here. It's a natural result of something being in the way, being in the same.
Brian. Right, fair enough. But Brian, do you know the most mysterious crater on the moon, the most mysterious object in our universe is named crater Aristarchus? Now, what if it's all storytelling, right? But
Okay, let's not move.
Towards the greater truth.
Let's not diversify from the point.
Crow a question.
No,
Randy.
stay on the point.
Well,
please.
come on, you let fucking Rumpus there speak for half an hour.
No, he rumpused it. He rumpused the point.
Right, okay.
He did. He did rumpus the point.
What did I do?
You rumpused the point.
And that's what I was trying to get in. The point was, come back to the angular size. If we look at the angular size of the moon, Crow, right? And we try to measure it ourselves, are we visually estimating the angular size?
What's the question again?
Right. So if we look at the moon, the full moon, in all its glory, as it appears very near to us, right? If we were to estimate its angular size, do we estimate it in terms of the visuals? In other words, do we point an X at one extremity and measure to the other extremity along, let's say, imagine the horizontal?
Yeah, I believe that's how you would measure angular
Thank you.
size.
Thank you. So I've just shown in a video, and Brian Leakey, Brian, you're my favorite flat earther if you're genuine, of course, but you also recognize that the moon shrinked to a size equivalent to the sun shrink, as I showed with the polarized lens. And that's
I'm a globe
far cry.
skeptic, by the way, Pete.
Right, okay. Well, yeah, you know what I mean by that. And me too, man. The Earth is a globe in a real sense.
I have.
And the Earth does move in a real sense. But the question is, Ranty, so Crow has just answered, right? Yes, we do it in a visual sense. We gauge it in a visual sense. But if it's an illusory thing, how can we say that the moon or the sun are 0.5 degrees in angular size?
The moon doesn't have glare.
Well, it does. And Channel Q showed a video. I think you've seen it as well, Brian. It was an eclipse, a solar eclipse above the atmosphere from a plane, and the moon, as Brian mentioned earlier on, shrinks down to a black dot, which fundamentally appears to be the same size as the sun shrink down to in the polarized reduction.
Right, so I want
the moon that shrank.
They have to,
Listen,
they have to interrupt that. They can't let that information out.
Don't go off this point.
All important.
Stay on this.
I'm trying to answer. I'm not interrupting.
No, stay that. Rumpus, please put that image back up, please.
Oh, sorry.
I had a question for you because you earlier on you'd been telling us how the sun heats up, different parts of the globe Earth at different times, yes, and they come they come in parallel, right? Don't go to that. Don't go to that image though. But
you don't want to go there. Okay.
No. I want to ask why.
You don't want to go this image then. You don't want this point I'm making here.
You're right. I don't want that image.
Okay, you want me to go back? Okay.
Yeah, show that image up your arse.
Right. So this image, you have all the rays of the sun hitting the moon.
Right.
All the rays. All the rays of all the sun.
I've only drawn in the ones that are forming a shadow on the Earth. I have not drawn all. Obviously, there's loads of other rays going out.
Yeah, go back to the sun.
If I drew.
No, just go back to the sun.
Go back. You want me to go to the sun?
Yeah, show us the sun in this image.
Okay.
Right, so all the rays from the sun, every single one of them, they're not coming in parallel, every single one is hitting the moon.
I've selected some rays I've selected the rays that are hitting the moon from the sun.
All the sun's rays.
Well, if I took the sun's rays, it would go off into
all the sun's rays.
Would diverge
they're not going parallel.
Yes, but these are the ones that form a shadow.
They're actually not going. Yeah, that's what's giving you the very small shadow. You're right, but you've told us before that the sun's rays come in parallel. Now they're not parallel.
No, I've never said that. No, they're near parallel. They're
no, now it's near parallel.
No, you've never. You obviously didn't.
Hold on.
Listen.
Your knickers in a twist, Rumpus.
Hold on.
Yeah.
You didn't listen.
They are okay.
All the sun's rays are hitting the moon. No. And then all the sun's rays, because the sun is so much bigger than the moon, is giving you a smaller diameter for the shadow that hits the Earth, right?
Correct.
But the sun's rays hit the Earth parallel.
No, they don't. They're different. They're 0.5 degrees. The sun has an angular size of 0.5 degrees. That means that the light rays from the sun are quite close to parallel, but not quite. I mean, if it's an issue to do with their parallelism, that's what you want to focus on. Then we can say they're not parallel. If there's an approximation for other discussions, you can talk about being parallel. It depends what you're just talking about. But if you want to get picky, then they're not parallel.
So all the sun.
So how did the moon shadow get to 70 miles on Earth then, Rumpus?
Well, by drawing this diagram. This diagram I've got here, you can see.
Parallel in relation to the scale.
I mean, you are a moron. You just need to have your heads examined.
That's a good question. If they're parallel, 93 million miles on one side, Ranty, in relation to a quarter of a million miles on the other side, they're parallel all the way in.
There's a point on the Earth that is about 50 miles across that will be obscured by the moon at this distance. That's all back.
Imagination.
where they hit the other side of the moon, and that causes a shadow of 50, which will become when the umbra will be 50. And here's the picture here.
Okay, well hold on. Go back to the image. So why would the shadow start to shrink?
Yeah. Well, that's what I asked about the focal point.
Why would the shadow start to shrink?
Because the moon, sun is not. These rays are not.
Go on.
Yeah, we know we're a twat. So your basic point is why? I think your question is basically why doesn't the shadow on the Earth equal the same size as the moon itself? Is that your
yes?
Point?
And it should do.
That's what I said.
And it should do.
Listen, I explained to you earlier when you first asked the question. The light rays are not parallel. There's a 0.5 degree here. This represents a.
But this isn't a light ray. This is a shadow.
Yes, but they will diverge as opposed to converge, Rumpus.
This is a shadow.
Son, that angle I've got here is 0.5 degrees. That's what this angle represents. And the moon has got an angular size of 0.5, and so has the sun. Yep. And that triangle, code,
the shadow, the shadow wouldn't shrink.
It would.
It wouldn't.
Okay, let me show you another diagram.
No, you don't have to draw me a diagram. You can if you shine a torch.
You're stupid. I've got to show you with a simple diagram. Because you're stupid, I'm having to no alternative. So let's.
Get a host like that, Rumpus. He's giving you a voice. It's ugly. Only give you 20 seconds the other day.
Here we go.
When will be my turn?
Try another way.
Here we have a big sun, and here we have the small moon. I'm going to put that as a moon. And it's not to scale, remember, this is not to scale.
So these won't be coming in parallel. These will not be coming in parallel then. These will definitely be angled, right?
These will not be coming in parallel. So because their thing is, let's make them a little bit bigger. It's not to scale, remember, but this is what's happening. So there's the moon. Let's make that the Earth. And then we light ray.
So we know what you're doing, Rumpus.
Yeah, the top rays and the bottom rays of the sun, Randy. What about the middle rays passing through the moon, Randy?
So hold on. Why is the sun's rays attracted to the moon?
So the shadow of the moon is smaller than the moon itself. There you go. Go ahead.
Yes, but the Earth is bigger than the moon, Rumpus.
But it wouldn't be.
So what about the rays from the center of the sun going parallel to the moon?
Rumpus is wrong here.
We're talking about the shadow here. What Andy's complaining about is this shadow here, this shadowed area here, is smaller than the moon.
That's my initial point, you fucking idiot, when I talked about a magnifying moon and it focuses in.
And I've just demonstrated it's a twatty argument.
Right.
But no, it's not. Where do those rays meet? If on the surface of the Earth, they're 70 miles across and the moon is 2,000 miles across, where does the focal point meet? I reckon, Randy, along the center axis of the Earth.
When you have a light source that's bigger than the thing that's being shadowed, it makes a smaller umbra than the object. So this accounts for why the shadow of the moon is smaller than the moon. Hopefully you understood.
Okay, but Randy's right. But let's talk about the rays coming from the center of the sun, parallel to the moon and the Earth. They will cast a full-size moon shadow, right? Because the sun is emanating in every direction, right, Rumpus?
You're a twat. I've just shown you that the rays that are coming from the center will not meet. That's the whole point. That's what makes the shadow. This area here is in shadow.
What?
This area here is obviously all in shadow.
But it wouldn't be, would it?
Right, okay, right. Point something at a target.
Right, let me have a go at this.
With a flashlight and you get a shadow directly behind.
I want to have a go at this.
Very simple. So
I want to have a go.
This whole area of the moon.
Right, I want to have a go. Right, so, okay, Rumpus. Take away what you've just drawn, apart from the three objects, the sun,
well, no, I want the shadow there. That's the thing I want to leave. That is the shadow of the moon.
No, I want to draw a different shadow, and you tell me why it's wrong.
Well, no, I'm going to leave that one there. Okay, I'll try and draw something else.
No, just get rid of the lines. Well, no, just keep everything there, right? Okay. So now what I want you to do is draw a shadow the same diameter as the moon, and draw those lines hitting the Earth.
You want me to draw a shadow that's the same? So you want me to move? Okay, do that.
You don't have to move anything.
I do to get the shadow. You want something to be that size on the Earth.
Yes.
Basically. No, I didn't. Right. So let's got that in slightly different colour. So that's the shadow you want, which obviously is quite a bit bigger. So in other words, it would make the shadow would be bigger. But the point is,
no, draw the shadow lines, not the actual shadow on the Earth. Draw the black line. You've got your black lines in a triangle. I want you to draw them parallel lines.
Okay, so you want me to draw
parallel shadows.
Okay, you want me to draw parallel lines. Okay, there we go. So I'll make this solid. Why have they become dotted?
No, just from the moon to the Earth. The shadow won't come from the sun.
Well, that's what. Okay, yeah, okay, right. Okay, yeah.
There we go. And then there we go. Right. That's
but
what
the
would
point
happen.
Is, Francie, if you're here, you can see the sun. If you're at this point on the Earth, the sunlight can get to you. So it's
how can it? Because those light. Hold on. Just hold on.
Right.
Hold
the surface of the Earth.
Hold on. Hold on. Right. Hold on. And listen to. Hold on. So.
Stupid.
So hold on. So.
My God.
Oh my God! If you don't. Right. So you see the top one. You see the top red line that you have.
Yeah.
Okay, so the sun has already used its light to hit the moon, right?
That's just above it then. Okay.
So yeah. Okay. So now that light ray is making its way there, you can clearly see the shadow will be straight as I've drawn. As I have drawn. So if somebody's moved up, they would be in the shadow.
And Ranty, as you do,
they would be.
Hang on. As you do to the children, all light rays from the sun rumpet emanate at tangential.
Be quiet, flat. So here we go.
They would be in the shadow.
Here you go, Ranty. So you're saying that this person here.
Well, no. What you're saying is that the light ray is going to hit two objects at the same time. You're saying that the light ray from the edge of the sun is going to hit the moon and simultaneously be able to be seen by the human on the Earth.
What's the problem? Why have you got this problem? Okay, I'll move it up here. There you go. I've moved it above the moon. Is that good enough for you?
No.
Hang on.
It doesn't matter. You're saying that the sunlight is hitting the moon, but then somebody else is also able to see the sunlight.
It's not hitting the moon.
It is.
It's not.
That's what's causing the shadow.
Moon, you twat.
That's what's causing the shadow. Hello.
Don't call the host a twat, Rumpus.
Boundaries. The boundaries.
Globe dead.
Ladies
and gentlemen, these are fatal errors that they can
hang on, Brian.
find a way around.
Rumpus. Hang on, please. Can I just ask a quick question? As we were all hang on, Rumpus. As we were all drawing the sun as children, right? Did we all draw vertical rays coming from the sun?
Twat. Right, so the area above the dotted line is the light is hitting the Earth. The area below the dotted line is hitting the moon and getting stopped by the moon. Why is that difficult to understand?
No, it's not. I'm talking about the light ray from the edge of the sun.
Yeah.
You have the light ray from the edge of the sun hitting the moon.
No, we don't.
Yes, you do.
Line.
The red line.
We don't. The red line is going to the Earth.
The red line is causing the shadow.
The red line. Yes, it's the boundary. So
that's the boundary. Yeah. So you've got the boundary. So how
he double speaks and he double draws.
I've drawn in the last line of the ray that can be seen from the sun that makes it to the Earth's surface. That's the line I've drawn. So in other words, someone here, where I've got this little pink star, they can see this edge of the sun following that red line, which has not hit the moon.
How can they do that? How can they see around it?
It's a dotted line, you moron!
The edge of the sun has hit the moon, but yet now what the edge of the sun is also hitting the light. How many light rays are coming from the sun?
Right. Someone kicked me out, Ranty, there. Someone kicked me out, and let me just rephrase the question before we... Rumpus, when we were drawing the sun...
Right, so let's get this sorted out. The red dotted lines
Rumpus, quit kicking people out, man.
Not being allowed to finish my point. So the red dotted lines are not hitting the moon. I'll say that again. The red dotted lines are not hitting the moon. Any rays below the red dotted lines will hit the moon.
So are they coming in parallel then?
Any...
There's a lot of kicking and going on.
He's got a fatal
right
problem because look how big he's got the shadow on the Earth anyway. He's double speaks and he double draws, folks, and he keeps kicking everybody out.
Right. Brian, this is the question I was trying to ask is when we're drawing the sun as children, we always draw the light rays emanating vertically from any particular point in the surface. Rumpus.
Okay, maybe I have time now for me.
Okay, go ahead, Yossi.
He's just kicking everybody out, dude.
Because you just kicked me out.
Oh God!
Because you kicked me out.
Children.
Because you're trying to prevent me from giving this explanation. You're not allowing me. You're not allowing me to finish what I'm saying. You're interrupting me systematically in an attempt to stop me explaining. I don't do that to you. I don't do that to you, so don't do it to me. And I'm trying to
30 seconds then, Rumpus,
I'm talking to Ranty, and I'm trying to explain to Ranty that the dotted red lines are ones that do not hit the moon, but one's just below. So I'll draw another line, and I'll make it green. That one does hit the moon, so it does not make it to the Earth. So I'll now remove that. So its green line hits the moon and it doesn't make it to Earth, and therefore it makes a shadow. So now you can see that the thing at the red star can see the sun, therefore it's illuminated. But if I go a little bit further in here, then I'm in the shadowed area where the green line would be, and it can't make it to the sun, therefore in the shadow. Why is that difficult to understand?
Is that the scale, Rumpus, that drawing?
It's not to scale because you've seen what I had to do to make it to scale.
So as you do it to scale, all of those lines are coming in, hitting the moon parallel, which means that
the moon shadow
should be the moon shadow on the Earth should be the same size.
They're not.
Let me just ask my question. I'm going to go.
They're not parallel.
Rumpus,
as I showed.
Let me ask my question. You shouldn't be tolerated in one sense. Let me ask my question. I'll go then. Right now, when we were all children, we were drawing the sun. We drew. God. Can I ask my question, please?
Yes,
go. Can you bear with me for that? Right. When we were all children and drawn the sun, we drew a circular object, and we had all ray lines coming at 90 degrees to the surface. Are you saying that every ray line goes in every single direction possible?
Yes. So in other words, let me draw that. So here I'm now going to draw all the light rays coming out of the sun. Let me just give that a nice arrow. I'll make it yellow. So you can't see that very clearly.
From that point.
So in other words, yes, exactly. So in other words, at any point on the sun, so if I move that here, this point on the sun, which you hopefully can see, is emitting light. Fucking thing. Right. Oh, you bastard. Why is that doing that?
It's a bollocks, Rumpus. It hates you.
Right. So.
Right. In every direction.
Let me just finish it. So a point on the sun is emitting light in all these directions.
Right.
Any one point is emitting it in all of these directions.
Is it being refracted?
Thank you for that
Not
clarification.
In space, no.
Just before I go, Ranty, thank you for that clarification, Rumpus. So all of the points, right, which are emanating towards the moon, will be emanating at every single point. So as it hits the moon and the moon creates a shadow on the Earth, we should get a horizontal shadow in relation to the image you've shown here, or a shadow the same size as the diameter of the moon. Why not?
It should be the same size as the moon as I've just
Why
shown.
not? Why would we not get that?
Because I've drawn this. I've been spending the last 10 minutes showing this. Because a position where this little star is, it can follow the red dotted line. It can see a bit of the sun. So therefore, this is not in shadow because it can see the moon. I can draw lines from the purple star to a bit of the sun. Therefore, this is not in the shadow of the moon.
Right, but moving back on, please. That's a particular point on the sun. Move down that point until it's parallel with the top of the moon, and it's shining in the direction of the moon. And then move every point between the top of the moon to the bottom of the moon, and then it casts a shadow on the Earth, and you will get the same size shadow.
only needs to be able to see one bit of the sun not be in shadow. It only needs to have this point which I've drawn. So in other words, if I move these, if I move all these things, let me just move all these to that point that I've got.
You have every point on the
All
sun's
right.
surface
Okay,
emanating in this direction.
Hang on.
Every point of light.
Right, let me try something different with. Let me try something different with you, Rumpus.
Off you go, Ranty. I'm gonna.
No matter what he says, it doesn't scale properly.
Okay, let me try.
Love you, Brian, and take it easy.
Well, I just the point. So this point
Our
on the
Stark
surface
is out.
is firing off rays in all directions, one of which just skirts round or just grazes the moon and ends up at the purple star. Jesus Christ, you're thick.
That's not very nice. That's not very nice.
Rumpus, no matter what you say, it doesn't scale. It doesn't
scale.
You can do it in degrees, you can do it in angular size, angles. It doesn't scale properly. Not even close, pal.
I don't know what you mean by it doesn't scale.
Okay.
Hang on, wait a minute. Hold on, don't say.
Of shadow.
Brian, calm. Listen, he said he didn't know what that meant. Guys, I mean, I think every single person in the audience, person in the audience understood what you said when you said that it doesn't scale. So when he turned around and said, I don't know what you mean, that was very stupid, Rumpus.
No, it wasn't.
That's what I was trying to demonstrate earlier, Ranty. I was trying to demonstrate when you get him on a snag, he has no common sense. He acts like he doesn't hear it or he doesn't understand. He does that every time.
You're never specific.
He's got no common sense.
Everybody understood what he meant when he said that it doesn't scale.
And I'm supposed to guess what the hell you're talking about. What scaling where?
Right.
How?
I'm going to ask the audience. One, if you know what he meant when he said it doesn't scale. Or two, if you have no idea what it would mean at all and would not be able to comprehend what he meant. So one, if you understood what Brian said, and two, if you think the Rumpus is right, that he has no idea what he meant when he said that it doesn't scale. Right?
And I've demonstrated up here, if you're going to talk about the scaling of the distances between the Earth, Sun and Moon, I've demonstrated here that it scales perfectly. I've demonstrated. So how you can say, does it scale, when I've already demonstrated it, if that's what you mean.
Give me 1 minute. Give me 1 minute and I'll explain that.
What do you mean?
Okay, I'll let you talk. Now, earlier when I said I'm going to ask Rumpus a question, and he's going to say, I don't understand, or it doesn't make sense, or he's going to just be quiet, or say it's gibberish. Okay, and then I asked the question, if we could see from the ground, we could see the Copernican crater, which is only 60 miles wide, okay, and then you look at the pictures supposedly taken from the moon's surface, and you can't even see the Andes mountain range, which is hundreds of thousands of square miles, and he did just that. He's like, and then Jim, or whatever his name, white knighted for him. Just now, you know the scale, what we mean is the shadow from the Earth to the moon, okay, and the moon shadow from the moon to the Earth. They do not scale during the lunar eclipse and the solar eclipse. They do not scale, okay? I think everybody knows what I mean.
No idea what you mean.
Well, the audience does. The audience does because the majority say one, so they know.
Yeah, I believe in understanding. He does not
no common sense,
what he means at all.
No. Okay, here's what I mean. Okay, if the sun, if the Earth is 24,000 miles, let's say it's 8,000 mile diameter, okay, and then it's casting a 70-mile shadow, okay. Now
you're talking. Are you talking about lunar eclipse? Hold on. Are you talking about lunar eclipse now?
Okay, let's just throw a random number out there.
About lunar eclipse or not?
Do you want to learn or not?
You describe the Earth's shadow, so you must be talking about lunar eclipse, I presume.
Yes.
Right, you didn't say that, did you, you twat? Jesus Christ, you are.
I'm saying both, you dumbass. I'm telling you both of them, dude. They do not scale.
What we're discussing here is now a lunar eclipse. Is that correct? Do you understand what a lunar eclipse is? In other words,
do you want to know the point or not?
No, you're such a bloody moron. There's no point. There's nothing to learn from you. Right. So when you're talking
either
about
you got no common sense, or you're obfuscating, one or the other.
Right. Well, maybe it's because Rhett Priestley's given a super chat. He says the Rumpus can't read. FE debate 1194 or listen to questions. He may have ADHD. Do you actually have ADHD there, the Rumpus?
Not that I'm aware of, no. I'm aware that this guy's an idiot. Whoever is continually talking to you doesn't even understand, and I has to have explained to them why the southern star can't be in the shadow of the Earth. And the fact that I've had to explain about 3 times to this twat and he doesn't understand just makes him a moron. So we don't care what he's got to say. So when you're talking about a lunar eclipse, and I bet you don't really mean this. God knows what you mean. The lunar eclipse is when we have this situation. Oh God, let me just ungroup this. So a lunar eclipse was going to be something. Oh God, let me just do this. So if this is the situation you now wish to discuss, so we can do that, and then we've got the Earth. It's not to scale, of course. Right there we have.
If you take the percentage, you can do it with math, Rumpus. If you take the percentage of the Earth that the moon's shadow is blocking, okay, and then you scale that. In other words, it doesn't matter that one's bigger. We're going to scale it. So size scales, okay? Then you take the percentage of the Earth's shadow that's blocking the moon, okay? So size, one bigger than the other. That's why we're saying the word scale, Rumpus. Okay,
well,
it doesn't scale properly.
So now it turns out that when you're referring to scale, you were referring to the size of the Earth's shadow as against the moon's size. Is that what you meant by scale?
Hello? That's what we've been working on for the past hour. We've been working on that exact thing for the past hour.
Because we weren't talking about a lunar eclipse, you
Yes,
twat.
we were.
No, we weren't.
You've just been drawing it.
We're doing a solar eclipse, and now we've changed to a lunar eclipse, and we're now talking about the relative size.
You've just changed it to the lunar eclipse right now. We've been talking for.
You're not listening to what this twit's saying.
We've been talking about we've been talking about the eclipse for the past hour.
Of eclipse, you twat. There's a solar eclipse that I was showing on screen, and now this guy wants to talk about the lunar eclipse.
Right, and. What's that got to do with it? He wants to talk about that now, but when he said that it didn't scale, it was with the other diagram, right?
Talking about the lunar eclipse. That's what he turns out.
Yes, it was with the other diagram, right?
He was talking about a completely different scenario.
So it was with the other diagram.
No, he wasn't. He's talking about this.
The other one.
So he's talking about this situation when he was talking about.
No, he wasn't.
He is. Brian, this is the one you were referring to when you're talking about scale, wasn't it?
No.
Yes, it is.
No,
Rumpus.
he was talking about the size of the shadow on the Earth cast by the moon.
No, he's talking about this scenario with respect to scale.
No, he's not.
Because you never understand anything, even a different idiot. Right, so Brian, you're saying that when you say something doesn't scale, you're saying that the shadow of the moon, shadow of the Earth in a lunar eclipse, you can indeed work out if you try to work out the size of if you know the size of the Earth, you can then work out, assuming some basic geometry, you can then work out the size of the moon, because you can work out what the shadow cast by the sun, the Earth is, and you're actually correct in that. If that's what you were trying to. Is that what
I made that calculator, and I sent the link for the video, which has the calculator for that.
So is that what you were saying, Brian? You were talking about how you can determine the size of the moon from the Earth's shadow. Is that correct?
No.
Let him answer, please. Don't be.
He was talking about the shadow. The size of the shadows of the.
Right. So, Brian, are you talking about the shadow of the Earth and the solar and a lunar eclipse? Is that what we're talking?
Okay. How about a little listen this time, Rumpus? Okay.
Is that what we're talking about or not?
No.
Okay. Okay, and Randy, he'll do anything to not have to answer this. Okay, if the Earth, Jesus Christ.
Rumpus, mute yourself.
Yeah, mute yourself for 1 second and let me get to the end. I'll make it quick. Okay, the Earth's shadow. Okay, the moon's shadow is casting a certain percentage of its size on the Earth. Okay.
Yep.
Let's just call it. Let's just call it 100%. Okay. Now the moon's shadow casting. I mean the Earth's shadow casting itself. It should also cast a similar percentage on the moon. Yet it does not. Okay. That's what I mean by scale.
Should it cut? Right, exactly. So there you go, Randy. He was talking about the Earth's shadow.
Randy was right, dude. What are you talking about?
Exactly. You didn't listen.
No, it was not relevant to the. Oh, you bloody morons! Right. So the scenario you're worrying about is that the Earth's shadow is somehow, you think that the Earth's shadow should be having the same size on the moon as the moon's shadow.
No, I don't think that. Math thinks that, Rumpus. Scaling thinks that.
But the Earth.
No, it's not with scale. No, I'm sorry, Rumpus, hold on. The size of the shadow is not measured by scale. The
Okay,
shadow
who's got a calculator? Do 70 miles equals
what percentage of n times? Hey, let's just do it by diameter to give you a break. 8,000. Okay, just do the percentage of that, and then convert that, then scale that to the moon, and it doesn't work.
No, it's not by scale. Okay, hold on. The smaller shadow, which is called the umbra, I think. The umbra.
I'm saying scale, so you can quit saying bigger and smaller.
No, well, hang on. Yeah, we know what we're going to say.
Scale.
Okay,
so you quit saying big and small.
Hold on. So what you're saying is the cone shadow that the rumpus drew before from the moon to the Earth is not correct.
Yes.
Thank you.
It's correct. I'm saying it's correct. But the size of that dark shadow is determined by how much is of a distance clipped from the original size. So you clip like 1,000 kilometers from the moon. You clip also 1,000 kilometers from the Earth when the Earth is casting the shadow. Something like that.
Okay, and if you do all that math, you will see that the Earth's shadow should only cover about a quarter of the moon. Okay, if that.
You are a moron. The
Earth, you are, dude. You got common sense of a rock.
Oh my God. The Earth is big enough to cover the whole of the moon.
Scale!
Right,
you
okay.
fucking idiot, dude. Quit saying big and small, okay?
Right, okay.
Quit saying big and small. Scale, you stupid fuck.
You are a stupid, utter moron. The fact you don't understand this basic geometry, the fact that the Earth is bigger and the moon is smaller, means that the Earth's shadow
genius.
will cover. Well, the angle. Well, okay, you could say that the angle. Okay, so the distance. The way you would do that is you would say that the distance to the moon. Where's this gone? What's this bloody doing?
Can you do me one thing, Rumpus? By the way, you know the other image that you had up with the sun hitting the moon, with the lines skirting past the moon.
Okay, that was this one going. Okay, let me just.
Yeah, this is my last point that I want to go to tonight. And we'll get to final thoughts.
This position here.
Yeah, that kind of position there. Okay, so if we get rid of the blue ball, right? So get rid of the Earth, right? And pretend that the grey one is now the Earth, right? So the grey one's the Earth.
Oh.
Get rid of the blue. Right, thank you. Right.
Okay.
So the grey one is the Earth. So there's the sun. There's the Earth.
And shrink that shadow too.
Right. No.
You
Just no. Don't. You don't have to do anything about the shadow. I'm just now talking about the actual sunlight that's hitting the Earth.
Right.
Because when you showed the diagram a couple of hours ago, and you were showing the parallel lines and how they spread out over the surface.
Yes, I
now
did
you've got all these lines.
I knew you were going to mention that. I thought that's what your original point would be.
Well, it was. I was getting back to that. So
here we are. This diagram here. I drew them as parallel lines, and I said that at the time.
Okay.
I'm approximating them to be parallel lines because it doesn't affect this.
Well, can I finish my point? So on this image here, so you've got obviously the sun on the right. So can you draw a yellow line from the top of the sun to the Arctic Circle?
Okay. So the top of the sun to the Arctic Circle, which is there.
Yeah, well, higher up.
Well, no, the Arctic. I've drawn in the Arctic Circle here.
Yeah, a bit higher up. I want it to that mountain range in the middle.
So you want it at the North Pole, not the Arctic Circle.
To the mountain range that you have on the screen.
That I've got at the North Pole.
Just put the line in, please.
Okay, it's not at the Arctic Circle. It's at the North Pole. That is the North Pole there. That is the North Pole.
So you put it in, right? Okay.
Which North Pole is it?
Now can you change the colour to yellow? So can you put that line as to yellow so it matches the other? So now what we have is we have more sunlight coming to the North Pole than what you drew originally. You drew originally straight,
not to scale,
parallel line.
Yeah, that's because it's not to scale.
Now can you go back to
not only that, he drew the shadow too big too. We all recognize that.
To finish the point.
Yeah.
If I now put this at the right place over here to scale, like I had it in this diagram here.
No, go down to that other image.
This is the one to scale.
The penumbra one. No, just go back.
Hold on. This is the to scale diagram, and you can see that the angle there is really tiny. It's 0.5 degrees. So this, because it's not, this is not to scale. This light ray is actually not going to be able to do what you're doing. It's almost identical with a parallel ray because it's only 0.5 degree difference. Just because this diagram's not to scale does not mean to say you can make the...
so you understand scales now, do you?
I understand scales perfectly.
You understand scales?
I understand scales perfectly.
Right. So here we have more light. This diagram, this original diagram that you drew, it's bollocks, isn't it?
You're a moron, Ranty.
The lines, the two lines that you had on originally, the bollocks.
It's bollocks. You moron. So the difference between this ray and there is only 0.5 degrees. It does not in any way invalidate this diagram. You are a fool.
Rumpus, it was bullshit. Even the shadow was too big. Why don't you just be humble? Hey, Sharky.
The fact that you think this non-scale diagram, you can start drawing these lines, somehow invalidates this. And I demonstrated at the time it's parallel, and I said to you that they were approximating to be parallel, but you don't seem to understand this is not to scale, and therefore if I move the sun to the right, it will be no different in effect to the argument I made here before.
Well, here's a challenge for you, Rumpus.
Can I have a go?
Yeah, well, yeah. I'll just leave my challenge out for Rumpus though, before we go off this point. Over the next few days, maybe a week or so, if you can to scale, use a program. Not this. This is bullshit. I mean, get sizes.
This is to scale. Everything in this diagram is to scale perfectly. The distance to the moon, the distance to the sun, the planets, this is all perfectly to scale. And the shadows to scale, the moon's to scale, and I've expanded it here. The distance to the sun is to scale, the angle of this ray is to scale. Everything is to scale.
Scroll into the moon and scroll into the moon. Okay. Scroll into the moon, please. I want to see those lines.
There you go. That is the shadow of the moon. You want me to move in here?
Yeah.
That's as far as I can zoom in.
Right. So you've done this. You've made this program, have you?
This drawing.
Well, this drawing. Right. Okay. And you say this is to scale. The size of the sun and everything.
Correct.
I don't believe you.
You're a moron. Who cares?
Well, anyway, and I still don't believe you, but I still believe that the shadow will be parallel.
In layman terms.
The shadow will be parallel. It won't be triangled like that.
It will.
No, it won't. I'm gonna have a go at performing this test in the back garden tomorrow.
I want to have a go at this.
I've demonstrated to you to scale what this looks like, and I've actually got the sun there. You can see this tiny angle that makes the distance. You're too stupid to understand it.
Bullshit! That is not to scale. The sun.
Hey, he'll have to talk over me, Randy.
Get the size.
Randy,
No. Get the size of that sun.
Eclipse, and there is no penumbra.
Wait a minute. Wait a minute. Hold on. That sun is not the same. Look at the Earth and look at the sun. The sun is only around about 15 times bigger than the Earth.
Fantasy.
What?
The sun is only about 15
His drawing
times bigger.
is fantasy, man. It's
about
not real
15
life,
times
man.
bigger.
Brian, let Ranty finish what he's saying. Again to Ranty.
Yeah, that sun.
Well, your drawing. Okay, I just want Randy to know, and everybody else that his drawing is fantasy.
Shut up, twat. Ranty, go ahead.
Right, that sun is not to scale to the Earth. No, it's not.
It is.
No, it's not. Stay still. Right, I've just taken a screenshot of that, and that's bullshit.
Don't get confused, by the way, that is not the moon to Earth to scale. That's a zoom-in box. The actual Earth is there. So don't get confused between that little blob there for being the Earth. It's not. That's a zoomed-in box.
He cheated that diagram in every way to favor his fantasy.
This is to scale. These are zoomed-in boxes. Do not get confused with these blobs looking at the Earth, which I know you'll do.
From the angle of the red line to the scale of the sun. Everything you could have done to shit on that model,
One minute.
did.
Ranty, I'm signing from my desktop, please. So I'm leaving this now. Coming from my desktop. Thank you.
Okay, see you later, Crow.
I mean, you're a moron. You don't know what the scale of the solar system is, so you've no position to say that's not to scale. You don't know anything. You're a moron.
You biased every point of that scale of that diagram. Every single point you biased it toward your fantasy, dude. That is not real life. Okay, now let me get this point out. You don't want this point getting out, okay? But balloons were set up during the Great American Eclipse of 2017, and ladies and gentlemen, there was no umbra, okay? In real life, that diagram is crap. It's meaningless.
I can show you a picture of the umbra here. If you look at this, where did I? Here we go. This diagram here shows a picture from space of the eclipse that happened over Indonesia, and there is the
like I said, fantasy.
Here's the penumbra. Here's the penumbra. Oh, bloody hell.
No,
There's the penumbra.
Like I said, fantasy.
And where is the Superman?
Rumpus, get that cartoon off the screen, you jackass.
It's a picture. Yes, reality. This is a picture. It was actually taken in the Indonesian eclipse. I think it was 2000 and I can't remember, 15 or 16 or something, or 17. Might be 17. And this is an actual picture from the Discover satellite.
Randy.
Hey, Rumpus, how do you choke a lawnmower? If you're trying to get gas in the carburetor, what do you do to choke the lawnmower? Just out of curiosity.
I'll bash it with you. I say.
I guarantee you, he can't start a lawnmower, folks.
Working. I'll set leaky brain on you, and then it immediately starts to work.
Yeah, I wanted to return Rumpus to reality, if it's possible. I will try to share the screen.
See, that drawing would be all fine and dandy, except they're considering the moon to be 1/4 the size, but they're not considering the fact that you're only seeing half the Earth, so 12,000 miles, so it would be blocking more than that. They always make little mistakes, man. All you got to do is scratch past the surface, and you get over their fantasy. So let's join heads, let's join minds, and figure out what shit really is, instead of this argue about fantasy.
Come on, Khaled. I thought you were sharing here or something. What are you saying I've got wrong?
World. Excuse me, Joseph, go ahead, bud.
Khaled, what are you saying I've got wrong?
No, I wasn't saying you got wrong, but I wanted to try to explain it from another way, so I'm trying to make a diagram.
Okay.
But I'm not sure how to share it yet. So is it okay, Randy, if I want to share it?
Yeah, we're sharing. You can see your screen now, Khaled.
Yeah, you're sharing now, yeah.
I'm sharing, actually. Okay.
Yeah,
so,
you're sharing.
Here is something not to scale, but just to explain the concept. This is the sun here on the right side, and the moon in the middle, and this here on the Earth is.
We're not seeing any diagram here now, Khaled. You're sharing the wrong window. I think you're sharing a window where it says It says please run IV cam. You're not showing.
That's the Skype. That's the Skype.
Oh.
Yeah, just minimize that box that says Skype. Minimize the Skype box. Yeah, go up to that box there.
Okay, so how to share?
Yeah, you're sharing screens now. Just minimize the box. So you see where it says Skype?
You're sharing the screen. Yeah, you're sharing the screen. It says please collect comps later.
Yeah, just minimize.
Are you showing your whole window? Is that the problem, Khaled? Do you not want to pick a particular window?
Right.
You're showing your whole window, I think.
I didn't attempt to share anything. You're telling me that I'm sharing, but I didn't do any attempt to do that.
Right. Right, Yossi. You see what we're seeing now? We're seeing, you're moving the cursor around over your Skype at the minute. So if you go up to the little minimize screen at the top, no, up above where it says Skype 1. See where it says Skype 1? Yeah, minimize that. Yeah, press that. Right, and now we can see what. Yeah, now we can see what your main screen shows.
Oh, thank you.
Yeah, you're showing your whole. You're showing your whole screen, not just the window.
Yes, that's okay.
Yeah,
it's okay. I'm showing you now what you see in real life. This is atmospheric lensing. What you declared at the beginning that doesn't exist. Look at lights.
Yeah, that's. Well, that's
Josie, have you ever seen this? Josie, have you ever seen the moon on the horizon during what we call a Mortal Kombat moon? It's like during September and August, the hotter months where there's more vapor in the atmosphere.
That's a vertical effect.
And have you ever seen the sun where it's like sometimes it's scary big on the horizon? I mean, scary big. Okay, they try and use the argument. Look, let me bring you some
You're a
reality.
moron.
They
It's
try
a
and say
vertical-
through a filter. Okay, first
It's
off,
a
just let me
vertical-
finish.
you can get-
Let me
I said
finish,
you can
man.
get vertical. I'm answering his point.
Okay, I'll
can
give you
get
that. Okay,
hold on,
okay, I'll give you
dealing
that. Now shut the
hold
fuck
on,
up
I'm
and
dealing
listen.
with his point. The vertical compression, you can have vertical compression and you can have vertical extension. That's not the same as lensing, you twat.
Okay,
Moron.
now
Go ahead, Brian.
they try and use angular size, okay, of the sun as the #1 proof of a globe. A, it's angular size, okay. So, and B, they only show 1 day, and even what they show changes angular size. C or D or 4 or 5. What about a damn sundog? And you got 3 little suns up in the air. What's that through a filter, genius? Dude, you have lost grip with reality, bro.
No idea.
Okay? None of your arguments, all your arguments are on paper, bro. None of them are real world.
Rumpus, you should, he have right. You should go out more and calculate less.
You should learn more and actually learn a bit about science.
No, you
You're
should
clearly
go out
ignorant.
and meet the real world.
Yeah, I do.
No, you talk about
You
fantasy
know
land.
nothing. You're a stupid
He
moron.
do.
You're a moron.
You do. I
Yeah,
don't.
you're a moron.
You are a
You're
liar.
a moron, we know
What
that.
are you?
Rumpus, you not only double speak, you double draw, you double speak. I mean, dude, get in reality, man. You're the best. I mean, you're one of the best recruiters for Flat Earth, man. I'm telling you, you and Brent are the reason I even looked into it, dude. I was like, why would he lie about that? I mean, it's just, dude, you're smart on paper, man, but your arguments are fantastical, man. They're fantasy, bro. You can't even. And then I try and use your math, your strong point, to take you out of this spell, right? You're in a spell, right? So I know you're good at math, right? So I try and use math to break your own spell, right?
Science.
And I say, okay, he's good at math. Let me show him how horribly off the scale is. But your brain can't get out of big and small. The scale does not work, man, between the lunar and solar. Okay, it doesn't work. It's not even close, bro. Okay, there are certain things the math can't explain, bro. But your diagrams are not real, bro. They're not real. Okay.
It all works.
Look how the sun is changing size. Look now. Learn something from real life.
According to your model, if we have the right angle, okay, in the winter time, then we can get a sunburn in 5 minutes, dude. Okay, and you go through all this 10-minute bullshit explanation instead of just saying, the sun's closer in the summer. The sun's closer, so it's hotter. Simple shit, dude. It's common sense, dude. Fuck the numbers. Common sense, man.
You have less understanding what's going on around you than a Neanderthal.
Yeah, we see, Rumpus. This is
Dude,
why
you got no common sense,
I'll tell you what, Rumpus. I've got a question for you, right? So we have total lunar eclipses, yeah.
Yeah.
Okay, so the Earth can cast a shadow that completely envelops the moon completely, right?
Yeah.
And it's all in the umbra.
Well, it can be in the penumbra as well.
The total eclipse is all in the umbra.
Yeah, because by definition of a total eclipse, then the moon has.
There is no penumbra.
Right. So.
Oh Jesus.
So
if you're talking about a total eclipse, yes, you can have all sorts of eclipses, but if you're talking about a total eclipse, then yes, it has to be inside the umbra. Yes.
Okay, so if the moon is about a quarter the size of the Earth, right?
Yes.
Okay, so if the shadow that the Earth is casting over the moon, because they're the same distance away regardless of which way you switch it, so it's a quarter the size. That means that the shadow that the Earth casts has to be at least a quarter the size of the Earth to cover the moon in its entirety. Yeah. Right, okay.
Yeah.
So we know that we've got a percentage, at least 25% of the Earth to cover the moon, right? So we know that scale works. We know that scale works, right? So when we flip that around and we say, okay, now we'll just shadow the moon. We'll put the moon casting a shadow on the Earth. Well, if we've already got a scale and we already know that 25% is a ballpark figure. Hold on, just let me finish.
No, you're wrong.
So hold on, just let me finish. So work with me on this. So the shadow, so the moon will cast at least a 25% umbra shadow, because that's what the Earth can do. Because that's what if the Earth can do it, then if the Earth can do that, then the moon should be able to do that too. And all you're doing is just flipping them around. So if it's casting at least 25% of the same shadow that the Earth would cast on the Moon, we're looking at substantially greater than 70 miles.
Well, I don't know what
It's
I haven't
logical.
actually done the maths to work out exactly what the size of the Earth's shadow is on the Moon. I'd have to go and look it up, or at least calculate it geometrically. I mean, I could do the maths. It's a bit late. It's too late now. I tell you what, when I come on next time, I'll do the maths and I'll work out exactly how big the shadow of the Earth is. Then we'll work out. Who's running around outside and crunching things? Jesus Christ!
Sorry about that.
God. Yeah, okay. Next time I'll go and do the maths. I'll tell you what, and then I'll work out how big the Earth's shadow is and compare that to the Moon. And I would have thought that it would have been. I don't know. Yeah, I'll have to go and do the. I'll have to go and do the calcs on it, but I haven't got. Yeah, it's too late now for me to go and do it here. But I'll go and do the calcs for next time.
I've already shared the video with a link to a calculator that I made. So, but now I'm ready to share my screen. But I did all what I can, but it's not sharing.
Hello.
Hello.
Yes, I'm trying. I did all what you said. I'm sharing an application.
I see it.
It's not working. No, I'm showing a diagram, but I see a video playing on the screen.
Yeah, I don't know whose that is.
That's
I was
dickhead.
playing this because Rumpus stopped my share screen. I wanted to show him the sun changing.
Oh my God!
Size and the moon.
How many times do we explain to you need to have a solar filter? We've had a whole discussion about this in this hangout.
Moron.
You've just ignored the whole point.
Moron.
And the change in size. You've just ignored it. Amazing.
Rumpus. What's a sundog? Hey, what does a sundog look through a solar filter? What's a sundog look like through a solar filter? The 3 different suns. What's that look like, genius?
They won't appear.
Just because you're using a filter don't mean the angular size is real life. It's angular size, meaning not actual size, stupid. Okay, a sundog gives you 3 different filtered suns, man. Y'all need to drop that argument, man.
Too stupid to talk to. Oh my God. If you think the angular size is changed or incorrect when you look through a solar filter...
You're trying to use refraction with the eclipses, dude. Everything you say is wrong, dude.
No,
you're trying to use refraction with the eclipse. What does that look like through a filter?
Stupid to talk to. You really are. If you think the angular size of the sun is incorrect when looking through a solar filter, then you're just too stupid.
Okay,
Rumpus, it changes, dude. It changes.
No, it doesn't. Wow. Even flat Earth videos have done this. Demonstrate it doesn't. There's no evidence of. You go and find someone.
I've got my own videos, man.
Hold on, Brian. With a solar filter, where someone's used a solar filter, you show us a video of someone using a solar filter. And the change of the sun changes in size.
Wolfie done.
Rumpus, I can think of a few, okay? But I got my own pictures, okay? The sun is scary big on the horizon, dude. Okay, sometimes, okay? Rumpus, have you ever seen the moon from high altitude? Don't lie. Let me tell you. Let me fill you in, okay? It's small. It's tiny, dude. The atmosphere is what makes it look so big. The moon from high altitude or even from airplanes is not the same, bro. It's not the same.
Agrees with you in science, or anyone who's made an observation agrees with you. You've just made that up.
Oh my God! What Pete showed earlier was genius, man. That was. But all you have to do is look up high altitude pictures of the moon. It's a tiny little dot, dude. And that's why we get a 70-mile shadow. Sometimes the shadow is only like 30 miles, dude.
No one.
Okay.
With you.
Maybe they are not zoomed in.
Yeah, exactly. Unless you're zooming in.
Why does this? Why would if you're using the scale you're using? Why would this the eclipse shadow go from 30 miles to 70 miles? Okay, you got it the way you got it scaled. And I can't wait till you do that scale and scratch your head. I can't wait to hear your bullshit, dude. Because you're not going to be able to get around it. The scale doesn't work. I've already done it.
Why does it go from 30 miles? I don't understand what you mean by it goes from 30 miles to 70 miles. What are you talking about?
wide width.
Okay,
the width
well,
of the,
yeah, the diameter. So here we go, Rumpus. The diameter of the moon's about 2,100 miles. Yeah, something like that. 2,100 miles, say roughly. But yet it only casts a shadow about 70 miles across. Well, we've already done the mathematics to show that the Earth can totally eclipse with its shadow the moon, which is only 1/4 the size. So it only needs a shadow a quarter the size of the Earth to do that.
Even after you inverse it, it still don't work.
So
I will go and do the maths.
So if you apply
Crow said he's done it already.
Yeah, well, this is when he said it doesn't scale. This is what he meant. When he said it doesn't scale, this is what he meant. And it doesn't scale. You can't get a 70. You cannot perform the same logical steps with this is the shadow that the Earth casts over the moon. You would also expect the same shadow to be cast from the moon, percentage-wise, scale at least, and it would create a bigger shadow than the one they said, 70 miles across.
I will go and do the counts next time. I can't be bothered to do it now. It's much too late.
It's not even close. Even if you inverse it, square it inversely, it still ain't even close, Rumpus.
I will go and do the count tomorrow, and then come back to you.
Okay.
I cannot be bothered to do it now.
Well, I better do a show tomorrow. Right, listen, guys, I'm going to do final thoughts. So, Brian, do you want to get your final thoughts in first?
Yeah, final thought. Sorry for the language, and it always gets. It's fun to me, you know. It always gets, but everybody eventually gets their points out and everything. I think we should practice on our behavior a little bit. These shows tend to get a little wild with Rumpus, and even with me sometimes. But I think we should keep the debate going. And Rumpus, I think you need to try and open your mind, at least consider some of this shit, you know, and just don't, you know.
I consider the flat Earth, and then I dismiss it. Sorry.
Okay.
But I will say, Ranty, you got a very fair platform, man. You know, to me, anybody could join. I'm an everyday guy, man, and I don't know. Other than that, man, I'll hopefully see you tomorrow.
Okay, Crow XE, do you want to do your final thoughts?
Yes, just I sent a link to the video for calculating the umbra of the moon or the Earth, and what I want to say is the size of the umbra should be smaller than the object. And it's not percentage, it's a portion that is being clipped, like a specific distance. So we clip like 1,500 kilometers from the moon, and that's also what we do with the shadow of the Earth. We clip 1,500. I'm not sure of the numbers, but
yeah, Crow,
that's the idea.
Crow, are you just in case, do you know that does the umbra of the Earth completely is that bigger than the moon? Do you happen to know off the top of your head?
I have the calculator in front of me, and yes, it's okay. 9,342 if the moon is 370,000 kilometers away.
Okay, so you're saying that the umbra of the Earth is bigger than the moon. Okay, all right, I'll go. Sounds okay. I'll go and check.
Do the math yourself. That ain't even fucking close, dude. Do the math yourself, Rumpus. After this show.
Okay, listen, let's not go back into this. Final thoughts, Rumpus, actually. We'll get into Rumpus's final thoughts.
Oh dear, the display of idiocy on here, particularly by Leaky Brain, is just extraordinary. And the fact you seem to have such trouble just understanding where shadows... I mean, I had to explain to you, for 10 minutes just to get you to understand where shadows form, and you had problems...
I do!
And Ranty, just as bad. I mean... You really need to recognize that you're having problems with basic geometry and understanding science and maths and things. That's it, really.
Yossi, final thoughts?
Well, I really didn't have time to speak much, even if I'm not able to speak very well, but I have really good evidence. I suggest, well, like Rumpus dismissed the flat Earth because the horizon doesn't rise to eye level and he doesn't accept the atmosphere. We know the air is not atmosphere for him. So I dismissed the ball. He threw away the flat Earth model because of the stupid not understanding, and I throw away the ball because I can not see the edge ever. So. Okay. We are at the same position there. And second, I want to go more out and let's calculate and sit in the room and reading some indoctrinated, falsified book, old books, and nothing. Thank you for the platform, and
well, if you want to come on tomorrow, come on tomorrow first thing, you can do a bit of a presentation. We'll have a half-hour, 40-minute chat, just us two, if you want.
Yeah, cool.
Okay, so I'll give you something to plan ahead for if you want.
Thank you. Okay, see you tomorrow then.
No worries. Right, guys. Well, thanks everyone for stopping by. I'm going to leave the Skype call now, so I'll speak to you all probably tomorrow. I'm going to end the show right now, but yeah, thanks guys for stopping by. That's me left the Skype call. I hope you enjoyed the show. It got a little bit hectic at one point. I was pulling my hair out at one point as well, but that's to be expected. It is some of the characters that you get on here. That's what you expect. It's a bit of a free flow, to be honest, at times. So trying to moderate things like that, it can get a little bit tricky. Just got to do your best as best you can. So I don't want to stop the flow of the show, but then again, I don't want things getting too out. So that'll do. So I will do a show tomorrow night as well. So tune in for that. We'll have Yogi on first doing a little presentation, and hopefully the Rumpus will come back with his Umbra size for the moon. That should be very interesting. I think we'll be quite shocked when he actually does the mathematics figured out that it doesn't compute, it doesn't work. But we'll see with anything about that. Anyway, everybody, thank you very much. It's been an epic show, 5 hours, and yeah, really good. Right, okay. See you all in the next one, guys. Take care.